Hi everyone, good morning, good afternoon, good evening, wherever you are in the world. Welcome to the Global AI Student Conference. I'm Fotinisa Vidou,
And I'm Loxley Kolakowski.
and today we will be your host for the fourth edition of the Global AI Student Conference. Before welcoming our first speaker, let us introduce ourselves. So, I'm based in Greece and I currently study electrical computer engineering at the Aristotle University of Thessaloniki. I love connecting with students and sharing my experience in AI and Azure technologies. I'm a member of the Microsoft Learn Student Ambassador, the student community of Microsoft, and I'm also a Microsoft MVP in the AI category. This year, I actually participate for my third time in the Global AI Student Conference. The last 2 years, I was a speaker, and this year, I am pleased to co-host this outstanding conference with my amazing colleague, Loxi. Loxi, would you like to introduce yourself?
Yeah, thanks so much, Fatini. So, hello, my name is Loxley Kolakowski. This is my fourth time participating in the Global AI Student Conference and my third time as a co host. It's actually the very first time that I've helped co host this in person, and I'm super excited to be doing this here today with Fatini. And so, a little bit more about me. I have some prior experience working as an intern at Microsoft. I was a past Microsoft Learn Student Ambassador and at Accenture and Major League Hacking. I've also had the opportunity to work as a data scientist intern at a startup and love working at the intersection of students and AI. Now, a little bit about the Global AI Student Conference. So, the Global AI Student Conference is an online event organized by the global AI community with Microsoft Learn student ambassadors. It is designed specifically for students and for everyone to give an introduction to the world of AI and to learn from students and educators from around the world and learn about the projects they are doing in AI.
So today we'll hear from Microsoft Student Ambassador, MVPs, and leaders for both the academic and the technology AI space. We'll be covering topics from low-code development using Power BI, machine learning from green tech, and using Azure services in machine learning, Azure cognitive services, and AI projects.
And we also have some really exciting opportunities for you listening in today. You can participate in our Cloud Skills Challenge. The link is on the screen, but you can also find it at aka.ms/learn challenge. You can also earn a learning badger at aka.ms/gai badger. Finally, please make sure that you adhere to our code of conduct. And with that, we're ready to introduce our very first speaker. Kanchak, are you online today?
Hi.
Hello. It's so
Yeah,
nice.
I'm online. Hello.
Yes, good morning. It's at least morning for us. And we're super excited for your
Yeah,
talk
it's
today
good.
because you'll be doing an introduction to
Yeah, I'm
Azure.
also I'm super excited to be here too. I'm really hoping you can all see me. I'm really excited. So hello everyone. Hello world. Can I begin?
Yes, yeah, feel free to take it away.
All right. So I believe my slides are visible. Guys. All right. So introduction to Azure Cognitive Services in the Power Platform. Hello everyone. Yeah, they've introduced me already. I will do the further. I will take it from here. My name is Panshak Jeremiah Koproda. I am a beta Microsoft Learn student ambassador. I'm actually a Power Platform developer. I have a whole bunch of passion for it. I have a certification, fundamental certification for the Power Platform. What other things do I do apart from Power Platform? Yeah, I am a video gamer. I am a dog lover. Yeah, I know a lot of people can relate. I am passionate. I am a passionate public speaker. I love public speaking. And most importantly, I am a die-hard Manchester United fan. Okay, these are my socials. You can connect me on Twitter and LinkedIn. Today we'll be talking about I'll be giving you an introduction into the community services on the Power Platform. Um, First, we're going to have an overview. This is the rundown. I'm really excited to see how I can actually take us through all this. Our objectives, yes. Our objective is actually at the end of this session to be this man, Tony Stark, the Iron Man. Yes, we are trying to see, are we talking about automations, AI? And at the end of the session, we are looking at building Jarvis itself. So, what is cloud computing, Azure in brackets? Well, this is the first thing thing that comes to mind. I am sure cloud computing is has nothing to do with this. Cloud computing is simply the medium by which we share computing resources over the internet. In an introduction to Azure, Azure is a cloud computing platform. It also confers with Microsoft goal to empower each and every one and every organization to do more. This actually works on a pay-as-you-go basis, and one of the unique things about Microsoft Azure is its presence globally, which actually helps you access your data faster, helps you scale your businesses and solutions. Azure AI as we know, our world is tilting on the hinges of new technology. One of those is artificial intelligence and cloud computing. Well, Azure AI gives you the power to actually build on those two powerful technologies, combining the power of AI and Azure, the cloud. Like this actually helps you expedite your processes and the actually makes you build much more intelligent solutions faster. The Azure Cognitive Services. Azure Cognitive Service has a subdivision. This is where this is a collection of resources majorly that actually empowers your applications to see, to hear, to speak, if possible, to search and understand human or cognitive related what should I call it, materials or such, or cognitive related data. So these are the major subcategories of the Azure Cognitive Services. We have speech, we have language, we have vision, we have decision, and we have open AI. We're going to look at computer vision later on in this session. AI in the Power Platform. In Power Apps, you actually have the AI majorly in the Power Platform has its feet in four of the three of the five legs in the Power Platform. We have Power Apps where you have the AI Builder. We have the form recognizer, which is a form of is also an AI powered tool, an AI powered feature in the Power Apps. We have object detection, sentiment analysis, text translation, key phrase extraction, business card reader, and receipt processing. In the virtual agent, we use the conversational AI, which is used to power the chatbot we use for Power Virtual Agent. Power BI, we have image tagging, language detection, sentiment analysis, and key phrases. This is also embedded in Power Query to help you to enhance your data preparation for the data analyst that we have in the house. We have Power Automate, which actually mirrors what we have in the Power Apps. Then we have Power Pages. Nothing has been, but I'm hoping, I'm really excited about this because I know a lot of things will have to be done about Power Pages. Now, Azure Cognitive Services in the Power Apps example. Now, this is where we build Jarvis, guys. So stay tuned. First things you have to do is go to your Azure portal. You simply go there and you actually create a resource. As you can see, then moving forward, it actually takes you to this page where you can actually type your computer vision or whatever cognitive service you want to actually work with, object detection or whatever. Well, there's a resource group for cognitive service separate that comes with everything. But if you want to work with it individually, then it's cool. One of the most important things you need to know about the cognitive service is that it is actually just a it's just one API call away. So traditionally you will have to go through a lot of processes, write a lot of lines of code, but you can actually do this with low code. Empower your apps with the power of artificial intelligence, cognitive artificial intelligence, Azure Cognitive Services. Everyone. From there, it takes you to this page. You click on create to create your resource for the computer vision. Then you create after that it takes you to this page where it asks you series of questions, your subscription, your resource group, your region, and of course, as you can see here, I named my computer vision app the function. I call it my Jarvis. You're going to move out to review and create. It brings you here. It's going to begin to deploy, and when it's done, it shows you that the validation process is completed. Then you click and go to the resource group, which is where the action and all the fun stuff. This is where the fun stuff begins. So we actually go to the resource, of course, and when you land on the resource page, it is important that two things are very key. You have to go to where you manage your keys. These are details about the resource group you've created and you have named. And it actually when you click on manage keys, it actually takes you to where you will actually get your keys and your endpoints. These are very important. We're going to use these when we are going transitioning into Power Apps. From here, we come to the Power Apps portal. You click on create and you click, of course, you're going to use it in a blank canvas app. You're going to use a tablet if you want. When you're here, next thing you do for you to power your application with the what's it called, with the power for the Azure Cognitive Services, you're going to make a call to the API endpoint. You're going to do that how? You're going to click on what's it called, the data tab here is actually going to open up, and it's going to show you a place where you can actually just click on add data, which is what you do traditionally to bring data into your Power Apps. But in this case, you're going to actually go to your data sources and type computer vision. It will actually complete, and you can see the computer vision API over there. All you need to do after this is click on it, then it will bring you to this window where you can actually put your account key and decide URL. This is where the keys we got in come in place. We just paste it here and we paste the shape or the endpoint URL here. Then we click on connect. It does that, and voila, guys. For those that are actually conversant with the Power Platform, you can simply just go add a component, then write a few lines of code, and you are building a business solution that has the ability to hear, to speak, to translate, to analyze, to understand, be it turning text into digital text. Guys, this is just awesome. I really want you guys to jump on this. I am learning. I would like to learn with you as well. You can connect with me on my social media handles, and we can actually, these are the links we are going to be using. You, if you want to learn, you have the one for Azure Data Fundamentals, Azure Data Azure Fundamentals, Azure AI Fundamentals, and most importantly, a series of free certifications, including the Microsoft Fundamentals Power Platform exam for students. Guys, I really like you all to jump on this. I remain myself, Pancho Kopruda, and thank you very much.
Yeah, thank you so much, Panchak, for that amazing introduction to the Azure Cognitive Services and the Power Platform. Maybe a couple questions for you because we have
Thank
time.
you.
And the first one is so you showed us some computer vision. Have you experimented or explored with any other cognitive services in the Power Platform?
Yes, you have, or you also have object detection, you have language to speech. There are a lot of things, yeah, but I actually love computer vision because I really want to work with something that can actually see, and that's it. But I've experimented with others too. Yeah,
Amazing. And even I know computer vision is actually one of my favorite applications of AI as well.
yeah.
Are there any specific use cases for computer vision, image detection, or object detection that you've explored?
Yes, I'm actually at the learning stage right now. But I built an app that can actually take inventory. So this is how it works. You have someone bring in inventory for his grocery store, as you guys call it. Sorry, call it supermarket over here. Then you actually, so the manager or the person that is in charge of taking the inventory will actually have a database where all they need to do is use their phone, which is the Power Apps they've built. They just snap the stock that just comes in. Then it actually automatically detects, okay, this is an apple, this is a crate, these are just crates of eggs, and it just sends it to the database so that the person that's at the help desk can actually see, okay, these are the things we have in store. I mean, it's a very big supermarket. It's very tough sometimes to know what's available and what's not. And you actually get updated constantly to tell you, okay, these things are out of stock and stuff. So I hope I really answered your question.
Oh, yes, yeah, you definitely answered it. Thank you so much, Panchak, and thank you so much for coming on our stream today. We will let you go. Have a
Thank you very much.
fantastic rest of your day, and we're going to go to a short break before introducing our iShare donation platform.
Hi everyone, and welcome back to the Global AI Student Conference. In our next season, three students in the Data and Cloud Administration, Jerry Lee, Andy Lam, and Hohlai Liu, will show us how they've built a donation platform using Azure Cognitive Services. Hello, welcome to our studio. How are you?
Hello.
Hi. So, we would like to know us better. Jerry, can you go first? Who are you?
You go
Can you
first.
can you tell us a bit about yourself?
I'm Peter. And
I'm Andy, and we are from Hong Kong Ivy. Now I study a year 2 cloud and data administration student.
That's great. So, the next one, Andy.
Yes, I'm Andy. Yes.
I'm sorry.
It's okay.
So, the next one, Jerry. Can you hear us?
I think the final one is Jerry. Would you like to introduce yourself?
Maybe it might have some technical problem.
Okay, that's fine. Don't worry.
Then we will do an introduction for you. First of all, you are all
I'm
extremely
from the STEM school, STEM. Yep, Hong Kong Ivy Cow.
awesome. Well, it's nice to meet all of you. And first of all, I just want to do an amazing introduction. At least 2 of you are Microsoft Learn student ambassadors, and you have at least 14 Azure certifications between all of 3 of you, which is absolutely amazing. And with that, I'll kick it off to Fashini to introduce your talk.
So, today you are going to present your donation platform you've built using Azure Cognitive Services. That's amazing. Can you tell us a bit about your platform before presenting your own presentation? Or you can just share your screen if you want.
hello everyone. Today we will share our project iShare platform. Next page, please. Since the COVID-19, school in various countries have changed from the face-to-face to online. The underprivileged students do not have a PC computer, a notebook, or internet connections. Some charities have large all PC donation campaigns. However, the traditional donation model has a limitations. Next page, thank you. To solve the problem, we decided to build our donation website platform. The concept is shared economy, which involves short-term peer-to-peer. Transition to share the use of idea assets and share surface, or to facilitate collaboration. The donation website platform appear as an online marketplace like Airbnb and Renewable to connect the people who want to donate their new unused or used equipment with those who need it. Next page. The objective of this platform simplify donation to make the donation process quick and simple. We are implementing the Azure AI function to improve the performance of the surface. To benefit students in need, the system is scalability to develop various surfaces to meet the students' needs. Okay. We are accepting donation items, including the headsets, webcam, mouse, keyboards, tablet computers, smartphone, routers, laptops, and desktop. Uh, for for here, we are thanks to Microsoft who sponsor the free license and the use of Microsoft Azure to us. Next page. Okay. To clarify the design of donation system, we spared for users group which are teachers, donors, students, and volunteers. Based on the user group, we spread form a major part of the system. The central part is according to the users need to define the surface. We are deciding a table to spread the function for the student's role. Registration, applied, edit, review technical support request for the reply application. To effectively the donation process, the page will display the three major part for the teachers to understanding the detail of the function. Registration, approve the student account, review and approve item request. Okay. On the donor page, we spread the application and management function. Registration, donate item, review the donate record. The volunteer page has two sections. Page support request is for a volunteer to select the student case and pick the date and time to meet up. Review the support record is for a volunteer to follow up on the case. We have our own registration system that can prevent personal data leakage and prevent the hiding people who really need it. The personal data of 4 user roles will be encrypted and stored in our database. Next frame. For the register of teachers, they need to submit their staff card or their photo to prove their identity information. Once complete the application, our admin will verify the school website or phone call them. A student needs to register by their school email with their student card and just wait for the teachers to verify the application. Next. Okay. For the registration of donors and volunteers, they just need to submit the application and upload their profile photos. In the next part, I will pass to Jerry.
Thanks, Peter. And now will be the session that show how does it work on the student side. Student need to create an item request, submit the item you need, and share the story for your background. Also, you can review the history of the item request. This is the image if you fill the request if you click into the history. If something you want to change or decline the request, you can edit your item request. Once the donor accepts the request, you will receive the donation details via email. If students have any technical problem, they can ask the question for help. You can review the question history here and edit the details just like the item request. Also, you will receive the support details via email. Last, when finishing all the procedure of donation, students need to write a thanks letter to appreciate the donor. Now let's switch to the teacher side. The duty of teachers is to approve the student application. Once the student applied, teacher will receive an email. Teacher can refill the item request here. Approve the request if it is a pre and teacher can refill the item request history for the donor. Donor can add the item on Azure platform, which can add item status and upload photos. After enter the item, the AI will calculate and match if any item request. You can pick a student where you nearing. Receive the donation details via email. And we fill the donation history here. When all set, the donor will receive the translator from student. Last, the volunteers. You can pick the question that the student asks here. Receive the support details email. You can refill also. Also, the translator student send. There is an email notification for all of the requests. In the next part, I will pass to Andy.
Thank you, Jerry. In this part, I will talk about the technical details for our donation systems. Next, thank you. This is the AI service we are implementing into our servers: text analytics, form recognizer, content moderator, and computer vision, translation, and face API. This is the video to demonstrate the moderation application and extra ID card data. To reduce human error and fake information providers, we are using Azure Face API to analyze the face in the image to verify locations and check the face index. For example, when the student or teacher upload their photos, student card or teacher identify card into the system, the Face API will detect the perceived face features and attributes to check the likelihood that two faces belong to the same person. And then the form recognizer will extract the data after the user completes the restoration. It detects and posts text and layout of the documents. Also, turning documents into variable data, such as student name, student ID, and school name. The content moderators and computer vision will review all of the text and image content submitted by the user to fill out the unwanted content. And now let's show how to use the Azure AI to match the student and donor. As you can see, you can plug in the writing on their side, and the donor can see that on our map. Okay, next page. About the KPI of donation, the Azure test will extract exclusively and understanding text from the thank you message. The Face API will analyze the phrase from the image by using preference and emotion recognition to indicate the donation is a success. And this video is show how to use the AI chat box. As you can see again, just put in your letter and it will share to the donors, or or the support volunteers. Okay, next, thank you. We have successfully deployed the system on Azure Cloud. For future deployable, we will improve the system performance, such as increase the accuracy for matching, improve system efficiency, reduce manpower of answering questions, and reduce manpower for checking unwanted content. Therefore, we would like to promote the platform to the world and solve the global problem. And this is the end of our sharing. Thank you for listening.
I definitely learned a lot, and I loved how your project was specifically about like inclusion and making technology accessible to the entire world. And I especially liked this very end where you talked about the AI applications in your project. And I think my very first question is, how do you see your project transforming as our world turns to a more hybrid in-person approach? Might ask that question again. Can you hear me right now?
Can you may you speak again?
Yes, I can say that question again. So,
Uh,
first of all, I'll say like it was a fantastic presentation. I think my question was, how do you see your project transforming as our world turns to a more hybrid in-person approach? I can also pivot. I have a second question as well, and it's on the face verification technology. So how do you verify like the identity? Do you do it immediately or you wait until after like they've taken a photo and like they've donated the technology?
we are using the face AI function of the
Yes.
Microsoft Azure Cloud.
And then for the face AI function, do you compare like the first picture they take in their profile with the second picture they take when they like exchange the technology? Or is there like a database where you compare all of these images to verify it initially? Well, there might be some technical difficulties, but that
Yes.
is okay. We thank you so much for coming on this. I think it's late for your time. So thank you so much for coming on to our show. And then I think we'll head to a quick break before kicking it off with an AI voice assistant using Python talk.
Hi everyone, we are back at the Global AI Student Conference. For the people that have just joined our live stream, we have two exciting opportunities for you. You can complete our Cloud Quiz challenge at ak.ms/learn-challenge, which is a collection of learn modules about AI. You can go to the website and complete the collection of the learn module that we have selected for you to sharpen your skills on AI technologies. By joining our Cloud Quiz challenge, you will be on a leaderboard where you can compete with people from all around the world to see who will complete first all the learn modules. And we have more. You can claim your own learning badge by Azure Heroes program. You can go to the website ak.ms/gai-badger, scan the QR code, and you will claim your own NFT. This is one of the many badges that you can claim, and you can join a community of over 12,000 badges worldwide. I have my own badge, and you can also take yours by watching our live stream. Loxley, can you introduce our next speaker?
Yes, of course. So our next speaker is Anam Sayeda, and she'll be doing a talk on the AI voice assistant using Python. Anam, are you there?
Everyone, hello everyone. So yes, I'm very excited for the session. So let's begin.
Awesome. Great. We're super excited to have your talk. And also, we know that you have your very own website called the She Coder as well. So super excited to hear about that and your talk as well.
Yes, I do have a website called theshecoder.com. And yes, let's start. Thank you so much. So let me share my screen now.
Yes.
I hope my screen is visible.
We can't see it yet.
Is it visible now?
No, not yet. Oh, yes, it is.
Okay, so I'll start now. Hello everyone, I'm Anam Sayeda Fatima. I'm a recent graduate and an ex-Microsoft Learn Student Ambassador for Oman. I've also worked as a machine learning intern at Capter, and I do have a website called as theshecoder.com. So do check it out. And as you know, today's session, we're going to learn about how to build your own AI voice assistant using Python. So without any further delay, let's get started. More than a decade ago, touchscreen technology was fictional. That means it could be seen only in movies and books. But with the release of Apple's first iPhone in 2007, touchscreen gained mainstream popularity and became a very prominent part of our daily lives. But now we are moving into a new era. We're transitioning from touchscreen to voice. This is the era of voice assistants. A voice assistant is basically an AI that recognizes, understands, and responds to human commands. You all must be familiar with Cortana, Alexa, Siri. All these are examples of voice assistants. So just let me show you Microsoft's own voice assistant called as Cortana. And I know you must be familiar with voice assistant, but I just want you to notice two things that we're going to do with our own project. So let me just start. Hello Cortana.
What's up? To find out, try saying, show my calendar.
Open Google.
All right. I'll open Google Chrome.
Okay, so the two things that I want you to notice is that the first thing, so while we were speaking, our speech was converted into text, right, over here. And the second thing that happened was the text was converted into speech, right? Cortana was speaking the results. So that is text to speech conversion. So these two are basically the main task of voice assistant. The first task is to convert speech to text, and the second task is to convert text to speech. Keeping these two things in mind, we will now start our own project, which would be making your own AI voice assistant in Python. So for this, I'm using an IDE called PyCharm, but you can use any IDE that you are comfortable with. Okay, so the first thing that I'm going to do is we are going to install Python packages. And to install Python packages, all you need to do is go to Google and you need to type, like, the 4 packages we're going to download for this project are going to be like speech recognition, PyAudio, Python text to speech, and PyWhatKit. Okay, so to download these packages, go to Google and then just type the speech recognition PyPI. Now, PyPI is a website from which we're going to download our Python packages. So over here, from the search results, you will find pypi.org, and we're just going to click that. And we're just going to copy this command. Now you have this command over here. You can just copy and go to your terminal. And go to your terminal over here, and we're just going to paste the pip command. Okay, and just press enter. Now what it's going to do is it's going to download the Python packages. And since my packages were already installed, so it comes like the requirement already satisfied. But for you, if you have not downloaded, you will see the whole process of downloading. Okay, so the first package was the speech recognition package. The second package that we are going to use is going to be PyAudio. Okay, and again, you're going to just copy and you're going to paste that into the terminal. And similarly, we are going to be installing Python text to speech, which you can see over here, and PyWhatKit. So these are the 4 packages that we are going to install using the same method that I showed you. Now, after installing these packages, all you need to do is you have to import these packages first so that our code can work. So I'm going to import my packages using the import statements. And the first package that we're going to import is the speech recognition package. And the speech recognition package basically will help us to help the voice assistant to recognize the human commands and also convert speech to text. Okay, and we're just going to give that short form as SR. And then we're going to import Python text to speech. And this Python text to speech is going to convert the text to speech. So it will help our voice assistant to speak out the results. And the next is PyWhatKit, and this has a very interesting function that we're going to know later in this code. And whereas we're not importing PyAudio, but we still need to install PyAudio, because without installation of PyAudio, our speech recognition package won't work. So we need to install that. And I personally experienced errors when I did not install PyAudio. Okay, so though you don't need to import it, but still you need to install. And over here, these 3 packages, which is date, time, web browser, and sys, these all are basically built-in Python packages that you do not need to install, and you just need to import them. So after importing all these packages, we're going to move on to the main part, which is converting speech to text. So the first line of our code is going to be, we're going to create a variable. I just named the variable as ear because my logic was that we humans, we usually listen and recognize human words with help of our ear, right? That's the main part that is help us to recognize human words, right? So that's what the reference I took. So we're going to declare a variable, and we're going to call the speech recognizer method from the speech recognition package. Now, from the name itself, you can tell that this basically helps the voice assistant to recognize the human commands, to recognize the human words. So that's what we're going to do the first step. Now these are the comments. I have commented these lines because they come later. So I'm just going to jump to this part in which we are going to the main function, which is speech to text conversion, is going to happen. So first I'm going to declare a function, which is the input command. Now this function basically will help us to input our commands, like it will take our commands and give that to voice assistant. And we're going to put that into try and accept block over here. Okay, and why we're using try and accept block is because we are going to call the microphone method from the speech recognition package. And this sometimes microphone, they can throw errors. So we need to catch that. So that's the reason why we're going to use the microphone, why we're going to use the try and accept block. And we are just calling the microphone method, and we're just naming that as source over here. So microphone will be called as source. The next step is we're going to print these dots. So basically, it's an indication for us to start speaking. So even you must have seen over here when you just switch on, there is a line, right? That is an indicator for
I'm
us to
sorry,
speak.
but I can't help with that yet.
So that's what these dots are. They are the indication. And the next step, the next line of code is basically we're adjusting our environment noise, comparing our environment noise to our own human noise. So what this does is the voice assistant, if you do not write this line of code, personally I've experienced that you will get an error, like your voice assistant won't be able to catch your voice because if there are background noises going on. So what we have to do, this line of code will differentiate your voice from the background voice. And the minimum duration it needs is at least 0.5 seconds for it to differentiate between your voice and the background noise. And over here again, from the name itself, first we're declaring a variable, and from the name itself, you can tell that it's going to listen to our microphone. That's the main function. And again, we're going to declare a variable, and we're going to call the recognize Google. Recognize Google is basically an API that will help us to convert our speech to text. This is the main one that is helping us to convert speech to text, and it's a Google API. And we're passing our audio, the one which we were listening, right? We are passing that. And yeah, we're going to print our commands just to see what we are speaking. So that is basically speech to text conversion. And over here, we have this accept part, and then we're going to return the commands. So let's run and see how the first part is, that is converting speech to text. Hello. So yeah, as you can see, our speech, what I said was hello, is converted to text. So that's the first main part of voice assistant. Now the second main part, the second main task you can say is to convert text to speech, right? So to do that, we are going to we're going to use a Python text to speech package. And I'm just going to declare a variable which is called as assistant, and I'm going to initialize a Python text to speech package so that we can use it. So after initializing a Python text to speech package, we're going to declare a function as speak. So basically it's like our voice assistant is speaking, and we're going to pass text, right? Okay, so this assistant dot says, so we had already initialized the Python text to speech package. We're going to use that over here, and that dot save is from the name you can make out. It's going to allow a voice assistant to speak, and just passing the text, and run and wait. Now without this run and wait, what voice assistant is will say won't be audible to us. So this is very compulsory to add. I will show you also, like without this line of code, we won't be able to hear what our voice assistant is going to say. So let's begin. So okay, over here I'm going to call our speak function, and then whatever command I'm going to say, I want the voice assistant to tell that same command. So let's see how this works. Hello.
Hello.
So there we go. We have covered two main parts, which was converting speech to text, and the second was converting text to speech. But majority of the voice assistant, they have female voice, right? Like even Cortana, Alexa, Siri, they all have female voice. There's no harm in having a male voice, but if you want a female voice, what you can do is Python text to speech has a method, okay, and basically we're going to use the get property method from Python text to speech, and we're going to call the voices key, okay. So we're going to call the voices, and then we're going to set that voices 1. So 0 is for male and 1 is for female. Now after writing these two lines of code, you would see that our voice assistant would have a female voice. Hello.
Hello.
So there you go. So this was the two main tasks which we covered. One more thing was that I said that without our run and wait command, the voice assistant won't be audible, right? So I'll just show you why the run and wait command is very necessary. Hello. Okay, so it could not catch my voice, so let's repeat. Hello. So yeah, without run and wait, you could see the voice was not audible, right? So that's why we need to add this. Now, after covering these two main tasks, which was converting speech to text and text to speech, we're going to move on to the main fun part of our voice assistant. And over here, we're going to add all those functions, like whatever functions you want your voice assistant to perform, right? We're going to use over here. So again, we're going to define a function, and we're just calling that function run assistant. And over here, you can see that we're going to call our input command. So input command basically takes our command, right? I'm just passing that to a variable command. So let me just comment this thing, and because the main thing which we are going to run is going to be the run assistant. And you must have seen, right? When I said hello, Cortana responded like hi and all those stuff. So we're going to do that. So if hello, it's in command. So if the voice assistant recognizes hello in the command, in what we have spoken, so it's going to print, hi, I'm your voice assistant, how can I help you? And also it's going to call the speak function. Now the speak function is over here, which we had declared. And it's going to also speak like, hi, I'm your voice assistant, how can I help you? So let's run and check. Hello. Hello.
Hello. Hi, I am your voice assistant. How can I help you?
So there you go. So that was the introduction part of a voice assistant. So suppose someone says hello, we can just respond in that way. The next thing which we want is the time, right? So to know the time, suppose the user is going to ask what time is it, and we want to print out the time, and even we want the voice assistant to speak out the time, right? So we had imported data and time package, right, at the start. We're going to call that over here. And date and time package has a method, which is again datetime.now. So it's basically the current time. And this is basically formatting our time. So this I over here is hours and M is minutes, whereas %P is basically AM and PM. We're going to print in that format. So we're going to print the time, and we want our voice assistant to speak current time is, and it's going to print. It's going to speak. It's going to speak our time, right? What time is it?
What time is it? Current time is 04:21 p.m.
Now, another function which you could add is like, we want to open any websites with help of a voice, right? And Cortana was able to do that. So we'll make our own voice assistant able to do the same thing. So to do that, all you need to use is the web browser. Now, the web browser also is a built-in Python package. You don't need to install it, you just need to import. And web browser has a method which is open new tab. So our website is going to be open in new tab. And you just need to pass the URL. Even if you want to use open YouTube or any other websites, you can just, again, elif, and you can just write open YouTube in command, and then you can just pass the YouTube URL. So let's see, it's going to be interesting. Open Google.
Open Google. Opening Google.
So there you go. The Google was opened in new tab. And it's very simple. You just need to import the web browser. Okay, so now we want to play any YouTube videos, right, or any YouTube songs. Again, we have a package for that, which was PyWatt kit, right? And we also imported that. We installed this package and imported. So over here, we're going to declare a variable song. And suppose if I say play One Direction, right? So we just need that One Direction part. We don't need that play part, right? So for that, we're just using the replace method, and we're just replacing the play part with an empty string. Then again, we're just passing that to speak and print. So playing plus, suppose it will say One Direction, so playing One Direction. Then print playing One Direction. And the PyWatt kit has a method which is play on YouTube, and it's going to pass the song, the variable. So let's see. Play One Direction.
Play One Direction. Playing One Direction.
Changes. That's my favorite song too. Okay, so that was it. It was quite simple if you think about it, but still it's quite fascinating at the same time, right? And yeah, that's it. Only the last thing over here is like if you want to switch off your voice assistant, you can just say stop, or if there's buy in your command, right? Just like stop, stop voice assistant or buy voice assistant. So that's what is written over here. So it's going to just speak voice assistant is shutting down, and this is .exit. It basically makes our program stop running, and this is also built in Python package. So let's try that. Stop. Okay, so there's an error, but let's check because it did not catch my voice. Stop.
Stop. Voice assistant shutting down.
So yeah, it just makes your program stop running. And over here we have the else part. In case if you speak tell anything which the voice assistant cannot perform, it will just say sorry, I could not understand the command. And this is the final part which you have to include in your voice assistant. So the one thing which we did not do was we did not have the open YouTube, right? So let me see if it responds to that. Open YouTube.
Open YouTube. Sorry, I could not understand the command.
So yeah, this was it. This is how you could build your own voice assistant, right? And yeah, one more thing is that you can add over here while true so that your voice assistant can run continuously. But for that thing, let me warn you, you need a very good internet connection for that thing for your voice assistant to run in loop. And I have done that. So let me just show you. So yeah, this is just my first blog post, which was basically building your own voice assistant in Python. And in this blog, I have also, I have added extra functions and extra packages are there, and you can find the code also, right? So we have explained. So since I have explained the main function, the main features of this voice assistant, rest of the things are going to be easy. So we had done this. Okay, so we had just displayed the time, but over here I've also shown how you can display the day and the date, and you can display the calendar too. And suppose there are like questions like who is Donald Trump or something, if you want to ask that kind of questions. We're going to fetch the data from Wikipedia. And since it's very simple, you just need to install the Wikipedia
Same
package. And again,
person
as I
or the next
explained it.
speaker online.
So yeah, you can just go through this and fetching weather and all those, answering your mathematical questions, sending WhatsApp message. All this is there. So yeah, please do check it out. And for this session, that's it. Thank you so much for joining me in this session, and thank you so much.
Thank you, Anna. Your presentation was great and your demos were excellent. So congratulations.
You did a
Thank
fantastic job, Adam, and I especially liked how you showed the entire process from the beginning to the end, downloading the packages so that beginners following along could exactly follow all of your steps and basically repeat it. I also, the end, having it play One Direction, I was so amazed personally.
Yes.
So
Thank you
we
so
have yeah. So we have a couple of questions for you. The first one, we have a lot of students that are watching a live stream right now, and they want to know if there are some learning resources to learn more about all the Python libraries for AI, like the audio that you saw in your demo.
Can you repeat just a minute?
Yes, can you
What?
suggest some learning resources for learning about Python packages for
Okay.
AI?
Oh yes. So for learning, you can find many online resources are there on Google. You can just type audio and you'll find so many things, resources related to that. That's how I learn. I don't learn from a particular website or a particular video, anyone, because some websites may have something good written about audio, but they won't explain much better things in much better way about some other packages. So I would just say in general, just type in Google and you will find obviously many resources, and it's going to be very helpful because that's how I have learned and my friends have learned, and I'm sure many beginners do the same thing.
Thank you. And our second question, is it possible to use libraries for text to speech or speech to text in languages other than English?
Sorry, can you repeat? I'm so sorry.
Is it possible to use Python libraries for text to speech or speech to text in languages other than English?
Okay, so you want a Python package that can use like both the functions in one, right? No,
Like
exactly. We
yeah.
don't have for that.
More
We
like
need a separate one.
like could
We need a
you
separate package.
is it possible to use the speech to text or text to speech packages in a language other than English? Like is it accessible for people who speak other languages?
Okay, okay. So yes, it's possible, but then you have to check it out. Like there are not many languages, right? But I feel it's going to be only the English language which is going to be preferred. But I'm sure Pi Audio is going to be used for all the languages which are available in a voice assistant, right? Those languages will be available, the general languages, because you know our voice assistant was built with help of Pi Audio and all those things, even Cortana and Alexa. So those languages will be available. Yes.
So thank you so much for your presentation and for joining us today in the Global AI Student Conference. We'll take a short
Okay.
break and be back for the next presentation soon. And we are back for our next presentation about deep computer vision approach for visual quality inspection. Our next speaker is Muhammad Tala, a PhD candidate in computer science and previously a machine learning engineer. So we are having some technical problems, but we'll be back in a few minutes.
Hello, welcome back to the Global AI Student Conference. Our speaker is having some technical issues, but no worries. We have an amazing talk from the Global AI Developer Days on predicting queues at Disney World. I am very excited for it, and we're going to get that rolling for you right away.
Welcome back, everyone, and I am excited to bring in our next speaker, who is going to be Becky. Hi, Becky, can you hear us? Hi.
I can. How are you all doing?
We are good, and you?
Doing very well, thank you.
That's great to hear. And I'm very happy to see you around, but some people maybe see you for the first time, so you should introduce yourself.
Sure. Hi, everyone. I'm Becky Gandillan. I live in St. Louis, Missouri, so squarely in the middle of the United States. Makes it a good sort of base for traveling. I work for Centric Consulting, and I lead the St. Louis arm of our data and analytics practice. In my free time, I do Disney analytics, and that's what we're going to be talking about today.
Which I really like, actually.
I was already wondering, there's something behind you from Disney, but I can't
Yes.
read what is written
I'm
on it.
counting down. My family and I are going on a Disney cruise here in
Oh,
November
cool.
out of San Diego. So excited for that.
Wow.
Enjoy.
Okay, I really think that we should not take more time of chit-chatting here, but
I want to see what you're
I'm
doing
okay
with
with
Disney
that.
data.
Yeah. Let's jump in and
take it
talk
away.
Disney data. All right, let me share my screen here so that we can all see what I'm talking about. Got it?
Yes.
Yeah, there we go. Perfect. All right, we're going to talk about hacking our vacation, which sounds fun and is pretty fun. One of my big passion areas is making data, numbers fun, engaging, powerful, and so that's what we're going to talk about today. And I have a lot of content, so we'll see how quickly I can fly through it. I talked a little bit about myself. So this is me, my fancy professional headshot, not in my headphones. I'm actually an engineer by background, and I love problem solving. And so my data is my way of solving those problems. And now I sort of specialize in data strategy and road mapping, and that's what I do in my everyday job, helping companies make better use of their data. But also, I am a mom of 2 young kids and a big Disney fan. This is us on our last trip to Disney World, which was back in July. I blog about Disney data. I have a YouTube series about Disney data. And it's pretty crazy to me that a series of videos that are talking some very technical data about Disney can have such wide reach. And I think it goes to show when you put the right spin and the right communication layer on top of data, it can really impact people and what they want to do with their vacations and with their lives. And so in this part of my life, I specialize in crowd and touring analytics for Disney vacations, mostly Disney World and Disneyland. So I apologize to the folks in Europe and Asia where the other parks are, but we'll see some of the same things apply. I'm going to talk about what we do on our vacation, what our goals are, and how I can use those goals to pick out data sources to solve potential problems with my vacation. So these goals that we're going to be talking about today, we want to know how to avoid crowds. We want to know how to save money. Disney can be expensive, and we want to enjoy our vacation. And really today, with the limited amount of time that we have, we're going to be focusing in on how to avoid crowds. How can we use that data in order to avoid crowds? Well, what's the problem here? It turns out that even if we're spending one day in the Magic Kingdom, there's a lot of things that we have to solve for if we want to predict how many people are going to be in the park and what they're going to be doing at any given time. So we have all these things. People can go on attractions, they can shop, they can eat, they can choose not to go to the park at all, they can choose to leave early, they can choose to go late. How do I wade through all of this and figure out what all of them are going to be doing so I can go against the flow and maybe spend a little less time in line? Okay, so, but that's just Magic Kingdom, right? And if we're talking about Walt Disney World, which is the park that's in Orlando, Florida, there's not just Magic Kingdom. We then have to multiply all those problems by Epcot, Hollywood Studios, and Animal Kingdom, plus 2-ish water parks. The second one is reopening here again pretty soon with a new theme that just got announced, plus a shopping district called Disney Springs where you can happily spend all day and spend all of your money. A new thing that just opened a few months ago called the Galactic Star Cruiser, where you can take 2-night, 3-day cruises, and you will be taken up to space in this Star Cruiser and be a participant in the world of Star Wars. So that's pretty cool and eats up some people. Plus there's 34 different resorts just on Disney property that are really highly themed, and people choose to spend time there too. So how do we know what all these people are going to choose to do with all of these great options to pick from? And the answer is that we pull a lot of data to try to figure that out. Now, this is an example of some of the data we could pull. I really wanted to walk you through the process of goals, problems, data sets, and then answers. And normally, if like we were in person and this is interactive, I'd ask people for ideas of what you think might be good predictors of how crowded Disney World is going to be. Spoiler alert, the top one is school calendars, because lots of people that go to Disney have school-age children. And so if school's in session, they're not as prone to taking their kids out of school to go to Disney World. If, however, it's Christmas break or spring break or Thanksgiving, there's going to be tons of families in Disney World and it's going to be really crowded. So that's the #1 predictor. I say 140 districts here because that's a pretty big sample size. It's concentrated pretty heavily on the East Coast because it gives us enough of the data we need to know when those times off school are going to be. You also have economic data. If the economy is not doing so well, Disney visits get cut. Travel agent trends, prior years of results, weather trends. If it's sunny, more people are going to be in the parks. If it's cold and rainy, no one wants to go. Operational info. And then on the right side, we have some information that's either gathered and scraped from other sources or generated by us. So we can scrape Disney's wait times. Disney has an app for when you're in the parks. You can pull up a map of the park and see all of the posted wait times for all the attractions. It's pretty easy to get your hands on that information, and then it's updated every 5 minutes. So obviously that's some pretty solid data, but it doesn't tell you the whole story because Disney's motivated to post different wait times than what reality is. I want to see a number and get in line and then be pleasantly surprised that I waited less than what that number was. And Disney knows that, and so they inflate those posted wait times a little bit. So we have an app that lets people submit their actual waits so we can get the data on what that gap is and be able to more accurately track those waits, as well as a bunch of other stuff, but let's get into the fun data. How are we going to avoid these crowds? Fun fact, this picture is taken back when the parks were still at 25% capacity after the parks reopened. So this is 25% capacity, Magic Kingdom here, and it's actually before the park even opens for the day is the crowds that you could be contending with there. Not great. So what do we do with all that data? We're going to take that data and we're actually going to use a pretty simple tech stack, including AWS and some SaaS, but we're going to run TreeNet and use some Python to figure out and piece together what we think the crowds are going to be like. And the way I'm going to talk you through it is actually the opposite of the way we build it. We build it from the bottom up. So predicting specific wait times for every attraction for every 5 minutes of the day, and then aggregating those to a park level, and then comparing it to the calendar as a whole to come up with what you see on this screen, which is our crowd calendar. And we have everything on a scale of 1 to 10, and we show approximately how crowded you can expect things to be. So if you get really inspired by my talk and decide to fly to Disney World tomorrow, it'll be about a crowd level 6 overall out of 10. Pretty average, not terrible. And you'll see sort of the park hours and how that might impact things, as well as special events. We can start to get some information here, but we need to go down to the next level to figure out what that information really means. So I'm showing you some of the attractions in Magic Kingdom. So those are listed up and down, and then along the right, you'll see the different crowd levels. And at the intersection of the attraction and the crowd level is what you can expect the posted wait to be in the middle of the day. And we have 1 through 10, those are our crowd levels. The way those are distributed throughout the year is they're sort of forced onto a bell curve. You'll see very few level 1 and level 10 days throughout the year. You'll see a lot more average days in the middle. Your level 10s are Christmas and New Year's, and your level 1s are the week after Labor Day. If you want to go to Disney and when it's not crowded, that's the key. You just go the week after Labor Day. No one wants to take their kids out of school the week after Labor Day. The bonus of it being a bell curve is that it looks like a roller coaster and makes for a fun joke in my presentation. You're welcome. Okay, so what does this mean? What will it do to our day in a Disney park? And so I'm pulling up here an example week surrounding a Labor Day. Actually, I think this is a week before Labor Day, but you get the point. I'm also cheating because I'm rewinding to this year's Labor Day and pretending it's in the future, but it's easier than going all the way forward to next Labor Day. Around this time of year, all the crowd levels are 1. No one's in the parks. You're going to have a really excellent time avoiding all of the waits. So what does that crowd level 1 mean? It means, like in the middle of the day, Seven Dwarfs Mine Train, which is the big headliner for Magic Kingdom, will have about an hour posted wait time. You'll probably wait a little less than that, and really an hour's not that bad. And we see some of the other attractions, half an hour for Jungle Cruise, 45 minutes for Peter Pan's Flight. This is a pretty easy day of touring Walt Disney World. On the other hand, if I chose to take my family to Walt Disney World during the week of Thanksgiving, it's not the most crowded week of the year. It's pretty stinking crowded. I can see a lot more not ones, 9s and 10s, a few 7s and 8s sprinkled in there. So if I decided instead of going to Magic Kingdom the week around Labor Day and I went on this Monday before Thanksgiving, now Magic Kingdom's a crowd level 9. So what does that mean for my wait times? It means 3 hours at Seven Dwarfs Mine Train instead of 1 hour. It means almost 3 hours at Space Mountain. It means over an hour at most of the other attractions. I could do that. I'm going to choose to not do that and make my decisions about when I'm going to visit so that I can go when there's less people in these lines. I don't want to wait 3 hours for a single ride in a day. But I can also see that I can game this system a little bit at this level. Now, a crowd level or maybe 2 of difference isn't going to make a huge impact to what my day feels like as a whole, but I can look at this crowd calendar and I can still go to each park on a specific day so that I'm avoiding some of the waits. I'm not going to Magic Kingdom when it's a 9. I get a couple of 8s in my vacation, so maybe it'll be a little bit better. So those are the sorts of decisions that I can make on this crowd calendar type of level. But we can dig even deeper, and this is where it gets really fun with all the nerdy data science. And I can see the trends of wait times at specific attractions all throughout the day on specific days. And again, the dates here don't really matter. What matters is the crowd level. So on the top, I have a crowd level 10. This is the most crowded the parks get. And on the bottom, I have crowd level 1, the least crowded the parks get. And I've got 2 attractions here, Seven Dwarfs Mine Train, which is a big headliner. Everyone wants to ride this. And then on the right side is Dumbo. Not a headliner. Still a lot of people feel obligated to ride it, but it's not going to be as popular. And we can see a few things here. We can take advantage of some dips, and really that's how you want to optimize your day, is going to the most attractions you can while they're in their dip in their wait time. So if we see Seven Dwarfs Mine Train, I could go right when the park opens, but that wait time spikes really quickly, so maybe that's not going to give me much of an advantage. If I sleep in a little bit, I should probably wait until about 10:15 or 10:30 when it has this sneaky little dip, or I need to wait way late in the night when the wait time drops again. Dumbo's a little bit different. It has a really low wait time for most of the morning until we get past 10 o'clock, and then that's when it spikes up. It goes back down in the middle of the afternoon when all of the families with young kids have taken their kids home to go get a mid-afternoon nap, and then it drops off in the evening when everyone's sleeping again. So in my human brain, I could process maybe a few of these graphs and try to figure out how to optimize my day based on those dips. The problem is these shapes change every day, and no 2 days are going to have the exact same shape. So if we look at crowd level 1 days, the behavior is much different. So in this case, Seven Dwarfs Mine Train starts with a really high wait time and then it drops. This is a weird quirk of human behavior. Everyone knows Seven Dwarfs Mine Train is the big headliner and they want to beat the crowds there, so they all rush to the park. That leads to a spike on those crowd level 10 days that then keeps going up as more people get to the park. But on crowd level 1 days, everyone that's going to that park is rushing to Seven Dwarfs Mine Train, and then they've already ridden it. So then there's no line the rest of the day. You can just go in and get in line in Seven Dwarfs Mine Train. And an interesting spike happens at Dumbo too. And there's these things that human brains just wouldn't expect to happen and couldn't plan around. And so being able to take all of these shapes for every attraction, for every day of the year, no one's going to be able to do all of that. And so that's where we use the advanced analytics to help you plan an optimized day. So on this website, which is touringplans.com, is where you can access these things. You can go in and make your plan for your day. Hooray. And so then you don't have to hold it in your human brain. That makes me happy. So I could say that we're going to go to the Magic Kingdom on October 28th. And I didn't trust myself to run a live demo because internet can always be shaky. So I did a few screenshots, examples of how this might work. Once I picked my day and what park I was going to, then I can tell it which rides that I would like to experience. So this list would go much longer than what we can see on the screen, but I know I'm going to ride Buzz Lightyear twice because my kids love competing to see who can get the highest score. I'm going to ride Big Thunder Mountain Railroad. It's a roller coaster, but both my kids are tall enough for it and they like it, so we're going to do that. Got to do the Country Bear Jamboree. You see some other classics here. It's a Small World is my 4-year-old's favorite ride. So I only have it listed once, but in reality, my family does that one multiple times. So our days at Disney World are a lot of fun. So if we take all of these results, then we have some options. Maybe I'm a Disney veteran, and so I want to put all of this in a plan, and I want to put it in the steps I want it to occur in, but I want to know what to expect. Like, if I do the things in this order, what wait times will I have? Then I would use evaluate. If instead I want the computer to do all the number crunching and get me all of those dips so that I have the least amount of time in line, then I would click optimize, and it would take the information about the day, the park, the things I wanted to do, as well as constraints like mealtime, etc. And it would put it in this beautiful plan for me. And there's several sliding scales that I didn't put on this screen itself, but I can do things like tell it my walking speed, because that's going to impact the walking times, which then impact when I'm going to get to the attractions, which then impacts how long I'm going to wait. So if I'm going to bring a stroller with me that day, I'm going to drag my walking speed to slow. If it's just me and I want to do all the things, my walking speed is going to be really fast. I can do that. I can also tell it to either minimize wait all the way, that wait time in line, or minimize my walking while still trying to minimize my waiting. So I don't care if walking from Big Thunder Mountain, which is on one side of the park, to Space Mountain, which is on the exact opposite side of the park, saves me 3 minutes. I don't want to have to walk half a mile across the park. So then I can tweak that so it doesn't make me crisscross across the whole park. But the results are this. So I tell it that I'm going to get to the park at 9 o'clock. I have to walk over to Buzz Lightyear. It turns out if I'm going to write it twice, the best way to do it is just write it twice right at the beginning of the day so that then the wait time doesn't go up later in the day. Then I can ride Space Mountain before the crowds get there. Then I ride the People Mover. Then I go to Mad Tea Party and spin around for a while. And then it continues my day. And I can see I know my wait times. I know how long the attraction actually lasts. And then I can see how long it's going to take me to walk from place to place. It plans out my whole day for me in a way that's going to minimize my wait time at each of these attractions. So this makes me very happy. Doesn't really do me much good though if I do that at home the night before and then I get to the park and I have a piece of paper and I'm walking from attraction to attraction and I do Buzz Lightyear twice and then I go to Space Mountain because that's step 3 and Space Mountain's down. Maybe it has unexpected maintenance issues, maybe someone threw up on it, whatever the case may be. Now my plan is ruined and I either just have to wait around and try to pick it back up on time or I go cry in a corner. So instead, we need to put it on someone's phone because they're going to have that with them in the parks. And because we're scraping that posted wait time information every 5 minutes, we're getting updates about whether things are down or whether they have a weirdly long wait that they shouldn't have or whether they have a really low wait that we didn't expect initially. And so suddenly now we can take advantage of that and you can optimize after you get off of every ride and you don't have to stick with that initial plan and it's going to stay optimized instead of just being optimized the day before. So now we can have a bunch more information in our hands about what we expect those wait times to do. We can also get real-time information about the posted wait versus the expected wait. So we know Disney's inflating those posted wait times. So is it really going to be different? And we can get data back with this timer. So if you're looking at your phone anyway to figure out where you're going to go next, now you can give us more data to make our predictions more accurate by just clicking the timer when you enter the line and clicking the timer when you get onto the actual attraction itself. So this makes sort of that feedback loop look really, really nice. So that's all I'm going to cover today because that was a lot. We didn't get too into the details of math, and that was intentional. I think it's more fun to think about, yes, all the math, but how do you make it applicable? And how do you make sure people are going to use it? And then how do you incentivize them to give you more data back? So this, again, is my family on our last Disney trip in July, getting to meet Cinderella, and that was pretty cool. But if you want to know more information about the Disney Analytics, feel free to look me back up. My Instagram, I share a strategy based on this data every Saturday. We call it Strategy Saturday. It's a whole thing. So you can see that. I also share pictures and more data, or you can see my blog, my LinkedIn page. But happy to continue the conversation about all things Disney and data.
A really interesting session, Becky.
Yes.
Now,
Thank
I have
you.
already one question. When you have the app, people can say when they're in line and when they're on the attraction, is that data real-time analyzed or it's analyzed afterwards?
No, it feeds back in real time. Since we're collecting those posted wait times every 5 minutes, those actuals can come in at the same time, and we'll use those to immediately change sort of those estimates and what we're looking at. So admittedly, it's a little bit behind, right? So if you have a 30-minute wait, we don't know it's a 30-minute wait until 30 minutes after you've entered the line. And so having to do some of that reacting and rewinding of the data to then predict the future is an interesting challenge in and of itself.
I can imagine.
Mhm.
Did you build all of this yourself or you have a
No.
whole team working for you?
I don't have that much free time. I have 2 young children.
Yeah, I can
no,
imagine.
there's a whole team of us. I don't want to make it sound like it's 20 people, but a good small crew of folks behind the website and the app.
Now imagine someone says, I want to help work on this. Where do they need to be?
Reach out to me, sure. Just go to touringplans.com and you can get in contact with pretty much any of us. We're always looking for people that like Disney and data.
Okay, cool.
Yeah, this was, I really like this session.
I'm glad, thank you. Anyone planning any Disney vacations coming up? You need any suggestions?
Yeah, I want to go back to Paris to see the new studio park with Marvel.
Yeah, so Disneyland Paris they're doing their 30th anniversary this year, while Disney World is having its big 50th anniversary, and Disneyland Paris's 30th is much cooler. I've seen the drone show, video of the drone show there, lots of cool stuff going on in Paris.
Exactly.
I'm jealous.
You're going on a Disney cruise. I think that's also.
I know. It's not Paris, though, right? It's San Diego, but I'll take it.
It's closer by for us to go to Paris, so.
Yes. Lucky you.
So,
Do you have any other questions?
No. Thank you. I really like the session, and it's always fun to hear this story.
I'm gonna check for sure your website to get more information out of it.
You should.
Perfect.
All right.
Look
Becky,
at it. I enjoy
thank you
it.
very much for sharing your knowledge about Disney statistics.
Thank you. Thanks for having me.
We're looking forward to hear more from you. Have a nice day.
All right. Thank you.
Bye-bye.
Bye. Thank you.
That talk was amazing. I wish Becky was here to ask her more questions.
I completely agree, and it's definitely inspiring me to plan another Disney trip. And now, but we are back at the Global AI Student Conference, and we also want to remind you again, if you've just joined the call, we have our Cloud Skills Challenge. You'll see the link at the bottom of the screen, but it is also aka.ms/learn-challenge. And by joining the Cloud Skills Challenge, you'll be on a leaderboard where you can compete with people from all over the world streaming in today to complete Microsoft Learn modules. And we also have a learning badger at aka.ms/GAI-badger. And you can go to this website or scan the QR code and you will claim your very own NFT. This is one of the many badgers you can claim, and you can join a community where over 12,300 badgers have been claimed worldwide. And I have my very own AI ambassador badger and many others, so it's a super cool opportunity. And now we are ready to present our next speaker, who is Shadrach Kiprotich. He will be presenting on his AI builder in the Power Platform. Hey there, Shadrach. How's it going?
Day.
We're almost ready for you to present, but first, I've learned that you've organized and attended 20 plus hackathons and tech events. That is really cool.
Yeah. Awesome. Yeah.
Yeah, and with that, feel free to take it away and share your screen. We're looking forward to your presentation.
Sure. Just a minute. I'm trying to share the screen. Then we go live. Yeah. Can you see my screen?
Yes, we can.
Okay. Just a minute. Hey, thank you so much for having me at this Global AI Student Conference. And for today, I'll be taking you through artificial intelligence builder in Power Platform. So just about me, I'm an ex-Microsoft Learn student ambassador. I graduated from the program earlier this year, and I transitioned into the Microsoft MVP program under the business applications category. And also, I'm a .NET developer and a Power Platform developer. And of course, I love empowering people from non-tech background, just as I am into the tech world. And also, I'm based in Nairobi, Kenya, where I'm a cowboy. So probably next time I'll be here with the full costume. You can find me on LinkedIn as Shadrach Protich and on Twitter, Miles_Shadrach. So let's jump into today's agenda, where we'll be talking about what is an AI builder. So like this is the big question that you are asking yourself, like what really is this AI builder? We're also going to see the managed services that we have for the AI builder. And also like the question like why should I go with AI builder? So like that's after all the introduction, after you get to know about it, and then how you can also get started. So after we've known like why should you use it, then we also get started, and also like how you can be able to acquire a license for the AI builder. And then we're also going to see about the AI builder models, the several of them that we have, and also hopefully time will allow us to do a hands-on demo for this application. So straight into it. So what is a Microsoft AI Builder? So Microsoft AI Builder is Microsoft Power Platform AI capability that allows you, that allows your business to be able to automate processes and also like in predicting outcomes. So this basically means you can be able to enhance the business processes that like revolves around your business. And also the Microsoft AI Builder sits under the Microsoft Power Platform, which consists of 5 technologies, 5 components. That is, we have the Microsoft Power Apps, we have the Power Automate, we have the Power BI, Power Pages, and Power Virtual Agents. And each of these components has a functionality. For instance, in the Microsoft Power Apps, you can be able to build apps without writing any line of code. We have the Power Automate. So Power Automate essentially is for automating repetitive processes that you normally have within your business. So think of that process that is manual and tedious, then Power Automate can be able to fix that for you. We also have the Power BI, where you can be able to analyze and visualize data that you have. And one of the cool things that was added recently is the Power Pages, where you can be able to build customer external facing websites for your customers to be able to interact with your data and also like your business. We also have the Power Virtual Agents, where you can be able to create chatbots from it. And also like essentially like what about like AI builder is for automating processes and also like for predicting outcomes within your business. So just come to think of it, let me just give you a business scenario of this. We have the invoice processing. For instance, your organization can be able to process like for instance 1,000 invoices in a single day. And those invoices, you need to extract key information that you want for your business. For instance, the name of the person whom the invoice is being addressed, the quantity of items that are needed, the prices, and also the dates and the invoice number. Just imagine processing 1,000 invoices within a single day. I hope you're building the scenario in your mind that it's very tedious and it's error prone. So you can be able to make lots of errors, and this will make you to be able to repeat the process once again. You also have the language processing. You might be a multinational company where you're dealing with foreign languages, where you need to translate those languages into a language that you can be able to understand well. You might be getting feedback from customers all over the world, and you need to make that understand that language and also get the feedback that the customers are saying. So with AI Builder, you can be able to translate all those languages, and currently AI Builder supports lots of languages. So any language that you want to translate from it, and you can also incorporate within your business. And so now we have the managed service for AI Builder. So we've gotten to understand what actually AI Builder is. So it's a low-code artificial intelligence where it has got managed services that you can be able to use. For instance, you can be able to analyze text for classification. For instance, you might be dealing with lots of data. And of course, we know that in this century, data is the new oil, where you need to process lots of data from your customers, from your business, and you want to classify all these text. Maybe you want to categorize all the addresses that you have, maybe all the feedback that you have that are coming into your business. And then the second one, we have the prediction, where you want to predict whether something will happen. These will come in hand where you want you're using standard data where it's kind of consistent, and you have historical data, and you want to predict something that is going to happen maybe in a couple of months, whether how much sales you're going to make. So with AI Builder, then you can be able to use that, provided that you have some historic data and some standard data that you can be able to use that. Business card readers. So you can be able also to process business card information just by scanning a business card. You can be able to extract all the key information that you want to have from your business. Just try and imagine that you're trying to process for instance 50 business cards within a single day, and you want to extract some key information about the person that you want to contact, or maybe, and also you want to store this data into your database where regardless of where you want to store your data is, then you can be able to leverage on this application. The next item is extraction of text from images. You can be able to process text from images. For instance, now in this scenario that we want to extract key text from images. For instance, that you want to extract something from a chart, from a bottle or something, and you want an AI solution that can be able to handle that for you. So just imagine you have lots of images, and you want to process all those texts all those texts are from those images. Next, we have the form processing, where you want to read and save information. So for instance, you have the hard copy forms, and you want to read and extract the information from that form. So with AI Builder, you can just be able to scan a document and key in all the information that you want. So we'll also be seeing all these processes when we go to our Power Up Studio. And then next we have the object recognition, where you want to recognize and count items in image. For instance, a good example for this is in a supermarket. You want to count the number of images, the number of products in a shelf. So with object recognition, that can be handled for you. So just training your model, and also being able to identify and make a count, and by just tagging the images. So all of this we are about to see them. And now the question is, why should you use AI Builder? So first of all, AI is empowering every skill set that you have. So regardless of your background, with AI Builder that sits on a low-code environment, you can be able to empower yourself with this knowledge, and you don't have to have a background in data science, AI, to be able to undertake all this. Second, we have the productivity, which as I mentioned, that this is a low-code environment that has a high return on investment. For instance, I'll just use an example of a company called Komatsu. They were processing about 54,000 invoices in a single year. Just imagine the cost of hiring developers for this service, the cost, the time that it takes for you to build this whole solution that can be able to process all those invoices and be able to store that data into your database. So just imagine how time consuming and and also cost that you are implementing in that project for. Now, for instance, with that, you need to hire an AI engineer, a DevOps engineer, and software engineer, maybe an front-end engineer to build all the websites, at the back end of it, the cloud of it. So just imagine that. And of course, we are here to play around with AI. So it's usually fun building models and using AI in real time. So just imagine creating your own model to be able to recognize images within yourself. So for instance, you want to build an AI model to be able to recognize all the images, all the items that you have within your place. So just imagine building a cool AI and that can be able to do that. Next, we have it's extensible, meaning that you can quickly embed them to the Power Platform and Dynamics 365. We normally say powerful alone, better together, meaning when you incorporate all these platforms into one, they can be able to perform they can be able to perform well, and also they can give you a range of services. And also it's very easy to use with guided and quick AI applications. So within the Power Up Studio, the Power Automate Studio, you can be able to see guided tutorials on how you can be able to get started. So whenever you get started, you can be able to get help. And also we have the Power Platform community inside the Power Up Studio, where you can join one of the forums and be able to ask questions, share feedback on something. So it's very easy to use. So AI Builder license, you can also you can only be able to get it from the Power Platform license and also the Microsoft Dynamics 365. So these are the two major platforms that sits under the business applications of Microsoft, where Power Platform, as I mentioned, it involves building application, analyzing data, and all those items that I mentioned earlier on. And for these, AI Builder can only be found in the Microsoft Power Automate and also the Power Apps. Or now we have the Microsoft 365, where it's kind of a customer relation management system where it has got sales, field services, operation, the customer service, and also the finance, where you can also be able to get the AI Builder license. And for you to get this AI Builder license, your administration, your administrator can be able to grant you the AI Builder license. So the role of the admin is managing all the environments. They also manage the settings that involves the AI Builder, and they allocate the capacity to the environment that you're using. So for AI Builder, you can only get from one environment. So for instance, if you don't have access to the AI Builder, then perhaps you need to ask your admin to be able to grant you access into it. And the admin can be able to manage all these using the Power Apps Admin Center and also the Power Platform Admin Center. But also, if you don't know how to get in touch with your admin, then definitely you can be able to get a trial version of it. So the trial version comes with a 30-day trial period where you can be able to create and use AI models in any environment, trial or in production. And also you can be able to store your models and it results in Microsoft Dataverse. So Microsoft Dataverse basically means this is the Microsoft Power Platform database where it's widely enriched, where you can be able to store your data. And you don't need to worry about the security of the data there. That's well handled for you. And also with this trial version, you can be able to use your AI model in your apps, flows, and many more. And also you can be able to share it with your colleagues within your environment. I like to be able to do that. And also once your 30-day trial period has ended, you can be able to extend the trial period, and also you can be able to share it with your colleagues. After you're done with your trial version and you want to upgrade, you can also be able to purchase a license and also continue using the AI Builder. So for the AI Builder, we've got two models. Like first of all, we have the custom models where you can build, train, and publish for intended use. For instance, these might be a business process specific to yourself. So for instance, you want to build, train, and publish for a specific function within your business. So then definitely you need to use the custom model to be able to train your model. For instance, your business might have its own way like of processing its data, and you want to just build a custom model purposed for yourself and for your company, and then this is the model that you're supposed to use. So for this, you need to train your model on how to do that. And also we have the pre-built model. These are already built models that are similar across businesses. So you're wondering like, I don't have the knowledge, but I want to I want a model, an AI model that can be able to process languages for me within my company. Then definitely you can be able to get a pre-built model that it has already been trained. So like what you just need is to connect to like your application or like your businesses. So like these are just some of the examples of the pre-built models and also the custom models. So key phrase extraction. So like you want to extract some key phrases from text. Language detection. So like you want to detect a specific language like within an email, a text. So like and be able to translate that. Sentiment analysis. So for instance, like you've done the yearly sales and you want to collect feedback from your customers, and you want to detect the sentiments from your customers. So like you can just incorporate this solution into your business, and you can be able to get know if the feedback is positive or negative or neutral. Text translation, just similar that you need to translate text. Business card reader. And category classification. Category classification basically means you want to categorize all your business processes. So for instance, you might be having a wide range of like data streaming into your business, and you want to categorize each of these information that is coming into your business. So like you can be able to do that via the pre-built models. We also have the entity extraction. And for this other side, for the custom models, so like we have some that like you can be able to access from the pre-built models, and also like we have ones that might be unique for the custom models. For instance, there might be some similar processes that happen across all the business, and therefore you can be able to get them from the pre-built models and also the custom models. So using the AI builder, what you just need to do is choose your AI model. So what do you want your business to achieve? For instance, you want to translate text, then that's it. You also want to extract business card information. You want a custom model, that's it. So like, first of all, you choose your AI model. Second, you connect to your data. So, and also in Microsoft Power Platform, you can be able to connect to more than 275 data connectors. So like, regardless of where your data is being stored, you can be able to connect easily into your application. And then tailoring your model, meaning you want to tweak the model to be able to perform a specific function for you. Like that is maybe business specific to your company or your organization. And then the fourth one is now training your model. So after you've been able to tweak the model to perform the specific actions that you want, you can be able to train your model now. And after you're done training, you can be able to publish your model. And before publishing your model, it gives you a score. So like once you get satisfied with the score, and then you can be able now to publish your model that and it will be ready now for use. So getting the right score. So like we have two types of models under this. We have the underfit models, which is a model that actually performs worse than a random case. So like for instance, like there might be a problem with your training data. So like if you have insufficient data, or like some of your data is just poorly tagged, then you can be able to get an underfit model. And this is actually like you can get a poor score. So like for instance, a score like 20% or something or less. And then we have the overfit models where it appears it performs very well. If not perfectly, then this is because like we have like for instance like a predicted outcome. So we have a column that directly corresponds to the outcome. So like this can give you a perfect score when you're using your AI model. So these are just some of the components in Power Apps. So like you will be able to get them in the model-driven application and also the Canvas application. And for the component that use the custom models and the form processor and also the object detector. So this is just an overview of the Power Apps Studio. So like we'll be getting there. And finally, I'll just try to do a demo in the next 10 minutes about custom model object detection. So like we're going to see if we can be able to detect pneumonia in a patient. So like some of the things that I learned while I was doing this demo was that one with a clear lungs is pneumonia negative, and one with a chest that is kind of closed, then that is pneumonia positive. So let me just go back to our demo. So like let me just head over to the Power Apps Studio. So just a minute. So let me share my screen once more. So for you to access the AI Builder, you need to get logged into the Microsoft Power Apps. And also like for these, you can also be able to get within the Microsoft Power Automate. So for Power Automate, just log into cloud.microsoft.com and just navigate down here where we have the AI Builder model. You can be able to explore and see like all the various components that we have here. So just a minute as it loads. And also like down below here, we have the models where you can be able to see all the models that you've been able to create. You can also be able to retrain your model. So like, let me just refresh this page. Okay, as it loads, let me just head over to Power Apps Studio. So like, as you can be able to see, when I click on this explore button here, I can be able to explore all these capabilities that we have within the Microsoft AI Builder. And as you can be able to see, we have the documents. So if I click on documents, it brings me all the documents that I want to use. We also have, if I click on text, we need, you can be able to get all the managed services that you want for text, maybe sentiment analysis, classify customer feedback. So if you want to classify a customer's feedback, maybe on a product, maybe on customer service, then you can be able to use the category classification and the text like to be able to do that. So, and if I go to the structured data where you want to predict future outcomes from like from historical data. So like with these, you can be able to predict like how much sales are you going to make, or like when is likely like a person to pay their invoice based on some historical data. So like this means like structured data where we have a uniform way of handling data. And then finally here we have the images where you can be able to extract all the text and photos in PDF documents. And also like second, we have the object detection where you can be able to detect custom objects in image. And for this specific demo, we'll be using the object detection under the custom model. And also, as I mentioned earlier, that it's very easy for you to use where you can be able to access all the tutorials here, or you can be able to get started. And also, you can just quickly jump onto one of the tutorials here to help you get started, and also be able to see all the companies that are actually implementing the Microsoft AI Builder and the how-to videos, and also see how the customers are using this. So let me just jump straight into the demo. So, and for you now to start a demo, so like you just navigate on models and click on this button here. So build a model. So once you can be able to click on that, so like the first step that we had mentioned earlier on is choosing your AI model. So for us, we want the custom model. So if I just scroll down here, I can be able to see where we have the custom model. So once I click on that, it will just inform me like these are just like some of the kind of tutorials. So I can just click on get started. So once I do that, it will navigate me now into now training the model, and also choosing where my data is being stored. So just a minute. So as it actually loads, so like this is just a model that I already trained. So like I'll just quickly edit these models so that I can be able to show you step by step. So once we have it, you can be able to see everything that is here. So if I click on edit this model, so it's loading, so just a minute. Yeah, so like I'll just click on edit model. So like so that it can be able to create a new version. So like you can be like this will be the new version now before being published. So like after I've done the changes, I can be able to publish this version now for use. So so I've clicked on create edit these models so that I can be able to show you the step by step way of achieving this. So this is just now like selecting your model's domain. So like this is just kind of a tutorial that you want to see. And also like you can be able to see like this AI builder model can be able to like detect that this is a skateboard. If I just click on these other ones, it can be able to also like to see these are a combined harvester and also the count of images here, and also like this is a drone. So if I just click on next, so like this is where we're going to be able to do that. So we need to choose objects for our model to be able to detect. So for these, we have two types of images. So whether we want to know like if this person is pneumonia negative or pneumonia positive. So just by choosing those object names, so like you can be able to do that. So if I click on add a new object, so I can be able to specify that specific object and what I want to achieve out of it. So once I'm done with that, I'll just click on next. So I need to select where my data is being stored. For me, my data was being stored within my device. So I downloaded all the images like for training, and I trained like 33 images. And one of the minimum qualifications for you is you need to train at least 15 in each object category. So if I need to add an image, so I'll just click on add an image, select where your data is being stored. So for instance, myself, it's being stored under my device. So I'll just click on device and be able to locate where we have those like data. So like if I can just click on this pneumonia positive, so I can just be able to choose an image. So I'll just choose that image and then upload that image. But since it's already been uploaded, it will notify me that this object has been uploaded. So in just a minute, it uploads. So one of the good things about this is that like it actually like notifies you that there is a duplicate images and it's being ignored. So like once I've been able to do that, I can go now to tag all my images. So and as you can be able to see here, I was able to train 17 pneumonia positive images and 16 pneumonia negative. And if I want to add more images, I'll just click on this to add more images. So let me just show you how actual tagging is being done. So like for instance, you want to tag this is a pneumonia positive. As you can be able to see, this chest is not actually clear, like meaning this person might be like pneumonia positive. So now like for you to tag this image, so like you just tag the area that you want this image to be tagged. And as you can be able to see, like I was able to.
Your presentation's going great, but we want to let you know you have 2 minutes left.
Okay, yeah, I'm actually almost done.
Great, thank you.
Okay, so like once I'm done tagging all the images, I'll just click on done tagging and I click on next. And now this is the model summary. So like I can just be able to click on train. So the model will just take a couple of minutes, not more than 10 minutes, and bingo, there you have your model. So once I'm done, just click on go to details page, and like you'll be able to see the score that you've got. So like this will be 86%. So like if you want to use this model, if you're satisfied, you can just be able to use this model. So if you're not satisfied, then you can go to add more images. So like, let's just do a quick test before I wrap up this session. So like, let me just upload one image. So if I just click on this third image here, so that we can be able to know if this person is pneumonia positive or negative. So just a minute, and bingo, there we have our prediction. It's pneumonia positive, and its score is 42%. So let me just try pneumonia negative patient. So let me upload one more image and then call it off. So if I just click on this pneumonia negative, so I'll just click on this and just click on this image. And if we can be able to see, bingo, there we have it's pneumonia negative and its score is 30%. So like, for you to get a high accuracy, you need to train more models. So that's it for me. Let's engage. Thank you so much. Thanks so much for your time. Back to you.
Thank you so much for your presentation, Sandra. It was really great, and we learned all the available features of AI Builder. So thank you for
Thank you so
joining
much.
us. So
pleasure.
we're going for a short break, and we're coming back in a few minutes with our next presentation. Hi everyone, and welcome back to the Global AI Student Conference. In our next presentation, we will learn how to build a bot using the Azure bot services. Let's welcome our next speakers, Tina Popley and Aditi Sharma, two Microsoft Learn student ambassadors. Hey Aditi, hi Tina.
Hi.
Hi. Thank you for joining us. How are you?
We're good.
I'm good. How are you all doing?
Good. We're very excited for being here. So, we would like to know you a bit better. Can you tell us a few things about yourself?
All right. So I'm Aditi Sharma. I'm a Beta Microsoft Launch Student Ambassador, and I'm currently in my bachelor's degree. So I'm currently at Sri Venkateswara College of Engineering in my third year. So off to Tina.
Thank you, Aditi. I'm Tina Popley. I'm a Gold Microsoft Learn Student Ambassador, and coincidentally, we both are from the same college. And I'm in my fourth year of my engineering and a software developer intern as well. Looking forward for this session.
Thank you. So, you can share your screen and we can get started.
All right. So is my screen visible?
Yes,
Yes.
it is.
All right. So, okay. So thank you everyone for joining in. So today we'll be, in today's session, we'll be walking you through the basic concepts of AI. So get ready to build your first AI chatbot. So before we start up, we know that while building a chatbot model, we have three configurations. So first we have the execution package, then we have our intent package, and we have the backend model. So the intent model basically describes the user intentions of covering both the texture and the graphical intents. So that's like when you have your images or text, or when you just click on a button, or there are a lot of different options and you have the radio options. So these are basically defined as your intents. So the whole point of basically having a front end is it acts as an interface between the user and the backend of whatever is to be executed. So the Azure Bot Services basically provides us with an integrated development environment for building, and it's integrated with the Power virtual agents. So it's fully hosted and it's a low-code platform. So it enables all the developers to enable their technical abilities to build conversational AI bots, and it's like we have no code needed. So coming to the bot framework composer. So the bot framework composer basically is an open source IDE. So it enables you to manage conversational experiences. The developers have to access language understanding to train models with natural language processing capabilities and adaptive dialogues for dynamic conversational flow. So we also have the language generation to help convey clear brand voice and Q&A maker to extract the FAQ. Then the packages are basically a game changer in the framework composer. So why are packages actually important? So they increase the need of rewriting the code, and they increase the extensibility with better sharing capabilities. Not only this, it basically allows you to connect with skills seamlessly. So now I would like to ask Tina to share her screen and walk you through the actual making of the bot.
Thank you, Aditi. I hope my screen is visible.
Yes, it's visible.
Okay. So as Aditi mentioned about all the various ways of creating an AI chatbot, today we are going to show you using bot framework composer. So let me go through the bot framework composer. So today we are going to do a hands-on for joke bot. So as soon as you trigger, as the user puts a message like joke or tell me a joke, please tell me a joke, the AI chatbot gives you a trigger with respect to a joke using API call today. So before even starting how to create a bot, let me show you a simple sample of it, that how does it work actually. So I'm going to start the bot. Meanwhile, this is the bot framework composer. It is divided into 4 sections. So the leftmost is the navigation pane, having all these options. This is the bot experiences. So as and when I keep creating conditions, triggers, and bots, it's all going to appear over here. This one is the canvas. So this one is the canvas, and this is the property lane. So let me open web chat and let me tell a joke. So the bot responds with sure thing, how many apples grow on a tree, all of them. So let me again tell, please tell me a joke. It again triggers and gives a joke. So let's go back to how to create the simple joke bot. And let me go here, home, create new. So there are 2 options. Either you can create with C# or Node. So I'm going to do it with Node, empty bot. Next. And let's name it as joke bot sample. Okay. And create. So it might take a few seconds to minutes to load up all the packages. And I would say that this is not a no code, but it is a low code tool. Why am I saying this is because once you create the bot over here at the background, so I hope you saw the location where I saved it. I saved it in the C drive as of now. So whatever location or path you have entered as the location path, the code is going to be saved there. So there are 2 ways. Either you can run your bot here in the bot framework composer, or the second way is to download the code from that location path and run it in your desired IDE. For example, let's say Visual Studio Code. Or the third option is just give it to your developers who are going to continue with the same code. So these are some of the options where you could actually make use of this AI bot. Let us wait for it.
Right. So I'd like to add a point. So Azure is basically a pay-as-you-go platform. And so whatever you are using on Azure, so you will basically only pay for the essentials or the needs that you're accessing or using while building your model. And as you saw when Tina wrote a joke on her web chat, so it automatically triggers a joke. And even when she says, please tell me a joke, you get a joke. So joke is the main keyword that we are using. So we'll tell you how you can actually integrate this joke in your chatbot and how your bot actually recognizes and how Azure, this bot framework composer is reducing your whole need of writing a lengthy code of finding the keyword.
The keywords, yeah.
Yep.
And this can be deployed using Azure. And okay, so it has started. So you can see the default greeting and unknown intent. So this, as I clicked on the empty bot, it's going to let me create a AI chatbot from the scratch. So as a beginner, at a beginner stage, you can make use of this very easily. So let's go to the greeting. So you can see the joke bot sample, there's nothing. Let's go to greeting. So what does the greeting do? As soon as you enter the chatbot, you would have you would have seen that there was a greeting called as welcome to your bot or welcome to your joke bot. That is where the actual response of the bot is actually starting. So let us do one thing. Since it's starting from here, let us edit it and say welcome to your joke bot. Okay, enter. So you can see that it's changed. Welcome to your joke bot. And one more thing, I missed sharing it there, but as if I would not have put joke or please tell me a joke, let me say I would have put hello, hi, how are you doing? That wouldn't have given a response in this scenario. So instead of not giving a response, there is an unknown intent saying, sorry, I didn't get that. So that comes under my unknown intent. So let us start. So in bot framework composer, there are terms like triggers. So what is a trigger? As soon as the user enters any value or enters a phrase, the bot actually triggers the action and again responds it, right? There are various kinds of triggers. Let me create a new trigger here. And before actually doing this, let me, okay, this one, add new trigger. Intent. Let me give a name, joke intent. Okay. Write an expression. Okay, there is some error. Let us see what is the error. Condition there does not match. Okay, let us do this. Yeah. So let me change the default recognizer to regular expression. What does my regular expression do is, you might have heard of regular expressions in various languages and while learning. So we'll put an expression or a pattern or a formula, which is actually going to match the bot. So let me add a trigger now. And let's say intent, you would have seen the intent recognized. Let's put joke intent. Okay. And okay, joke dot dialogue. Okay. Yeah. Now, so you can see a joke intent which is created, which was not initially there. Now, you can see this plus sign where we are actually going to add conditions. So this particular what you can say, a section of the bot framework composer is nothing but your canvas where you're actually going to drag and drop and actually make conditions. So plus, so whenever I put, as a user, I put the phrase joke or please tell me a joke, what does the bot do? It said sure. So let us create a response, send a response. It will say sure or sure thing. Let me do it for you. Okay. So we need to make the bot as a human, right? You need to get the feeling that a human is actually texting you or messaging you with replies. So sure thing, let me do it for you. Now, due to time constraint, we have used an API call. Let me show you how. So once the bot says, sure thing, let me do it for you, it takes jokes from this particular API call. So you can see there are various jokes here, right? Now let's go back and create a HTTP request, send a HTTP request. So we use get method, and let me put the URL. Okay, URL, and yeah, here we put joke dot. Okay, let's create a new one. Let's delete it, create a new one, send a HTTP request. Get. Okay. Now, after it sends a request, actually, what does it do? So once the user says joke, then the bot replies, sure thing, let me do it for you. It's actually going to take the joke from the API call, right? For that, we have sent a HTTP request. Once you have sent the HTTP request, the bot has to reply you with the joke. So let me show you the call again. So this includes the setup and the punchline, right? The content includes the setup and the punchline. So what am I going to do here is again send a response, because the joke is coming in the form of a response, not a HTTP request or not a dialog box, right? So once I do that, I can do dialog, or for easier convenience, I can just copy this. Get here. Okay. I don't know why this is not coming. Dialog. Why am I doing joke response is because it is stored in the form of joke response here, and we are taking it in the form of joke response, which is again coming in as a sender response. So through dialog joke response, it is taking the setup and the punchline content. So let me show you. So let's go through the flow once again, right? So how does the flow starts? It starts with greeting. We have welcome to your joke bot. It comes to the unknown intent only when the phrases of the triggers does not match with these triggers, which is the joke or the, let me add the triggers. So triggers must be joke, or let's say tell me a joke, or yeah, this should be fine. Okay. So as soon as the trigger matches with the joke or tell me a joke, it immediately comes to this response, that is the joke intent, which is with respect to the trigger phases. Once it sends a response, it comes to the API, and many a times within our websites and apps also, we call the API. Through that, you can send in your AI chatbot, which very easily using the bot framework Composer. So you have the get request, you have the result property, and once it sends a HTTP request, it again comes to your chat and sends in the response. So let's check whether it works or not. Start bot. So there are two ways of starting a bot. Let me show you. One is through the web chat, as I showed you earlier. Second is through the bot framework emulator. So let us check both the ways. Yeah, so it started. Let's check to the open. Okay, welcome to your joke bot. Joke. See, it works now. Sure thing, let me do it for you. What did the zero say to the hit? Nice spelled. Let me say, tell me a joke. This also work. Please tell me a joke. This also works. Let me do hello. Doesn't work. It goes back to the unknown intent which says, sorry, I didn't get that. Right? So this is a basic method of creating a simple joke bot, as a bot. Now let me run it through the emulator. So you need to use the bot framework composer. You need to install bot framework composer. So I'm using the version 2.1.2. And to use the emulator, you need to again install the bot framework emulator. So let us see, the bot has started. Welcome to your joke bot. Joke, or let me say hello. Hi. Sorry, I didn't get that. Okay. Joke. Okay, so it triggers with a joke over here. So this is a simple method of creating a joke bot, and you can make this with respect to various fields. It might be your, for example, you might have seen some hospital websites having chatbots. You might be having chatbots in various university websites, in various websites, because these days, as we have already seen so many sessions, and even Aditi mentioned that AI has grown to the next level, right? So let us create more and more, let us grow the technology with more and more knowledge we have. And I'm looking forward to see many more bots by all of you. Over to Aditi.
Thank you so much, Tina, for walking us through the hands-on of how you can make your bot. So just to summarize on what all you have covered. So while in the starting, you mentioned about C# and the Node.js. So you can show that how and where it's stored.
So yeah, I missed out that. So this is the joke bot we created right now. We have an option called a show code, right? So this is the code actually. So we haven't created this code, as I mentioned. This is not a no code tool. It is a low code tool. So the location I have saved this bot, there all my code is actually saved at the backend, right? So as and when you keep adding triggers, you keep adding condition, dialog boxes, and more intents, everything keeps on adding to your code, which can then be continued with your desired IDE or the same IDE, or you can just pass it on to your developers, and they can continue creating the bot.
Yes, so C# or Node.js doesn't actually mean that you are supposed to be coding in that language. It's just that when you store your code or see your code, it's stored in that particular language. So as you can see Tina sharing her screen, and you can see there are two options which she mentioned in the start, that's C# and the Node. So you can use both of them. Both of them will provide you with the same framework, that's the front end. But in the back end, your code is basically stored in C#, and that's why you have been provided with two languages in whichever you are comfortable with.
Yeah.
So just to summarize on our, Tina, you want to go?
Yeah, I was just mentioning that these are various templates you can use. This was the basic level. We created from the scratch using the empty bot template. There are various templates like chat bot, core bot with language, bot with question and Q&A maker, assistant bot. All of these might be advanced at a level, but looking forward to all of you using this one by one and letting us know how you did it.
Yeah. So we'll just summarize our today's session. So we talked about how Bot Framework Composer and the Azure Bot Services basically provides us with a low-code platform to make our own bot. And Azure is basically pay and go platform, and to make your own bot, you need to install the bot framework emulator and the bot framework composer. Also, if you're using the Azure services, so you can use the Azure services tool too. Tina, you can show the Azure services
You
too.
can also sign in with your Azure account, and using your Azure account, you have features like Azure bot. So previously there was web app chatbot. Now you have Azure bot as well, which you can make use of to create such bots from beginner level to the advanced level and deploy it within your Azure account and take it forward.
All right. Yeah. So we have triggers and intent to basically identify and process different keywords and qualifiers in the bot. And then it makes our work easier by the autofill in with the syntax. And then we do not need to save our code again and again or whatever we are writing on the bot compose framework. So we can just run our restart our bot, or we can just start our bot again from the web chat which Tina showed.
Yeah.
Yeah, so is there anything, Tina, that you would like to add in? So I have summarized the points.
Yeah. So there is one more way of creating chatbot using Q&A maker. So that is also included here, although you can go to the website and create one. So I can show you here itself. So when you go to home, create new. So you can see this Q&A maker, which has templates already existing for with respect to the Q&A, right? So empty bot, we had options to create with various dialog boxes, triggers, and conditions, regression, this regular expressions, and so on. So all of these have their own purpose and levels to use. You can see here you can see the description here as well. Empty bot starts from the scratch. Q&A maker is for the question and answer bot, and assistant bot. And one of the previous session also had speech, right? So you can also include text to speech to text, and various ways of including technologies in the bot. So yeah, this is all about our session. Hope you enjoyed, and let us know if you have any doubts further using our LinkedIn IDs or anything.
Well, thank you so much for your presentation. I remember like one of the very first like tools that I ever created in Python was creating a bot with code. So seeing how you created it in like AI Maker in our platform was just super cool.
I'm not able to hear.
Yeah.
There you
Tina,
go.
you
Can you
can
hear me
stop
now?
share.
Can you hear me
Yes,
now?
I can hear you now.
Oh, that's
Yes,
fantastic. My mic was not on. But what I was saying was, first of all, thank you so much. Your project was really cool. I remember hard coding a chatbot as like my very first project when I was learning Python. So seeing it in Azure was super neat. And we have two questions for you. The first is, once you create your bot, can you publish it onto an app or website and share it with people?
Yes, you can deploy it either using Azure, or you can, as I mentioned, that there is a show code option or the downloadable code option. You can download the code and proceed further with your own methods of deploying the chatbot.
Awesome. Great. Thank you so much. And our second question for you is, right now, like you created the bot using low code. Is there a way in the future, like say you wanted to add more detail to it, to then add code as well to it?
Aditi, you want to take over?
I did not get the question.
Yeah, the question was, so right now you created the bot entirely with low code. Let's say you wanted to add like some more complexity to it. Could you add some code to it later on?
Yes, you can add your code, because as Tina told that you have the show code option. So you can add the code, you can see the pre-existing code. So if you're stuck, and you can carry on writing your own code. But you'll have to keep in mind of the integrations that are done inside the Azure Frame Composer. So you'll have to keep that in mind.
Yeah, you are free to use it in your own IDEs. This is for a low code method wherein you're just getting it so quickly and easily, right? So that's the whole point of creating a bot here.
Awesome. Well, thank you so much for joining us on the stream today. Your demo was extremely impressive, and also your detail was amazing. And I think we're about ready to go to our next speaker. So let me welcome to the stage. We have disaster risk monitoring using satellite imagery with Kevin McFall. And Kevin is a master instructor for the NVIDIA Deep Learning Institute. And we're super excited to hear more about your presentation in a little bit. Awesome, and we're back at the Global AI Student Conference, and we are here with our very next speaker, who is Kevin McFall, doing a talk on disaster risk monitoring using satellite imagery. Kevin, it's so nice to see you.
Yeah, so cool to be with you guys today.
Yeah, and how are you doing, and where are you tuning in from?
I'm tuning in from the southeast corner of Germany, near Salzburg, between Salzburg and Munich. It's a beautiful, sunny, snowy day here.
Oh, that's amazing. It sounds, first of all, that sounds absolutely beautiful. And initially I was like, oh no, are you from the United States? Because it would be like 4 a.m. there right now. Well, we're super
Indeed not.
excited to get started with your talk on disaster risk monitoring. Feel free to take it away.
Okay, cool. I just want to make sure I have an hour, is that right? Or I just want to make sure I get the pacing right.
Yes, you have an hour.
Sorry about that. I'm back. Let me go ahead, and I'm going to go ahead and start by sharing the screen here. Let's see. There we go. You know what? First, I need to go in the chat, because what I have to present for you guys today is actually an interactive lab. You know, I'll be presenting this, and I'm going to be giving you a connection to be able to work through these exercises on your own. So give me 1 second here. Let me switch my presenter. So do you see this? Does everybody see the screen? Is that good?
Yes, we can see the screen.
Okay, cool. I want to drop in the chat for you a link that I'm going to show here in a little bit. So I want everybody to be able to see that link, because that will take you to the hands-on activities that I'm going to show you today. So the idea, I want to first start off talking a little bit about the problem statement and the sort of idea of what we're trying to solve and what you can learn about today through this course. So the idea is disaster risk monitoring using satellite imagery. And this is sort of like an overview slide. You know, you might have like the satellite that's going around the Earth and collecting images. In the actual data that we're going to use today is actually radar, and it sort of visualizes the radar to make it look like a picture. So you might think like you're seeing a picture, but it's actually radar data. And so the idea is you've got this satellite that is giving you all of these, you know, the Google Earth and all of these pictures of the world. And we have to be able to there's got to be a way to use this to do good things. You know, there's all sorts of disasters that happen. There's landslides, there's, you know, the Hawaii, the volcanoes erupting in Hawaii now. And we're going to focus today in this little course here on floods and trying to prevent floods. And so the idea is you're collecting this information from the satellites. It's getting stored in some sort of data center. And you want to build a machine learning, a deep learning model to be able to do something with that. So you're going to train, this number 2 is, you know, training your deep learning model. You're going to have a bunch of different models in repository that you can do something with that will detect a flood or detect a landslide or anything like that. And you're going to use this to then deploy it and manage the model being run, because if you're going to want to do something real to help people, you're going to want this to be happening in real time. Okay, so you're going to need to have some sort of a tool to be able to manage and get this to happen in basically near real time, so that you can get immediate updates of what's going on. And that's going to feed back here, okay, across 4 to get, you know, watching the model performance, seeing how fast it is, making sure everything's working the right way. And of course, you can go back and fix things. And this can be an iterative loop where you're going to make improvements and get everything to work the way you want. But then essentially, when it's in operation on this number 6 here, you're going to be getting these inference results. And inference is just a fancy word for, as you know, for you know, using your model to make a decision. And then that can go to a front end where maybe there's scientists or people in government that are trying to manage a response that can use it, or you can even push that out to user devices, give a warning to somebody's mobile phone. So this is sort of like the bigger picture of how you might build one of these systems. Now, what we're going to focus mostly on today is essentially 2, 3, and 4. Well, I guess really 2, 3, and 6, really, where you're going to build a model, you're going to get it ready to be deployed, and then you're going to go ahead and use do inference on the results and get something that you can work with. All right, so that's sort of the overview. And these are, these pictures on the top are what I was saying before is these radar images that are sort of converted into something that looks like a picture, okay, that we can sort of look at. It's not really RGB, but it basically looks like an image to us. And the goal of the model that we want to build is to take these images and be able to segment them, okay? And to segment an image means that you're going to color pixels, basically classify pixels to know the white pixels are water and the black pixels are not, okay? And so that's the type of model we want to build. And I'll talk here in a bit about how we're going to use a UNet to do this. But this is the overall picture of what we want to do. Now, that link that I put in the chat, that's going to get you to the NVIDIA's Deep Learning Institute course. And this course, Disaster Risk Monitoring Using Satellite Imagery, is a free course for everybody. So you guys can get in there, you can share it with your friends, everybody can work through this. And as you'll see here in a minute, that you will be working with the code. There's Jupyter Labs that you can go line by line and work through the code to understand how things are going. Now, I want to mention this because essentially, I want to do a little bit of a deep dive into the technology behind the UNet. I'm going to talk a lot about computer vision because this course is essentially freestanding, and you don't even really need me. I could be quiet right now, and you could take the link, and you can go and watch that link and go through everything yourself. So I don't want to repeat the things that are in the course because there's a video that explains everything, and the code is very well explained in the Jupyter notebooks. But I want to make sure that you're able to unlock this so that if you have any trouble, I can help you here towards the end of the hour that we have together. So this is the link that I put in the chat. And hopefully you all can get that. If you're having trouble, you can go to courses.nvidia.com. And if you go into the self-paced courses, there's these online courses, and then you'll find it. Otherwise, you can use this direct link, and I put that in the chat. So once you get into this website, you'll need to register. You'll need to create an NVIDIA developer account. It's really straightforward. You just have to put in your email address, and that's like when you click here to log in, it will bring you to this website. Or you can do courses.nvidia.com/join. But either way, it'll get you here. You put in your email address. There'll be a little bit of a form to fill out. Do make sure you use an email address that you have access to because it will ask you for a confirmation. Okay. Now, once you get yourself logged in there and click on enroll here, once you get, let me go back here a second. Once you click on enroll now, once you're logged in, it brings you to this page here, which is the course. And once you get here, you can click on this direct disaster risk monitoring using satellite imagery to move on to the first page. And it brings you here. And this is where I was saying there's a video that explains all of the background much better than I could in terms of the way the problem statement. And like I said, I'm going to take a bit more of a deep dive into the UNet here in a minute once I get you started. And so you'll click down here on this start button, and that will spin up a Microsoft Azure instance where all of the hardware that you're going to need, all the GPUs, all of the computing hardware you'll need to run the course will be running on a Microsoft Azure virtual machine. So you don't need any extra hardware to get in here, and it's great. You won't have to worry about that. And then once you click on start, it might take 5 to 10 minutes for it to allocate the resources, but be patient. It'll spin around for a while. But that's why I'm letting you know in the beginning how to do this so that can be sort of running in the background while you're listening to the stuff I have to say about the actual technology here in a minute. And then you click here on this launch button. You'll notice that there is a timer. It will kick you out after 5 hours, and you have a total of 17 hours in the virtual machine. It does cost some money to run those, so we give you 17 hours to be able to work through that. It should be plenty enough time for you to work through all the exercises. So when you click then on that launch button, that will bring you into the Jupyter Lab environment. And it's really self-explanatory. It'll walk you through here. It tells you, the introduction. If you haven't worked in Jupyter Notebooks before, it'll show you how to do that. So that's sort of, the process that you're going to do to get into the course and get into all these, there's all these different Jupyter Notebooks with code in there that you're going to modify and play around with. And essentially, this environment will teach you how to use the different technologies to build the building blocks for that sort of overview that we're looking at. Okay. All right. So that's going to get you into the course, and you can work on that now. It actually is recommends it's about a 4 hour long course. And again, I don't want to hash over the details because you can spend the time there. What I'd much rather talk about is computer vision tasks in general, and then get into segmentation in specific, because the course does a great job of walking you through how to use the technology, but it doesn't talk a lot about the specifics of what's going on under the hood. And I thought that some of you might really enjoy a walk through convolutional neural networks and how to use that for the segmentation task that we're interested in today. So just as a bit of an overview, there's several different types of computer vision tasks. The easiest is classification, where essentially you've got an image and you want to say, is this image the class that I'm looking for, or is it not? So for example, on your phone, you put that little bounding box, around your face when you're in your camera app, right? So you might want to detect, is there a face in this picture or not? So, that's a face, that's a face, that's not a face, okay? So classification is assigning a label to the entire image, okay? Oops, sorry. So there's other tasks that you can do as well, okay? That's detection. And detection is like what I was saying in your camera app, that it's going to put that bounding box
Hey there, Kevin. I think your audio just cut out. Oh, it's back.
I think I'm back.
Yay,
I'm
awesome.
back. All right, sorry about that. So object detection is going to tell you not just the label, but it's also going to give you a localization for it, okay, with the bounding box. Now, what we're interested in is segmentation, and essentially segmentation is a pixel-wise classification, that every single pixel in the image gets a classification. So you're getting a much better boundary on the face than just a bounding box that's rectangular. And that's what we're trying to do today, is segmentation, okay? Now, there's several different kinds of segmentation. What we're after is sort of the simplest version, in a way, semantic segmentation, where you're gonna, all the pixels that have to do with cats are going to be one color, and all the pixels of the background or the table are going to be other colors. For us, it's going to be water is one color and everything else is going to be another color. There are things like instance segmentation, and that's a combination of detection and semantic segmentation, where, okay, you identify with a bounding box each of your objects, but then you find what pixels are for each one of those instances. And so now we can see 3 different cats instead of one big blob of catness, okay? And then, of course, panoptic segmentation, that's like the combination of everything, even the background, not just the objects we're trying to find are being segmented, but the background as well. Okay, but for our purposes, semantic segmentation works just fine when we're trying to do water and not water. Now, I'm an old guy. I've been doing machine learning and deep learning for many, many years. And I was doing machine learning before deep learning existed. And one of the great things about deep learning is that the features are essentially calculated for you in a neural network. In the old days, we would have to do traditional computer vision to sort of take the image, this image of a flower, and extract information out of it. Back then, we didn't have powerful enough computers to be able to just feed the entire image in and let the computer figure everything out. And so, for example, if we're trying to say segment this flower and identify all of the pixels that are inside the flower, we might want to know the edges. And you can see, in this image, we've identified where the edges are, and then we can maybe do like a flood fill or something like that to find, to segment the image. Maybe we're trying to identify what color this rose is. And so maybe we do a threshold on the red, on the R pixels in our RGB image. And then we can say, oh, are there very big blobs? Are there giant blobs of red in here? Oh, that must be a red flower, okay? Or maybe we're trying to identify how many floors there are to this building, and we apply a Huff transform or something like that to identify where the lines are, and then we can count the floors. And so this is what you had to do in the olden days to calculate these features before you fed that into your neural network. Now, of course, these days with convolutional neural networks and, of course, vision transformers and other things that are coming, we don't need to do that. We can just feed the entire image in. Now, I wanted to go ahead and talk about those old days because this idea about convolutions existed long before deep learning. It was a traditional computer vision technique. And I'm going to talk a little bit about how convolution works, okay? So here's a 3x3 kernel, okay? And essentially this is just a little matrix, and it has values in this matrix. In this case, I made them to be binary values. Of course, normally they'd be floating point and I'm back.
Oh, yeah,
Sorry
you're
about
back.
that.
Awesome.
Okay. Yeah. Sorry, it's a little glitchy today. In any case, let's say you've got an image like this, okay? And it also has ones and zeros, just to be simple. And we take this kernel, and we're going to put it over the first overlap of the first upper left-hand part. And these maroon values are the kernel values, and the bigger values are the ones of the image. And what we're going to do is we're going to do an element-wise multiply. Here's 1 by 1. Here's 1 by 1. Here's 1 by 1. So there's 4 1 by 1s, and the rest are zeros. And that 4 will give me this pixel. And so then we're going to shift that kernel over 1 pixel and do the same thing to get the new value, shift it over again to get the new value. And then we're going to keep rastering that, bring it down to the next one, shift it across, and we're going to keep convolving this kernel over my input image, and it will calculate a new image. It's what we call a convolved feature or a feature map, okay? And this is a new feature. By using this kernel, it will tell me new information about my image. Now, you notice that this image is a little bit smaller because the kernel had to sort of be inside the image, and you could pad the outside of that image with zeros, and then you could make the feature map be this kernel and transforming the input image into something new. Now, what might some of these kernels look like? These ones are called Sobel kernels, and they give you essentially the horizontal derivative or the vertical derivative to see how much the image is changing in the horizontal or vertical direction. And that could be interesting for us. So let's say, for example, we've got these very simple images, and we want to classify which of these has a square. And the squares, well, it's got a horizontal line at the top and the bottom and a vertical line on the left and right. So those Sobel kernels could help me to be able to see whether there's vertical or horizontal lines in my image. So this is applying the Sobel X to each of the 3 images. This is applying the Sobel Y to each of these images. And you can see by applying this kernel, we're getting a new image that tells me something about the previous image. Here, we just got a whole bunch of mess in it. There's not really any lines because it's more like a circle than a line. Okay, and here I see there's vertical lines, but not really horizontal lines. So we're starting to get information out of our image that we can use to classify. Now, there's 9 by 9, there's 81 pixels in this image, and surely we can tell, if you look at this image, we can tell that there's lines there without all 81 of those pixels. So we could reduce the resolution of our image to make things easier and actually faster to compute because it's smaller. And what we could do here is use a max and we could look and see what is the brightest pixel in that 3 by 3 area and make this entire area that color. And then we could move to here. What's the brightest color? Ooh, that's very white. What's the brightest color here? Oh, well, that's all pretty much the same, okay? And so we could do this max pooling, and it makes our lives easier and simpler and faster because we don't need all of the resolution in the original image. Now, it's pretty easy to see, well, look, let's look on the left side. How bright are these pixels? Let's look on the right. How bright are those? Let's look at the top. How bright, etc. And so essentially, if it's a square, if the average pixel value on the left and the right and the top and the bottom, if all of them are high, then that should mean that it's a square. Okay, and so I'm walking you through here as a very simple example and sort of, hand designing this program. I'm not doing any machine learning here, but I'm showing you essentially the process that the convolutional neural network is going to go through. Now, how do I go about this process of saying if those pixel values are over a particular threshold, make a decision? And that's where our activation functions come in. Now, this step function, the blue one, that's the one that we originally used in the very first perceptron networks, the very first neural networks. And they use that because that's what happens in our brain. Our brains are binary. Either our neurons fire or they don't. If they collect enough information into their inputs, then they'll fire, and if they don't, they won't. And so that's what the step function is, okay? But as you probably know, these neural networks operate with backpropagation. And in backpropagation, we need to have the derivative of that value, okay? And we need the derivative of our activation function, okay? And if you look at the derivative of the step function, it's 0 everywhere because it's flat, and then it's infinite at an input value of 0. So if we're looking at the gradient or the derivative of the step function, it's either 0 or infinite. And that's not going to be very helpful. And that's where the sigmoid comes in. It's basically a nice, smooth, differentiable step function. It goes from 1 down to 0, okay, but it does it smoothly and differentiably, okay? Now, that's great, but if we look at its derivative, the largest derivative that it has is 1/4. It's a small number, okay? And in deep neural networks, we have many layers. We maybe have, you've seen hundreds of layers in some of these deep networks. And if I'm going to multiply 0.25 times 0.25 times 0.25, or even worse, what about like 0.01? If we multiply all these small numbers together, it gets very small, and that's what we call vanishing gradient. And that's why so often we use the ReLU function. Now, first of all, it's super simple. It's very easy to calculate, but it also has a derivative that's 1 for an entire half of its input range, okay? So yes, the ReLU is simple to calculate. It's faster, especially for deep networks, but it's also less susceptible to vanishing gradients. So, the whole reason I was talking about this was because I wanted to talk about, setting a threshold and firing, okay? And that's what we're going to use. We're going to use the step function for that. But if we're going to do backpropagation, we'd have to use one of these others. Now, all that's important with the activation function is that there's non-linearity, okay? The ReLU is piecewise linear, but overall it's non-linear. And that's the only important thing about these activation functions, is that they have non-linearity in them. So normally we'd use a ReLU, but I'm going to talk here about using just a step function because we're not using backpropagation here. So here's our input square. We're going to do convolution on it. We're going to do a Sobel X and a Sobel Y. Okay, and then we're going to do max pooling on it to reduce its size and make it easier to handle. And then we're going to take all of those 18 different values and flatten them out and feed them into my neural network. Okay, and this top part is telling me about the left, the right, the top, and the bottom. And so what we can do then is take each one of those. We want to take the average of each of those. So we're going to multiply each of them by a third and add them together. Okay, and then we're going to apply a threshold. We're going to take a constant value and subtract, say, 0.75. What I want, if it's a perfect square, it's going to be perfectly white. It's going to be a value of 1 perfectly. But it's not perfectly 1. So if it's above 0.75, we'll go ahead and say it's a square. So we're going to take the average of them and subtract 0.75. And as long as the average of all of them sums to be more than 0.75, then I'm going to get an output. Okay, and that output, if that's greater than 0, my step function is going to fire. If it's less than 0, then the threshold dominates and it doesn't fire. And so then I'm going to take all of those, combine them together. I want them to equally contribute. So I'm going to give them all 1s, and I'm going to compare them to, say, 3.5. Is it close to, we want it to be 4. We want all 4 of them to be. And then we're going to, again, set another step function. And if it passes through that, then it's square. So what we have here is some convolutions. We have some pooling. Then we flatten, and then we have fully connected layers. Now, this isn't truly fully connected because all of these inputs are not feeding into each one of these nodes, but you could imagine if all of these guys had 0 weights multiplying into that node, then you could make this to be fully connected, okay? So we've got a fully connected layer here, assuming some of those have 0 weights, and then we have a fully connected layer here. All 4 of these feed into that. So we've got a convolution part that extracts the features, and then we have a fully connected part that makes the classification, okay? Now, I did all of this by making human decisions to make this work. But what the convolutional neural network is going to do is these values in the convolution kernels and these values for the weights and the biases, those are going to be what are automatically updated through the supervised training technique. So I don't have to, as a human designer anymore, calculate these features. This convolutional neural network does that by itself. And that's what's really cool. So this whole architecture, we can sort of summarize it down by having a 9x9 input, then 2 convolution feature maps that are 9x9, and then max pooling down to 3x3, then flattening 18, then having fully connected 4, fully connected 1 at the output, and we're good to go. Okay? Now, what are some of the, that's a dummy problem. What are some of the real architectures? Okay, that one's very simple. Okay, here is something, there's essentially the very first convolutional neural network, one of the things that Jan LeCun is very famous for. And this came out actually in 1998, which is amazing how old it is. And here you can see it's much more complicated than what we have, but it essentially follows the same process, okay? It has input to convolution feature maps to max pooling or some sort of pooling, subsampling you call it, okay? More convolutions, okay? More pooling, and then fully connected layer, and in this case, maybe they're trying to tell the difference between the numbers 0 through 9. That's why there would be 10 outputs, okay? And so that's a very simple convolutional neural network. Of course, AlexNet in 2014 became very famous. That's when deep learning really started happening, and we really were moving into the deep learning revolution. Okay, now that's for classification. How would you do detection? The simplest way is with a sliding window search, where you have this window move across your image and you perform classification. Come on. Okay, so we got
Hey, Kevin.
back here.
Oh, we're back. Awesome.
Yeah.
Do you want to you want to take a
So
pause to rebuild your machine?
No, I don't think that's the problem. I think the only other option is going to my phone, but then I can't do the presentation. So I don't know. I think I don't think a reboot's going to help. So I think we might power through.
Awesome. Well, you're back, so you've got this.
Okay. All right. So we have this question. In this example, applying the convolution seemed to blur the lines. Those lines got blurred. Now, and yes, they did get blurred in a way, but the important piece was to change this input image into something we could use, okay? And yeah, it got blurred, but there still was white there. And I guess the really big takeaway is we as humans will pick this kernel and we'll get this blurred result. But what's going to happen is the computer will automatically choose what these kernel values are. And if it's blurred and it still gets a good result, it won't care. It'll keep changing these values until it gets some sort of feature that helps it get the output. And so, yeah, this is an imperfect example with a human selecting the values, and it's just a dummy example. But the beauty is that the supervised learning technique will optimize what these kernel values will be so that it won't be blurred, or it gets at least what it needs to be able to get the right answer. So it's a really good answer, and I think the sort of good question. The short answer is the network will adjust them to get just the right fuzziness or clearness or whatever it needs. It will optimize itself. And that is something amazing. And to be honest, that is what got me back into doing machine learning and deep learning. I did a lot of machine learning, then I got into robotics, and then deep learning came around. It's like, hey, this is really cool. You need to go start working more in it. So that point is really, really interesting. So there's this sliding window search, which, as you can imagine, is going to end up being a little bit slow because I have to do lots of small. And so then RCNN came about. And what it did is it did region proposal. And with region proposal, it didn't try every square possible, but it had a network to try and predict which places were the best to be. And that was a bit more efficient. And then about 2 years later, YOLO and SSD came around, and they used a single network. You only look once. That's what YOLO stands for. It once, one pass. You don't have to do lots of different things. Okay, and so that is that's sort of where the state of the art is for the most part. There's been improvements on all of these, but that's basically how you do detection. Okay. All right, now we want to get to segmentation. And to talk about segmentation, most all of the networks of segmentation networks are based on the idea of an autoencoder. And this is a image of a vanilla, very simple autoencoder. What an autoencoder is, you put your input in, and you want the network to output the exact same thing that you. So the autoencoder's purpose is to take the input and get the same thing come at the output. And the reason this is interesting is bottleneck. And essentially, we take the large amount of input data and we want to make it into a smaller space. We want to encode it in, essentially boil down all the important information. And if this autoencoder can make the input smaller and then recreate the output pretty well, then it must have learned the important features of the inputs. Okay, and basically this network is trained by looking at the difference between the input and the output, called the reconstruction error, and the weights of the network are optimized to make that reconstruction error as small as possible. So this idea of taking the input and encoding it into something smaller is how we're also going to do semantic segmentation. Okay, so this is an image of a U-net. Anybody want to guess why they call it a U-net? It looks a little bit like a U, okay? And in the U-net, what we do is we take our input image, we perform a bunch of convolutions, we do max pooling or some sort of pooling to make it smaller, go through a bunch more convolutions, make it smaller, more convolutions, smaller, more convolutions, smaller, until at this point we have represented our image as a vector, okay? Well, almost a vector. It's 32 by 1024, but it's reasonably small, okay? And so we've got it as this vector, and then we're going to upsample. We're going to make it bigger. We're going to do the opposite of a max pooling, and then we're going to do more convolutions. Opposite of max pooling, make it bigger, more convolutions. Max unpooling, you could call it, and then convolutions, unpooling convolutions. And then in the output, we're not trying to get the exact same thing as the input, but rather we're trying to get a segmented image. So it's similar. The output's going to look similar to the input, but it's going to be segmented instead. Now, one important piece to this U-net architecture is skip connections, where it takes things from the input side and it copies them over directly. So the original image essentially here is being copied over and concatenated or added in here. And these skip connections do two things. One of them is it allows information to bypass that bottleneck, okay? Because there might be important information here that could be useful over there. The other piece too is that it helps us reduce the vanishing gradient because this value is copied over. All of the relus that it has to pass through in here, all of those activation functions has to pass through, get skipped by. And the gradient can pass very quickly without having to be multiplied by the derivative of the activation function. So these and they help carry information forward. So this U-net is the architecture that we're going to use in our segmentation, in our network problem for doing the So that gives us an overview of the U-net architecture, okay? And the one last thing I want to talk about is how does this happen, this upsampling? We already talked about how the max pooling can make things smaller, but how do we make things And this blog here talks about some really good ways a little bit longer, but there's a couple different upsampling methods. There's nearest neighbors, interpolation, max unpooling, and this is basically the opposite of pooling. But there's no parameters for the network to optimize. What we can do instead is we transpose convolution, where we take our input and we apply a kernel to make things bigger. We have a 2x2 input image, and we want to make it a 3x3 larger image. We take whatever value is in the kernel here, multiply it by all 4 of these, and put that in this place of our image. Then we take the 1, we multiply the 1 by all those and put it here. Just put it here. And the 3, all of them, and put it here. And then sum together. And so the original image looks like this guy here. They're similar, okay, but they're modified by the kernel. And again, just like when we talked about how the blurring was happening before, and the convolutional neural network can choose what the kernel values are to get the right output it needs. Okay. We struggled with the connection. I'm very sorry about that. I apologize. But I threw about talking about the presentation. So what I
Hey, Kevin. Would you mind leaving the call and coming back without sharing your video? We're gonna see on our end if that changes the audio at all on our end.
I'm switching over to my phone, and I know that's going to work because I made the presentation I needed. Now I can just be here and answer questions for folks. So hopefully
Fabulous.
that will work better. All right. So I've walked you through all of the essentially theory that I wanted to, and so I want you all to go to that course page now, okay? And if I was on my computer, I'd be able to share the screen, but I want you to get to the course page and try and get yourself in there. And let me just take a pause here for a bit and ask if anybody has any more questions. There was one really good question that somebody posted, and if you have any other questions for me, I'd love to answer them. And let me know if you're struggling getting into the course platform to be able to run the actual lab.
I just had a couple questions on my end for you I'd love to ask. I think we have time for. I know one thing you brought up in the let's see, in the semantic segmentation is you make your image smaller and smaller and smaller to and it takes away the detail. Is there a point where it's you have to watch out before it gets too small, too vague for you to not be able to extract any value out of it?
Yeah, I think there definitely is a point of that. I mean, the thing to think about is we've got images that are huge. I mean, 4K, thousands by thousands. And obviously we don't need all of that resolution to be able to see whether there's a cat eye or, or whether there's a blob of water. And so, using all of that resolution is just wasteful of computation. And so, yes, we want to pool down and build these features that are smaller and smaller. But I think absolutely you're right that at some point there's going to be a problem there. And if you go back to that architecture with that UNet, it went down. It had 32. So it had basically 32 by 32 image, 32 by 32 pieces in there. And so that's still reasonably big. But that's the standard UNet architecture, and every problem is going to be different. And maybe there are bigger features in your image that you're wanting to capture. Now it was 32, but if you remember, I think it was 1,024. So there were 1,024 32 by 32 images. And so if one of them captured something, another one that might be next to it might capture something else. So in that sense, you're capturing all this information in there, but I do think there could, it depends on the problem. If you crush too far down, especially if you make that bottleneck in the middle too small that it can't carry all the information forward, then there definitely could be a point where it gets too small. And you just have to, that's one of the things as deep learning engineers you mess around with. You see, does this architecture work? Does tweaking this make it any better? So certainly that's something to look for.
That is super helpful, and like your explanation was absolutely amazing. I have one more question as well. And like one thing that you were bringing up specifically in like the various upsampling methods is like there's a lot of different methods to do like the upsampling. And so as an expert, is there like a time and a place like where to use one specific method versus another?
I mean, for me, the go-to one is the transpose convolution, and of the ones that I mentioned there. And because it's the only one that is parameterized, the others are good. Like, the drawback of the transpose convolution is that it adds more compute. And so, if you're worried about compute, then maybe you go to a straight up interpolation. The interpolation is going to be pretty decent. And it'll probably give you good results. But if you have the computational power to be able to add in the transpose convolution, the neural network gets to pick those kernel values. I can't emphasize how awesome that is. Being a machine learning engineer that had to do all of that by hand, let the data decide what the upsampling should look like. Let the back propagation choose that. So for me, I'm always going to choose that transpose convolution unless I have some sort of issue with the compute not being enough, and then I'll go with something like interpolation or one of the others.
Maybe even like an expansion question on that is like the level of compute needed for something like that. Like I think like, is it possible on like your standard laptop, or like I know OpenAI has like their entire backbone is in Microsoft Azure. So what type of compute power do we need here?
Well, I do work for NVIDIA, so I have to mention the GPU. I'm legally required by that, right? So I guess the answer is you can do a lot of this stuff on your laptop at home. And hey, if you got a gaming laptop and got a GPU in there, you can use that to help accelerate things. But unfortunately, in today's age, if you're going to do anything meaningful, like the chatbot we were talking about previously, you're going to need more compute than just what you're going to have on your desktop. Now, that's where Microsoft Azure and others come in. You don't have to own this anymore. It used to be, and I guess maybe you still might buy a giant hard drive. You might want to have a terabyte hard drive at home, okay? But you can get a free Google account, and I don't know, what do you get now for free on Google or Microsoft on your OneDrive? What do you get for free on a Microsoft OneDrive? You can get a lot of storage for free there. And that's sort of where we're heading now. You don't necessarily have to own your own gigantic workstation with a GPU in it. You rent some time on Microsoft Azure and get a cloud, get something going in the cloud, and then you only pay for what you use. If you're a super heavy user, like you do this for your work, yeah, maybe it's worth buying some hardware. But as a student, as a casual student, there's lots of free ones out there too that you can use. So, so I think you're definitely going to want more compute than just what you have on your desktop laptop. You can mess around with some toy problems and stuff, but if you're going to do something meaningful, go with something in the cloud.
That is absolutely amazing. And I have some more questions, but I want to see, do we want to go back to the live training? And I can always come back to my questions if we have more time at the end.
Well, I mean, what would be interesting for me is if there's anybody having trouble getting access to that training. That's what I would like to know. And, like I said, if I had my computer instead of my phone, I could, sort of do a screen share and walk you through there. But just out there in the audience, are any of you having trouble? And if you are, let me know and I can try to help troubleshoot you. And the other thing, that's one thing I forgot to put in the chat, is my email address. It is kmcfall, KMCFALL @nvidia.com. If you can please blast that out to everyone. I'd be very happy if you're having trouble getting connected to the hands-on training, follow up with me afterwards. I'd be super happy to connect with you. Please share my email address. And if there's anybody having trouble, now we've got another 12 minutes or so. I'd love to help troubleshoot if people are having trouble getting access to that.
Awesome. I'm checking on my end very quickly, and it looks like nobody's having trouble, but I think being so helpful, sharing your email is just, it's so kind to do for all of our students listening in today.
Well, I'll tell you, I'm trained as a mechanical engineer. All of my degrees are mechanical engineering, and I just backed into AI by chance. It just happened to be that the first job I took out of my master's degree was working with computer vision and neural networks, and I got totally hooked and been doing it ever since. So I'm just really excited to share, my experiences and help encourage all of you students out there to follow what you find fun and interesting. And man, this deep learning stuff is so cool. And there's so many things. I mean, with the chat GPT and all of the generative models, stable diffusion and all of that, there's just so many cool things. And it's a great time to be in this technology, and just happy to help all of you students out there, leapfrog into this if that's what you're interested in.
Mm-hmm. Even, I know one thing that you talked about with your experience is how you were doing work in robotics, but then came back to computer vision because you found it so fascinating. But have you done any work at like the intersection of both of those technologies?
Yeah, absolutely. Before I came to NVIDIA, I was a university professor, worked in a mechatronics engineering department, and I was working a lot in autonomous vehicles. And so, we did a whole bunch of, using object detection, to identify pedestrians or cars, and that is really cool now, is that there's so much interesting hardware to be able to do machine learning at the edge, that you can get hardware to put on a robot that has a little GPU on it and can be able to process this stuff. So yeah, I mean, there's so many cool things you can do putting AI together with robotics. And I mean, it's kind of interesting, the traditional, if you call it, robotics approach is, you build a control system and you do all this sort of hand engineering things, like that way I was showing of doing that square detection. You do everything by hand and can verify and have total control over everything. That's sort of the robotics approach of how you, build an autonomous system. And then you have the machine learning, way where, you can do a total end-to-end one, like you take the picture coming out your windshield of your car, and you feed that into a neural network, and the output of the neural network says, what steering angle and what throttle on the pedal should you have. That's sort of the total end-to-end one. And then of course you can have, approaches in the middle that are a hybrid, but that whole tension between the robotics approach and the end-to-end, deep learning approach, that's just a really cool battle out there to see, which way is going to win. So there's just so many cool things to talk about.
That is just, I mean, like, your enthusiasm and excitement about it makes me super excited about it. And I think I feel like we're starting to get into dangerous territory, because we know you'll be on our AI and education panel later today. So I don't want to steal all the questions that we really want to ask you then. But with that, I think my next question for you is you've been in the industry a long time, you've done academia, and now you're back in the professional industry. And what are the trends in AI, in computer vision, that you're really excited about?
Yeah, well, when it comes to computer vision for AI, I mean, everybody's got to watch out for these vision transformers. I mean, transformers basically made LSTMs completely, useless overnight when it came to natural language processing. That was about 5 years ago, that suddenly, recurrent neural networks were totally useless. Okay. And I think that sort of thing is coming. I spent a lot of time today talking about convolutional neural networks. In a year or two, I may have to retire that presentation and never show it again, because vision transformers are coming. So, if we're talking specific about computer vision, these transformers or these mixed mode models where they're taking both vision as well as language or other things and combining them together, I think that's definitely where things are headed. Just in general, though, a big trend in general, not just computer vision based, I would say is ML ops. Okay, we spend a lot of time talking about training and building the algorithms, and that's great and necessary, but we don't spend enough time talking about actually deploying them and putting them in service and making them work and making them work well. And that doesn't it's not nearly as sexy as, training the model and messing around and hyperparameter search and all that, but it's so important. There's so many surveys of companies that have built a machine learning system and proven that it works, but then never get it into production. I mean, some surveys, it's as many as 80% of these models that get trained never actually get used. So if you want to be valuable to a company, figure out how that last step, that inference step, and doing the ML ops, that's where companies really, really need expertise.
That is, I think, extremely insightful. I feel like I had one final question, but then it slipped my mind. Will it come back?
But there's too many cool things to think about.
I literally, you know what, that is so true. And you know what? It's starting to come back. Oh, that's fantastic. Okay, coming back to the lab, the course that all of our viewers can do. And I would love to hear about applying the flood analysis in real world scenarios. Obviously that's even from my hometown in Seattle, Washington, there was flooding I think a year ago. Actually, I think in January. So that's something that's very real for a lot of the world.
Absolutely. And that's the big challenge now. I mean, AI has proven to be useful and to be mature enough that it can solve real problems. But that's what all of you guys as students need to do. You need to take us to the next step. You got to move beyond us old geezers that have shown that it works and put it out there and use it for good and find ways to, help your communities with these things. Find ways to make these better and more ethical and good for the planet and good for people and good for society. That's your guys' challenge for the next generation, is take these systems that can do good things and you guys make them and turn them into things like flood detection, all these other things, for hurricanes and whatever it happens to be. There's so many things you guys can envision to use them for. Let's do it.
That is, I think, an amazing final message. I think, do you have any questions?
No, I think I'm okay. And we have Kevin our panel, so
yes,
we and our audience can ask more questions about AI and the future of AI.
Yeah, and I know we have a little more time. So, Kevin, do you have any final notes for the audience before your panel later this day?
What I would say is, there's lots of other free courses that are at the Deep Learning Institute. So if you go to courses.nvidia.com without the other stuff in there, just courses.nvidia.com, poke around in those self-paced online courses, because there's stuff on natural language processing, even cybersecurity, all sorts of things in there. Some free ones. And we have a whole bunch of other educator programs too. So if you're at university and you have a mentor, faculty mentor, we have all sorts of other things that we can do to help you get more training through the Deep Learning Institute. And so reach out to me. You got my email address, and I'm very happy to help all of you in your journeys with AI going forward.
I think that is absolutely amazing. Oh, yes. And so, thank you so much, Kevin, for being on our call today. We're super excited that you'll be back in a couple of hours for our panel. And because this was an extremely fun, not only talk, but also a conversation at the end. And now we'll let you go and take a break before we talk with you more later. And then we've got a little bit of time before our next speaker. So 2 announcements here. The first is you can claim your learning badger at aka.ms/GAI- badger. This is like your very own NFT that you can download to your own personal wallet. I personally have an AI ambassador badge. My co-host Fatini also has multiple badges, so it's a very awesome opportunity. We also, once again, want to remind you that you can do I forgot the name, I'm so sorry, our Learn Challenge. So everyone who is watching the stream today can go participate in the Learn Challenge, learn about different Microsoft Learn AI modules, and then you'll be on a leaderboard where you can see where you stand, but also complete it to learn more about the awesome parts of AI. And I think we'll take a short break before our next speaker comes on stage.
Hi everyone, and we are back at the Global AI Student Conference with our next speaker, Emre Kikiman from the Research Center of Microsoft. Hi Emre.
Hi,
Welcome to the show.
We're doing good. How about you?
Thank you so much for joining us. Can you tell us a bit about yourself?
Of course. My name is Emre Kujaman. I'm a researcher at Microsoft Research, where I work on causal machine learning and its applications to decision making in particular.
This is amazing. So you may share your screen and you can start your presentation.
Sure. Great. So thanks, everyone. I'm really happy to be here. This is an exciting event, and I hope everyone's enjoying the presentation so far. So my talk is going to be about the foundations of causal inference, and I'll also talk a little bit about our open source causal analysis tools that make causal inference a little easier. So just a quick note, of course, this is work that we're doing together with many collaborators, both at Microsoft Research and in the broader community. I'll thank them at the end. And right now I'll just dive into why causal inference. Once we talk about a little bit about what causal inference is and what it's good for, we'll go into 4 steps of causal inference to kind of make the process a little bit easier, and then I'll talk about our open source suite to help people get into and scaffold the best practices of causal inference. So first, I want to say a little bit about what are causal questions. So let's start by reviewing what is a causal question. So a causal question is focused on a cause and effect relationship, usually where we want to analyze or make some kind of change in the world, and we need to know what the effect of that change is going to be. For example, some of our partners want to know how their model and, so for example, we might want to know how an ad campaign affects user conversions. We might want to know how farming practices affect soil carbon sequestration. We might want to know who is going to benefit from a drug or not. So these are all decision-making tasks, asking something about the world and how it works in order to enable some kind of critical application. And these decision-making tasks, now, AI has had a tremendous success in capturing complex patterns and leveraging them for things like classification and generation, but oftentimes we find that decision-making and asking what-if questions is a little bit harder. And the reason is that machine learning success usually relies on something that's called the IID assumption. That is, that the patterns that we see in our training data mean the same thing as the patterns that we see in our deployment data. And the problem here is that new decisions often change these patterns. So for example, when we apply machine learning to digit recognition, we find that this recognition accuracy drops to maybe 64% under rotations. Just very simple changes to the patterns in our data. This is the case where normally we would expect recognition to be around 99, 100%. Similarly, we see that object classifiers fail when we see 3D perspective shifts. For example, rotation of a stop sign might fool an algorithm into thinking that something is not a stop sign, but a dumbbell or a racket, something that's obvious to us as people. And studies have found that this occurs in more real-world settings with real-world data as well. In particular, a study of hundreds of chest scan COVID classifiers identified that instead of detecting COVID, these classifiers actually detected something else about the image. So, for example, in one data set, a classifier was trained to identify the COVID versus non-COVID chest scans, but instead it identified whether people were sitting or lying down during the chest scan, because the people who were sicker tended to lie down. So that was a false kind of a spurious correlation that the classifier found it easier to pick up on rather than actual signs of illness. So how does causal AI help this situation? How does it help us break apart some of these spurious correlations and patterns and focus in on the patterns that really mean the same thing as opposed to the ones that might be changing? Causal AI helps by focusing machine learning models on a cause and effect relationship that, that are stable. For example, in this scenario, we see that we have some data here where we've captured some variables z and x and y, and we want to know what is going to happen if we make a change. What if we change this x1 value to from 20 to 100? What would be the output result here? Now we might think that, well, maybe the output result y comes from this variable here. So if we change it to 100, maybe y will be 100. But what if this y didn't take its value from x1, but took its value from something that happened earlier? This is z. Then what will y be? Will it be 20 still or 100? Clearly, our understanding of what's causing y to change over time is going to greatly influence what we believe is going to happen when we change x1. And so the way the causal AI helps here is it focuses on these cause and effect relationships that we believe are stable and independent. They're grounded in the real world, and these are going to be robust to kind of outside changes that we might be seeing in the system. We do this by getting some kind of systematic reasoning over domain knowledge. So we're going to bring our knowledge of what these potential causes might be, these arrows, into the system and use those arrows to guide our data modeling and the learning of the potential relationships among these features. In a way, you can think of this, if we want to get a little bit more mathematical for a second, we can think of this as being an observation over a joint distribution of these three variables, x, y, z, and that conventional machine learning just learns one joint distribution, that this is how the distribution of the world works across all these variables. And when this relation changes, say because we are switching a value of a variable from 20 to 100, this distribution is no longer going to match the new changed world. What causal AI does is it builds a model of a factorized distribution. So instead of just being one joint distribution of all these variables lumped together, we're seeing a little bit more structure here based on where we put these arrows. This factorizes this distribution into, say, multiple distributions, and we can pick, as we change z, what is the world going to look like. So I want to get into one maybe a little more specific example of why this is particularly important for decision making, and that's that decision making can, and that's just to illustrate how decision making itself can change the data distribution. Let's say we have a simple task in the agriculture domain. We're going to irrigate based on our predicted soil moisture levels. We're going to train our models of predicting soil moisture levels on years of sensor data from real fields. And we're going to ask the question now. Now we're ready to deploy. We're out in the world, and we're going to say, okay, it's going to be really hot in 2 days. What do I need to do to water? Do I need to water my fields? Is the soil going to be dry or sufficiently moist on these really hot days? The model is going to say no. We don't have to water. The soil moisture is going to be very high. And this doesn't make that much sense. It's really hot weather. Wouldn't we think that the soil is going to dry out? Well, the problem is that the models are only predicting high moisture because the farmers in the past have always watered on the hottest days. So in a sense, we have this relationship here where we're asking a question about, what is the effect, what is soil moisture going to be based on hot weather, and we're ignoring in our model the influence of our irrigation decisions or our irrigation policy. Once we decide to change this irrigation policy, we're also affecting the model of how hot weather affects the pattern between hot weather and soil moisture as well. And that means that our decision making based on this model is going to fail if we don't take that into account in the first place. So how do we take that into account? I'm going to go through the 4 key steps of causal inference. We are going to first model to create an encoding of our assumptions, those arrows that I mentioned before. Then we're going to go through a step of identification. This is about formulating what we need to estimate. And then we're going to go ahead and compute that statistical estimate, and then we're going to double check our assumptions. And that last step in particular, I'm going to highlight as being very important. So modeling our assumptions. This is about taking our knowledge about how the system, about how whatever it is that we're modeling, the system, the world works, and then converting this into something a little bit more formal that we can reason about. A good model exposes the key causal relationships between the variables that we are observing and capturing and other variables in the system, including the one that we're trying to ask a question about, the kind of what we're going to be changing as part of our decision. The model is capturing the assumptions about how these variables affect each other, and in particular, it's affecting. We're capturing the direction of the influence. We don't need to specify all the causal relationships, but really the more complete, the better. And by sorry, we don't need to specify all the causal relationships. I should highlight that we do need to capture the relationships between the features we're observing. If there are features that are exogenous to the system, we can play around with how we define our system in order to compensate when we don't have full knowledge of things. And if we ever aren't sure about a relationship, we can add an arrow just in case. The arrow means that there might be a relationship. So we don't have to know for sure, but we do have to encode when we are unsure. So the edges encode, in this case, here's an example of 4 features that we've been observing, A, B, C, and D. And the edges, these arrows encode potential mechanisms where we think A might influence B, we think C might influence B, and we think B might influence D. A key assumption here is that the missing edges don't exist. So there is no way for D to change C, for example. And from a formal point of view, what this graph is encoding is that there's a statistical independence, that if we know B, we can predict D without knowing A or C, for example. D doesn't depend on A or C except through its influence through B. Now, the key intuitions here, as I said, is that the assumptions are encoded by the missing edges and the direction of the edges, that these relationships represent stable and independent mechanisms. That is, other things outside in the world change, these arrows are not likely to change. And that's what gives us some more trust in the robustness of these models when we're going in and changing our decision-making policies, and et cetera. This graph, interestingly, can't be learned from data alone. It's something we have to bring from outside the data set itself in the form of domain knowledge. We can learn the graph to some degree, but in the end, for any given data distribution, there's going to be a set of graphs that all can possibly explain that data, and it's our domain knowledge that will help us choose which one of those graphs is the right one. And it's important to note that graphs are a tool to help us reason about a specific problem. When we ask a different question, we might need to bring in different information that wasn't relevant before. So, for example, one graph might be looking at the effect of user fatigue on our observations of people, say, their outcomes from their usage of an online website, for example. So we might have something we control on this website that affects what they do. So this might be whether I use a feature in in Office? Or do I, what am I clicking for on search engines, or what am I buying on an e-commerce site, for example? Now, whether or not, or what my interests are and what I've done in the past is going to influence what I do now, and is going to influence whether or not I see a particular opportunity, maybe on the website. Maybe this is what leads me to a particular product, and then I'm going to decide now whether I purchase that product or not. And maybe my purchase of that product is also going to be influenced by how tired I am, for example. Now, here this encodes several assumptions here that user fatigue, for example, doesn't change what I'm interested in. Past clicks don't directly affect the outcome, for example, and we can keep reading off what these arrows mean or don't mean. Now, when we're asking a question about what is the effect of this treatment, this variable that we control, maybe whether we're highlighting a particular opportunity, whether we're putting a message in front of the user to tell them about a new feature that was released or something, what is the effect of that going to be? Well, when we look at our data, we can see that because of these multiple arrows that are influencing both whether someone sees this message or so, and this outcome here, we're going to have to disentangle the influence of for example, the user's past interests and its influence on the outcome from the influence of this message or this treatment itself. So this is going to be represented by a new graph that we want. It's basically we want to compute. Basically, we get to see the data generated by this graph from our real world data, but we want to answer questions about data that would be generated by this intervention, where this treatment is completely independent and disentangled from everything else. So identification is about figuring out how we can take this question where we have a clean kind of signal about the effect of treatment and why without any influence from anything else in the graph. And we want to figure out how to calculate this from the data we can observe on the left-hand side. Now, one way to do this is through a randomized experiment. Often we run a randomized experiment where we flip a coin. That coin flip that decides whether or not to show treatment to someone independent of everything else is essentially generating this interventional graph here by construction. And so in this case, we can directly read off how this treatment affects the outcome that we care about directly from the data we observe from the randomized experiment. But if we don't have this ability to run an experiment, then we have to start to identify how to disentangle those other variables. There's several different approaches to identification, and we're not going to go into the technical details of them here, but they are implemented in the tools that I'll talk about at the end. So the third step, once we know what we want to identify, once we have the statistical expression that we're going to compute, then we start to look at how we're going to compute that from the data we have right now. A common way to estimate the effect of a particular treatment is to match data points that have the same kind of background variables that we think are entangled up in our observations, and match them up and compare their outcomes. So for example, let's say we have a data set where there's a number of people in our control group who haven't been exercising and a number of people in our treatment group who have been exercising, in this case, like bicycling. The question now is, well, what's the effect of bicycling on some outcome that we care about? Maybe it's some health measurement, blood pressure or something else, cholesterol. And what we're going to do is we're going to find pairs of people who are identical, very similar, according to some metric, and except for one difference, and that one difference is going to be whether the people are biking or not. So you can see we've lined up our population here, and they're all exactly the same, except for the fact that on the right-hand side, we have a bicyclist, and on the left-hand side, we don't. Now, once we see this now, we can, this is like now, this subset of the data is like a randomized experiment. If we look at any particular attribute of these units, we're going to see that the people who exercised and didn't exercise are exactly the same. There's no entanglement or influence on whether people are biking or not in this data. There's going to be some people that we weren't able to match up, and then that's going to basically limit, who we're talking about when we talk about the effect of the bicycle. But otherwise, for this part of the population on top, we're going to be able to correctly identify the influence of the bicycle on the outcome that we care about. Now, what identification gave us was the list of the attributes that we need to do the matching on. So, for example, in this case, age is one of those attributes. Maybe whether someone is wearing a hat is another one of those attributes. Now, matching is one particular algorithm, but we do have a lot of challenges here around how we handle variance and bias and how we trade off some of these issues. For example, what do we do if there's many people who look very similar on one side of the data and less people on the other side? Then we might have issues that we have to resolve. There's many different machine learning based methods that help with this and take us beyond simple matching approaches to more complicated approaches. And these methods are also in our open source library as well. Now, once we have analyzed this data and we've gotten our estimate of a result, we have to make sure that we trust it. And how do we do that? In machine learning methods, conventional correlational machine learning methods, we often get to test our analysis against a outcome that we already know. We have some holdout data that's been labeled, and we get to do something like cross-validation to give us a very kind of quantitative measure of whether our analysis is working or not. The challenge in causal inference is that we're asking a question about something that we don't always get to observe. So, for example, when we were changing our values before from 20 to 100, we don't actually necessarily get to make that change beforehand and see what the value is. If we do get to change it, we don't know what else might be affecting that. Maybe that value. So if we make the change to 100, then we get to see the outcome, but we don't know what would have happened if we kept the value at 20. So robustness checking becomes a little bit more difficult here. In particular, our estimate now depends on many assumptions of our algorithm. We have to validate that, ask ourselves during the modeling step, did we miss any unobserved variables that we should have matched on, for example? During identification, we might wonder whether our identification algorithm made some sort of parametric assumptions about what the data looks like. Or our estimation step, do we make assumptions that might lead to higher variance than we would desire? And now again here, the goal is to gain trust in our analysis results. And so we recommend running a number of different tests on our assumptions to try to validate them if possible. That's rarely doable. To refute them, to try and prove them false otherwise. And if we can't prove them false, then that helps us a little bit. And then finally, to run a sensitivity analysis to ask ourselves about how wrong we would be if our assumption is a little bit wrong or a lot wrong. And then we can use our domain knowledge to understand how much we believe our assumptions and what the impact of it on our final result would be. So those are the 4 steps: modeling, identification, estimation, and then robustness checks, validation, refutation, that is. Now, to help people through this process, it can be it can be very different in some scenarios from conventional machine learning, especially in that validation, refutation, and the encoding of our assumptions. We have built out an open source suite of tools for causal AI. This consists of 4 libraries that we have out in the open source community. The first is DoI, which is built for scaffolding the best practices in causal analysis end-to-end. EconoML, which really focuses on the sophisticated estimation method that bring in the latest in machine learning for causal inference. Causica is a library that uses deep learning methods for causal discovery. This is about trying to get as close as we can to that first causal graph or modeling assumptions from data, kind of like a bootstrapping based on a different set of assumptions. And finally, the 3 libraries here, DoI, EconoML, and Causica, are all Python libraries. We've put on top of these tools a ShowY for no-code interactive usage by data analysts who maybe aren't coders, for example, or for data scientists who can code but want to quickly explore these results. I'm not going to go into too much detail here with a coding example, but I did want to just highlight how straightforward the APIs are. So the first the first thing we do here might be causal discovery, where we load in our data, provide some domain knowledge, what we're already willing to say about constraints that we want to put on this graph. For example, we know that there's certain edges that are connecting our data already. Then we want to discover the rest of it. Once we have that discovered graph, we're going to run that's now our modeling step. The next thing we're going to do is identification. So given that we want to, say, identify the effect of providing technical support on revenue, then we're going to come through and we're going to say, identify the effect and tell me what I need to estimate here. Once we have that estimand, we're going to feed it into our estimate effect function, and we're going to let the library know which method name we want to use, what statistical estimator we want to use. And after that, we're going to go through and call our refutation functions, our sensitivity analyses, iterate through all the different methods that are available, and look at the results to see if they're holding up to our tests. And then over this set of Python functions, we can use our interactive no-code tools that support causal discovery and exploration, that look at effect inference, the 4-step process that we went through in detail, or a different approach to effect inference in the context of policy changes over time. So, for example, a law passing or something that affects many people at once. Now, our tools are pretty popular. They're open source, and we're seeing a broad academic and industrial usage. We're expanding these tools to incorporate new causal tasks, in addition to expanding them with stronger no-code and user interfaces as well. At this point, I think I have a few minutes left. I'll stop for questions and say thank you to the whole team in our collaborations.
Emery, and yes, we do have a couple of questions for you. First of all, thank you so much for your amazing presentation. And my very first question for you is it up to humans to identify like irregularities or assumptions, or can the AI identify the irregularity on its own to make itself more robust?
So some of the assumptions a human has to bring to the table. So our core domain knowledge, for example, that graph parts of that are going to, at least parts of that are going to have to come from a person. But when we talk about the assumptions that are made about, like, I think I mentioned things like, what are the parametric assumptions that our identification algorithm makes? Those are things that come along with the algorithm. We know that a particular method makes a particular assumption about the shape of the data. And then that implies that, we should run a check of some kind on that. Yeah, so we can track what assumptions you need to run based on the analysis that you're doing.
Awesome. I think we have time for one more question. And I know, like, you're talking about causal AI, it's currently, you can do it in Python, and there's also no code solutions. Are there any other languages you can use with causal AI?
Yes. So we don't have libraries to support it, but there is a lot of functionality in R for these analyses as well.
Awesome. That is super cool, Emery. Thank you so much for coming on to the Global AI Student Conference today. I hope you have a fantastic rest of your day. Thank you so much.
Thank you for having me. It was great.
And now we get to pivot to an extremely exciting stream because we have one of our guest speakers in the studio with us. So I'd love to introduce you to our next talk, which is Smart Parking in Modern Cities, Challenges and Solutions. And we'll introduce Vadim Porvatov, who is a master's student at the University of Amsterdam. And then joining us remotely is Anastasia Martinova, who is an applied mathematics student. Yes, feel free.
Sure. Hello, my name is Pravat Vadim, and today I, with my respected colleague Anastasia Martinova, will tell you about artificial intelligence applications in parking lot occupancy detection problem. So let's begin our talk with a little motivating example. Have you ever had a problem with searching for a non-occupied parking lot? Probably in Western Europe it is not a big challenge, but in other parts of the world it can be quite a hard problem, especially in Eastern Europe and America and in Asia. The main reason behind such situation is lack of officially allocated parking spaces on the streets or in special areas, and undeveloped policies regarding the parking in the yards. In this slide, you can see the typical yard somewhere in the middle part of the Russia, for example. However, it is not the terminal stage of the parking issue. In some cities, like in St. Petersburg, it is the second largest city of Russia with population that exceeds 5 million. We can observe such situation where cars occupy not only the side of the roads, but its center part too. Unfortunately, despite the clear violation of multiple policies, such as practice emerged to be something normal for citizens of St. Petersburg as the population becomes larger of St. Petersburg and the city become overcrowded. Similar situation can be observed not only in this city, but in other cities of Russia, and not only Russia too. Okay, the last example will be too apocalyptic, I think so, because if you were so unfortunate to once park your car in such a location, in the next morning you will not find a way out just from this trap. Okay, but let's shift our focus from these a bit exaggerated examples to something more relevant to the actual statistics. The parking lot problem is influenced by two actual trends, motorization trend and urbanization trend. Despite the expected decrease of the number of cars per thousand of people in Europe, in other parts of the world it will grow, certainly, especially in the locations where the parking issue is expressed at most nowadays. Okay, what do we expect from the solution of this interesting problem? We need to establish such a system that will solve three questions. That will solve three problems. First of all, we need to detect from some observation infrastructure non-occupied parking lots. Then we need to establish some route from the current user location to these observed free parking lots. And additionally, it will be extra beneficial to predict future availability of parking lots. Will they be empty after 10 minutes or 20, for example? In our current study, we will focus mostly on the prediction of the real-time availability. Well, and how our solution can be expressed in terms of application, for example. Okay, it can be a client-server app that is connected to some observation system based on video cameras. These video cameras can be connected together to broadcast the images, for example, once per 60 seconds. This broadcast is then translated to the predictive algorithm that will identify in defined desired locations. Are there any empty spaces that can be occupied by your car, for example, or not? In such setting, we can formulate our task as a binary classification challenge. And if we are talking in this way, we can just shift further to the possible approaches that can solve this binary classification task. So, when we are talking about image processing and machine learning, one of the first things that come to our minds is convolutional neural networks. It is the really old architecture that was established more than 20 years ago by Jan de Koon. It consists mostly of three types of building blocks. First of all, it is convolutional layers parameterized by their kernel, obviously. The second one is large variety of different pooling operators and batch normalization, of course. Well, the key properties of convolutional neural networks are the following. First of all, it's their depth. Such architectures as VGG and ResNet have demonstrated that number of convolutional layers can significantly increase the generalization ability of neural network. However, there are interesting problem that is known as vanishing gradient problem. So it was a big issue with the VGG neural network, for example. However, it was resolved successfully in ResNet architecture, where authors just add so-called skip connections that preserved the informational flow from vanishing. The second direction that is utilized in order to process some images and infer some predictions is recently emerged vision transformers. They are mostly based on a common technique that came from natural language processing. The key idea is the following, that we can split input image in some segments, organize them in the sequence, just like some sentence, for example, and fed directly into transformer encoder in order to predict something. In our case, to check whether in our image, in our patch of the image, there is a car in some parking space or not. Okay, let's talk about the main specific designs that were applied in the area of parking lot occupancy prediction. First of all, there were several attempts to implement really trivial architectures like AlexNet, they were successful, and the authors achieved quite good results despite the simplicity of the given approaches. Deeper architectures obviously performed better, but not significantly. Some specific approaches like contrastive feature learning and Siamese neural networks lacks of comparison with the other models, and the last one method was based on combination of heuristics and object detection model that extracts some bounding boxes of the car and compare them with the predefined locations of parking spaces. They were not so good as other models, but still, we will give them a try in our own study to show us better results. Common problem of the given approaches is the following. The data that was utilized before was quite limited in sense of specific data categories, and by the specific data categories, I mean the lack of proper annotations. We will reveal it in the next slides. So let's proceed to the datasets, what they contain exactly. The first one is the PK load, parking load dataset, the most common benchmark, but despite its distribution among the studies related to parking lot occupancy detection, it is not so expressive as others that we will discuss further because of its explicit simplicity. There are no so many occlusions, distortions, or any other kind of real-world visual noise that make it very simple for CNNs or vision transformers to handle. Scenery Park is a better option to evaluate your prediction model because there are many different angles, a lot of occlusions between cars and trees, which is a common scenario for real-world application too. The last two published datasets are interesting. ACMPS 2 times larger than PK lot contains some more hard to process data, but not as challenging as CNR Park. And the ACPDS dataset is the smallest. It's simply tiny. But however, it consists of images with perspective distortions, and there are a lot of categories of data, yet they are not annotated enough, good enough to use. As I mentioned before, common issues are problems with categories, with annotations, and the simplicity of certain benchmark that, despite of that, was used as the main approach, as a main benchmark in some studies. Okay, what categories were not established in our previous in the previous studies in the dataset related to them? First of all, it is winter data. It is challenging because of obviously some snow can cover cars, and these make predictions less reliable. Night is an option too in CNR Park and ACPDS. There are some images without any annotations and occlusions. Most of the biggest datasets tend to exclude such data, but in real world, again, we can frequently face such situation where we need to understand is some parking lot empty or not, just in the as in the right image in this slide. So how can we just overcome this problem? We need to add some additional annotations to our data. We need to extend the presented data by some additional tool. In order to do it, we established several IPython widgets that can be integrated in Jupyter Notebook. The first one allows us to add some annotations regarding the locations of parking lot, and the second allow us to add the labels to each of the previously defined areas where the cars can park. Finally, we established our own dataset SPKL, which contained half of the image regarding the winter data and extend annotations of other datasets as follows. Finally, let's proceed to the architecture that we presented as our own contribution towards the parking lot occupancy detection problem. It is based on EfficientNet, a neural network architecture that based on algorithm known as neural architecture search. It is just another neural network that is used to find the proper configuration of our CNN. EfficientNet P consists of 8 blocks. First 7 of them are the common blocks of EfficientNet B1, and the last one is our own addition. It is fine-tuned block regarding our task of occupancy prediction. Well, let's proceed finally to the results that we obtained. The first thing that I want to discuss is the intersection-based methods. As I mentioned before, they're not so reliable as classic binary classification tasks, mostly because of heuristic parts that utilized in them. And here we can see proper values of metrics for some of the configuration. However, there is a strong influence of stochasticity among different evaluation approaches, different backbone architectures, and different object detection methods in general. So let's shift to the main contribution of our work. It is results regarding the patch-based methods. And here I will give a word to my colleague, Anastasia Martinova. Anastasia, please.
Thank you. Despite using specific method for training our vision transformers on small data sets, these models still performs unstable, as you can see. For example, a set of VIT models provide the highest result on all dataset except merged, but different modification achieve best result on different datasets. Especially interesting that non-pre-trained VIT outperforms pre-trained one on CNR Park and SMPC, which both are heterogeneous datasets, but doesn't surpass it on small SPKL. Thus, it can be supposed that this small dataset has the most complicated features. It means that this dataset may be used as the most realistic benchmark for testing real-world solution. As you can see, good results were shown by the VGG19 and MobileNet models, but the highest ones overall were achieved by our version of EfficientNet. It can be assumed that the scaling system allows it, obviously. We can say okay, thank you. In order to test the additional features of EfficientNet and increase values of metrics, we decided to try out several heuristics to train this model. The first one is batch-independent normalization. It is a just simple replacement of batch normalization step with the batch-independent step. It involves adding the standard activation step, one variable called proxy norm, which enables to preserve expressivity while compensating for the all channel-wise normalization channels. The second one is grouped convolution. it is just the use of multiple kernels per layer of image to help the neural network learn a diverse set of low and high level features. In our cases, we used parameter groups equal 16 in conv2d operation. The first heuristics is quite simple and involves changing the resolution of input images. We supposed that models trained at half image size can outperform models trained at native image size. Also, we tested different optimizers and stopped on Hermes probe because it gives the best result. The next one is exponential moving average. It avoids sudden changes in model weights while training. So having previously created a copy of the weights after updating, we get the weighted average between the weights before and after the optimization step. And the last one is batch accumulation. It is simple accumulation of gradients and spreading them back every few batches. Next slide, please. We evaluated the effectiveness of our heuristics not just on the general validation sample, but for each category separately. As you can see from the histogram at the top of the slide, the largest number of images were in the occlusion tree and sunny categories. Let's examine their results in head map. In some cases, the use of heuristics gave a slight increase in metric values. In general, the models worked best in the glare, overcast, and occlusion tree categories, which was not obvious at first. The combination of heuristics that performed best on the total validation set, as you can see it denoted as best, as well as the combination of contrasting heuristics that denote as contrasting, never surpassed the results of individual methods, which seems to be an interesting result. And finally, the best results were shown by the exponential moving average heuristics, but guided by our given head map. You can choose the best method, especially for your data.
So, several words in conclusion of our study. Our first contribution is a new SPKL dataset that can be used as a new benchmark for parking lot occupancy detection problem. The second one is embeddable widgets for parking lot occupancy annotation. We hope that community will use it and it will accelerate the annotation process and boost other studies in this domain. Additionally, we extended available datasets for parking lot occupancy detection with additional annotations regarding the 20 new categories. And the last one is our own method for predicting of parking lot occupancy that achieved the state-of-the-art performance and thus outperformed other solutions. Well, thank you for your attention. I am ready to answer your question.
Awesome. Well, thank you so much for first coming in to live to our studio today and for joining us online for the talk. I think my very first question is kind of like the future use cases of this chatbot right now. And I think about it, I'm picturing like not only the do I know of a parking lot has spaces for AI, but where in the parking lot is there typically going to be available places. So I'd love to hear what you think are the use cases.
Well, it depends. Should we focus only on the parking guidance system, or we need to extend it even further? In the first case, okay, implementations of such parking guidance system is a big challenge. There are interesting results in China, for example, whereby the company implemented it in their well-known map system. Also, they have great results regarding, also mentioned in this talk, problem of future predictions of availability of parking lots. Such system can be used as the data extraction tool for these forecasting tasks. For the other domains, I suppose it is not so obviously useful, but time will show.
Awesome. And thank you so much for asking that question. And for the audience, that question was, how do you think this research is going to be the most impactful for AI in parking lots? I have one final question for you both. And what do you think the biggest roadblocks will be for applying this research? For example, like right now, there's millions of parking lots all over the world that all could use this data. So what do you picture as being the roadblocks there?
I think the main issue that we need to overcome in order to implement our results in real world is local bureaucracy. In order to receive access to the proper number of video cameras and observation infrastructure, you need to go to municipalities and do some paperwork with them, which is not an option in some cases. In our own experience from Russia, it was hard enough to implement it in some regions, but however, in capital, it was way more easier.
Well, I think that was awesome. Thanks so much for coming into the studio today. Thanks so much for joining us online. I think that is all for that session. So yeah, thank you so much for coming in. And now, quickly, before we go to a short break, we have two announcements here. First of all, you're at the Global AI Student Conference. For those who are listening in or have been here for a while, we have our Cloud Skills Challenge happening right now. The link is on the screen, but it's also aka.ms/learn-challenge. Through this, you can participate in the challenge, register, and you'll be on a leaderboard with everyone else listening in today from all over the world to go through some specific Microsoft Learn modules that were selected so that you can learn more about AI. We also have the opportunity for you to earn your very own learning badger at aka.ms/GAI-badger. And by getting this badger, you can download it, add it to your own specific NFT wallet, and then you'll join a community of where there are over 13,000 badgers that have been redeemed worldwide. And with that, we'll go to a short break before coming back with our next talk. Goodbye. Thanks so much for your talk. Oh, thank you. Oh, this is important.
Cool. Clean up the studio quickly. Before your 5 minutes, I will come and say goodbye to you. You don't have to leave. You just have to pack. You have the cable back.
Yes.
You have our notes. We are not on mute.
Yeah.
Sure about that.
Welcome back to the Global AI Student Conference. Our next session is about how to use automated machine learning for breast cancer prediction. Let's meet our next speaker, Hadid Ben Amor, a Gold Microflame Student Ambassador. Hi!
Today. So I'm going to start my event, breast cancer prediction using automated machine learning. A special thanks to Global AI community and Microsoft. So Hadil Banamr, an engineering student from Tunisia and a Gold Microsoft Learn Student Ambassador. I'm going to move directly to what we will learn. We are going to discover what's automated machine learning, and we are going to have a small demo on breast cancer prediction. So, automated machine learning is the process of automating the time consuming, as the name indicates. It iterates tasks of machine learning model and development. So it also allows data scientists, analysts, and developers to build machine learning models with high scale and high efficiency and productivity while sustaining the model quality. So automated machine learning in Azure Machine Learning is based on the breakthrough from Microsoft Research Division. So machine learning is the process of learning the machine. Automated machine learning have done many things for us, like it choose the neural architecture search. It select the best model for us depending on the metric you are going to choose. It seek for the data engineering or the feature engineering and study your data. It also did the hyperparameter tuning, so which is important for the optimization and the quality of our model. Also, it does the model compression to be suitable for our needs. So why to use automated machine learning in place of the classical machine learning? Because you won't need any intensive resources like CPUs or GPUs, because everything is done in the Azure cloud. You will not require significant domain knowledge and time, because we have two approaches we are going to discover. Then you won't need to compare dozens of models and search for the best model, because automated machine learning did this for you. Then you are going to accelerate the time it takes to get production ready machine learning models, and we won't forget the ease and efficiency and the quality of the model you are going to have. So how to use automated machine learning is an important question. So Azure Machine Learning for working with automated machine learning provide us with two approaches or two methods. For code experienced people or users, you can use Azure Machine Learning Python SDK. And for non-code or limited experience, users, you can use Azure Machine Learning Studio, which we are going to use for our demonstration. We need to have some steps to create a model with automated machine learning steps. First, we need to create an Azure Machine Learning workspace, and it's important to keep those those keywords in mind. Before you need to create an Azure Machine Learning workspace, you have to have an Azure subscription if you are students or an employees. So then you need to create or load your dataset with which you are going to work. Then you need to have some configurations done. After that, you will explore models, different models, many models you are going to see, and you will discover the model explanations. Explanations aren't done by you, but by automated machine learning. You are going to visualize them and decide which model to choose. Then you will need to deploy the best model. Deploy the best model as a web service or an endpoint, depending on your need. And finally, you need to clean up resources if you will not need them anymore. So for our demonstration, which is the most important because practice makes perfect, we are going to train a model which predicts breast cancer existence with no-code automated machine learning in Azure Machine Learning Studio. This demo is divided into two parts. The first one in the Azure Machine Learning Studio and the other part using Power BI Desktop. So we need to create a data set from, we can create it from our local files. I uploaded my CSV, breast cancer data CSV. The data is from Kaggle and I used it to bring my model. Then I create an automated machine learning model using the create button. Here we can see the many algorithm names, like we have 64 models provided by automated machine learning. And the first algorithm is the best one with the higher accuracy is explained. Here we are going to see the explanation. So the explanation is about like a precision recall graphs, or we can also see the ROC. Here we can see the true positive rate and false positive rate. We can also have our confusion matrix with row. So we have here predicted label and the true label. We can also see the normalized confusion matrix with values from 0 to 1. So explanations, we can see the binary classifiers or dataset cohorts. We can sort by data point and choose also the chart type. We can use bar or box. So we have here the aggregate feature importance. The feature are depending on their performance. We have the features of mean parameter, mean smoothness, mean texture, and mean area. Here you can also increase the top features by their importance. For example, I can have only 3 or 4 or 5. Then I choose the best model, which is depending on the voting ensemble algorithm, and I'm going to deploy it. So I deploy it as a web service, and here my statue is succeeded. So now I have my model deployed as a web service. But after that, how should I like use it or consume my model? That's gonna happen with Power BI. Power BI is a power. It helps us to import. First of all, we need to import our data. Then we need to rely Power BI Desktop with Azure Machine Learning using this button. Okay, since the execution is took too many time, so I prepare a video for that. So here we can import our data. We import our data, which is breast cancer data, to Power BI Desktop. Then this is the preview of our data with the 5 column of features are of type text. So I need to replace values of text and convert them into numbers. But first of all, I need to replace any point sign with a comma, since my system doesn't recognize a point values as decimal, so I couldn't convert them. Now I will convert them. And no errors were displayed since all my values are numbers. Now I clicked on the button of Azure Machine Learning and I have my 5 features here. We have our features. We pressed on OK. So breast cancer data is being evaluated and all the rows are loaded. Then we will edit our query to discover the diagnosis. So we have here the type are numbers. It's very important to take care of our data types. So here we are going to enter new data. For example, mean radius, mean texture, mean parameter, and mean area. Those are the 5 values of our features. Then we are going, okay, with a comma, we have an error. So now our model is being treating our data, and we have 0. So no cancer is detected. Apart from that, we can use Power BI to visualize the data and see some charts and consult our data. We can use from here a line chart. We can choose the x-axis and the y-axis. We can choose the number of parameters we are going to draw. So here we choose mean parameter as x-axis. And we remark that during the model, Azure Machine Learning is predicted the same. Maybe the model here isn't really exacted. So also we can invoke the function and see the diagnosis. You can play with the parameters as much as you want because you won't find the best chart or the best visualization from the first try. You need to visualize more and more depending on different parameters. So then we are going to save our model, our dashboard, and publish it on my workspace. So those are the steps. Those were the steps of creating breast cancer model using automated machine learning and how to rely the Power BI desktop on your local computer with Azure Machine Learning subscription. So I will provide you with the GitHub link, which composed of the report, the data set, and a video of the detailed demo here in my GitHub. So thank you so much. So this is my GitHub account, and this is the repository. You can log in and see whatever you want. Thank you so much.
Awesome. Thanks so much, Hadil. This was an amazing presentation. I think my big questions are like, what are you think like the biggest takeaways or learnings you had as you created your talk?
Okay, we need to know automated machine learning using Azure Machine Learning. We need to know how to create a classification model and a regression model because those are the basics. Then it's important to know how to consume our model after creating it, because after all, creating a model and take it just creating a model isn't enough. We need to know how to consume it, and that's depending on your Power BI knowledge.
I think, especially as a student, understanding all of those things and being able to present it is super impressive. If you had advice or recommendations for students watching the call right now, what learning resources would you point them towards?
I will advise with Microsoft Learn because I finished many paths there. I discovered automated machine learning from there also. I was like, I want to know how exactly what's automated machine learning and why to create it. Not with code with another source. So it will be amazing to join Microsoft Learn and seek for courses there.
Awesome. And one final question I have for you is, what are the next projects you're interested in doing in like the automated machine learning space?
I'm interested in machine learning operations, which mingle machine learning and DevOps or and cloud. So it concentrates basically on your coding skills. For that, I want to learn them in the future.
I think it's super awesome that you said that, because we actually have a panel of machine learning professionals later today, and we've already spoken to one of them who was talking about MLOps and how important it is going to be for the future. So thank you so much for coming on to the Global AI Student Conference, and we also hope you stay and you watch that panel later on today. Butini, do you have any other questions?
I don't have questions for Hadley. Thank you for joining us and for sharing your vision about automated machine learning.
Awesome.
Thank
yes.
you so much.
Thank you. Great. And I think we'll go to a short break before coming back for our next talk for AI in tracking air quality.
I don't know who said this, but the saying goes, growth is not by mere chance. It's a result of forces working together. I have been a student ambassador for about 1.5 years now, and it's been an eye-opening experience.
As a student ambassador, I've been able to grow both in my skills and in my capacity as a student, in the technology ecosystem, and also as a leader to the community.
The Microsoft Learn Student Ambassador Program has helped me develop my career as a woman in the tech space.
So the program has shaped me to become the next generation of leaders. So things like running an entire tech community within USIU Africa. To be a Microsoft Learn Student Ambassador, I mean, it all starts with you as an individual.
You're called to be curious.
Have to be patient.
And share what you've been able to learn with other students.
For the longest time, there has been a gap between the industry requirements and the skills that students normally get from the universities. So this program seeks to bridge that gap. It does so by providing the students with necessary materials to learn, and even goes as far as providing Azure credits for students to be able to solve real-world problems, so that when they step out of the university, they have the necessary skills to be able to solve any market problems.
Benefits.
Get access to Microsoft certifications.
Mentorship from different Microsoft employees.
A swag kit.
Who doesn't love t-shirts, stickers,
Microsoft Office 365.
LinkedIn Learn.
And events such as the Student Summit.
And most of all, a family where you can grow in tech.
As a student ambassador, you not only get the chance to attend different global events, but organize them.
As a student learn ambassador, I also run certain events within my community. And the good thing about doing these events online is that we don't limit it to students within our universities. We take this broader because anybody who has access to our learning platforms could potentially just join the event and just learn.
I was able to organize the Microsoft Student Summit Africa 2020. I was also a team lead in the virtual hackathon Game of Learners 2021.
The Game of Learners is a virtual hackathon whereby students from different universities and countries meet together in teams and build products that solve societal needs.
For you to be a student ambassador, all you need is passion. If you're passionate about machine learning, that is all you need, because that will push you to learn so that you can teach and mentor others.
The Microsoft program is open to all students, regardless of your major, your gender, or anything else.
I would encourage students who have just joined the university to join the program because you have more room to learn, explore, and discover a lot about tech.
Join me and other student ambassadors to make impact, both locally and globally.
For more information about the program,
please go to aka.ms/studentambassadors.
See you there.
Hi, my name is Ruth and I'm from New York City.
Bonjour, je suis Jean-Philippe Boncos de France.
Ciao, sono Mauro Benici dall'Italia.
Hola, soy Luis Beltrán de México.
Hej Ingrid, ik ben Sami uit België.
Cześć, tu Bartosz Polski z Polski.
Ciao a tutti, sono Francesca dagli Stati Uniti.
大家好，我是 Ryan， 来自台湾。
My take on life is that life is definitely there for the taking. What you put in is what you'll get out. Two things important to me in life are family and music. They both play a huge part in my life. Technology allows me to be my own one-man band. I try to be as independent as I can, and the way that I do that mostly is with low tech, which is a white cane, and high tech, which is a phone.
Seeing AI.
Seeing AI is one of the biggest deals in technology, I think, at the moment for visually impaired users. It's an app that you can read almost anything, anywhere with it.
Kilburn High Road. Fashion. Workspace. Mayonnaise.
It has a multitude of functions, and they all work together to produce something that you can use whenever you need it. It might even be considered to be a Swiss Army knife of apps. Of all the parts of Seeing AI, I really do think short text is the biggest of the game changers.
Northwest 6.
Because I've never seen anything like that in any other app before. And I like being in the back of cabs or in buses and pointing it out the window and seeing what I pass on the way to places.
Mobile phone NC 4000 services.
One of the greatest things about short text for me is that if there's no one else in the house, I can sort the post into who's who.
Mrs. K. Louis. Mrs. Kirsten Louis.
So I don't open my wife's post and she doesn't get cross with me. Package.
Yo, well, Andre.
My man Alex.
Good.
One fella.
Blessed.
£20.
That's really cool.
Currency is a very useful channel because sometimes it's very difficult to know what notes actually are. So with Currency, I can detect that straight away.
£5.
Job done. 2025. Well done.
Scene preview.
Scene is actually really cool. It's quite descriptive, really.
Processing. A store filled with lots of different types of fruit.
I think that's pretty amazing.
Twitterific.
In my view, one of the best parts of Seeing AI is the ability to read pictures from social media. Because so many times someone will send me a picture of something that I cannot understand. So I will share that picture to Seeing AI.
Scene. Probably a group of people sitting on a bench in a park.
And then I'll get a description of what it is.
Person. 8-year-old boy with black hair looking happy, 7-year-old girl with brown hair looking disgusted.
And it's changed how I can view social media. It feels like I can participate.
Like, reply.
Far more than I could before.
Thank you for sharing. Handwriting preview.
With Handwriting Channel, I was actually able to read a card from a family member last year. That's the first time I'd actually been able to do that without help.
Dear Dad.
That was
Alice
very
worked.
good.
We can tell if Jake's been writing well, if the handwriting tab can recognize it. That's good proof, really.
We love you, Daddy. XXXXXX.
We've got lots of X's.
Yeah.
The effect of having Seeing AI to hand all the time is like having somebody who can see in your pocket.
34-year-old man with a beard wearing a hat looking happy.
Why not?
There is so much more that I can do now that I couldn't before. You've grown up.
I used to be 9.
I think Seeing AI really is a huge technological step down the road, and I hope that we can continue down a road like this for many years to come.
So I think AI is going to have a huge impact in everybody's life, from day to day to work and things that we do. I think each of us have a huge responsibility in terms of how we make AI work for good and the ethics of how AI will work for everybody. So we have a huge responsibility, and I'm looking forward to how AI can help everybody.
I think AI will empower the 1 billion people with disabilities on the planet.
I believe that the applied use of machine learning in scenarios like predictive maintenance will help save people and the environment from disasters.
I think AI will save lives by enabling self-driving vehicles to be trained in simulated environments before they ever hit the road.
I think AI will change our lives in a profound way. Because if you look around, every aspect of our life is being digitized.
I think AI will be used heavily in healthcare and help save lives.
I think AI will help feed the poor by providing better predictions into when to grow crops. And
I think AI will help people to create more smarter reports and applications.
I think AI will make AI easier to develop. Microsoft Research figured out a way to use machine learning to develop machine learning models. It's called automated ML, and it's now part of Azure.
I think AI will help us predict crop yields to be able to better manage agriculture, detect animals in mounted camera traps to be able to aid in conservation, and utilize satellite imagery to be able to recognize patterns and how we can best fight climate change.
I think AI will continue to push the boundaries of what we can do with technology, giving developers the opportunity to grow a skill set in this exciting area over time. I believe, though, to get started, we've got to start building right now. I'm really keen to help developers and data scientists to achieve this.
Welcome to the
Hello and welcome back to the Global AI Student Conference. Did you love the videos on the Microsoft Learn Student Ambassador Program and Seeing AI? I think the part that I found super cool is that students are demoing the tools and technology at this conference, image detection, object detection, speech to text, that is being used in tools like Seeing AI. So I'm super excited to see what they do in the future. But now I'll pass it off to Futini to introduce our next speaker.
Thank you, Loxley. I also love the videos that we see about our student community and the Seeing AI. So our next speaker is Sifa Kinoti, an environmental engineering student in the University of Nairobi. And she is going to talk about AI in tracking air quality. Hi! Welcome to the show.
Can you hear me?
Yeah.
Yes, thank you so much for the opportunity. I am going to go ahead and share my presentation, if you don't mind.
Yes.
I'm going to go ahead and share my screen. I hope you can see my slides.
Yes, we can see your slides.
Okay. So my laptop is a bit slow. Kindly bear with me. So this is what the presentation is about. It's going to be about air quality visualization. And this is me. My name is Sifa Kinoti. I'm a data science and AI enthusiast. I took a short course in data science from a school called Jenga School, and I'm yet to graduate. And I took it as a minor, but a major, I'm doing environmental engineering at the University of Nairobi. I'm currently in my 4th year of study. So, of course, University of Nairobi is in Kenya's capital, Nairobi. So this project was motivated by the challenge that has been described as one of the biggest challenges of this century, needless to say, climate change. Of course, we're all facing dire effects from climate change, especially here in Kenya. So I wanted to see, or rather I wanted to investigate, how can AI help in this fight against climate change? And we know that climate change comes from air pollution. This is where we release toxic gases into the atmosphere. And they're called greenhouse gases, and it has this whole greenhouse effect that raises the temperatures. So what can we do? The goal of the rationale of the project was to measure these pollutants that are present in the air, such as we have many different pollutants. We have particulate matter, and it's also divided into different branches. We have particulate matter 10, we have 2.5, and we have 1, and it's all divided according to how thick the radius of the particulate matter is, of how the molecule is. We also have ozone, we have methane, we have the very popular carbon dioxide, carbon monoxide. So what we can do, we can measure it in the air. We know the trends. This is where it's coming from. This is its concentration. And then we can also create algorithms to visualize so that we can see maybe in the western part of Nairobi, it's on a downward trend, and the eastern part, is it on an upper trend, to answer those kind of questions. And then it would also be interesting to investigate, or rather to see if we can predict the value of the pollutants. And this we do using neural networks. I investigated using LSTM. LSTM is short for long short-term memory, which I will get into later. And what do we do with this information afterwards? This information can be used to advise policy. This information can be good for you as a citizen, as an active citizen, to know what's happening in your world currently, and to also know how you can take action, whether you should wear a mask, whether we can plant more trees, and so on and so forth. So this is the basic workflow of such a project. The first thing, you collect data. I was fortunate enough that for the data that I used in this project, it was made open source by a company called Sensors Data Africa. It's an NGO that works to put sensors all around cities in Africa in order to measure air pollution, water pollution, and sound pollution. And the data is open freely. I think they've been collecting it since 2017. It's open on that website, Open Sensors Africa. So, of course, it's a time series model. A time series is it's a kind of data set where the values vary per time, or rather you collect these values every second or every minute or every hour. So you have the column for the value that's coming in, and you also have the column for the data. So in a time series model, of course, you will need to look at it, you'll need to clean it, and you'll need to transform it. And the package that I use the most over here is pandas. Of course, it helps you to see if you have any null values, and it helps you to do feature engineering. You can end up merging columns, you can end up creating another column from the columns that you actually have, and I will show you one that I created. And you'll also use another package that I forgot to mention here to check for something called stationarity. So stationarity is you conduct a stationarity test in order to look at the trend and the seasonality of this time series data set that you have. So basically you want to see if the average is moving, if it's going up, down, or if it's on a constant upward trend or a constant downward trend. You need to check for that because data science is all about statistics and learning from patterns. So if you want to put this data set into a machine learning model, it's important that you put it in a way that the machine learning is going to understand it, in a way that the model is going to be able to detect these patterns. So something else that we also do when we're transforming the data is differencing. We do the differencing so that we, sorry. Sorry, I think I had stopped for a while. You do the differencing so that you can bring all this data around the same average so that the machine learning algorithm can be able to detect the patterns. And I was saying the last thing, yes, that we need to do is scaling. Now you realize that sometimes you might collect information that has varied, very varied values. You can find that in the same data set you have values that are ranging from 0 all the way to 1,000. Now this makes it difficult for the model to predict. So what you need to do, you need to scale it. You usually have either the min-max scaler or the standard scaler, where it does some maths behind the scenes so that you can bring your values down to either 0 or 1. And that way the machine learning is able to understand the trends in your data set. Then afterwards, we move into the LSTM modeling. As I mentioned, LSTM is a neural network. It's a recurrent neural network. And I use the one from TensorFlow. You use a package called Keras, and I will show you that later. Then afterwards, I evaluated using the mean squared error. In short, you can see that it's MEC. And I would suggest, as used in this project, I deployed my data on Dash, and I used Heroku. Or rather, I visualize the data on a dashboard, and then use Heroku to finally deploy it. So kindly give me a second as I switch to the GitHub. Yes. So this is a GitHub account. I will share the details and I will make it public right after this presentation. But I just wanted to do I wanted to show you how the project looks like with code. So basically I did just a little bit of write-up, an overview, what I've talked about how clean air is very important and how air pollution is a major cause of climate change. And later I went into something called a CRISP-DM methodology, which would be important for students to understand, or rather students to employ in the data science projects, in the AI projects, which is basically a framework for how to conduct your project. So what I did was a bit of business understanding to understand the objectives of this project, which is basically to track and identify various pollutants within the city. I looked at the availability of the resources, which, as I mentioned, I was fortunate enough to use the open source data from Census Africa. And you also analyze the risks and contingencies. Of course, something that we always say, we don't have enough data, especially here in Kenya in regards to air pollution. So I'm hoping that this is something that I can create awareness of. And another risk and contingency that I should have added here is that you need a lot of desktop power in order to run such a project, because you'll be using a lot of data. So the data mining goals, as I said, the goal is just to identify and track pollutants. And then you also have the project plan of the city, a project plan of the project and to help you plan. And then, of course, you collect the data and you import the necessary packages that we're going to use, as you can see. I was using Colab, so I imported them from my drive. And then you can look at how this data has been preloaded, so it's already been transformed, but this is just basically how it looked like. We had the sensor ID, the different, this is to identify each sensor where it's been put in various parts of the city, and the sensor type. So the different types of sensors, some that measure particulate matter, some that measure temperature, others that measure humidity, the location. Later on, you realize that this project has 17 locations within Nairobi. And of course, the geocoordinates, the timestamp. So this is what I was saying about it being a time series model. It means that information is being collected every second. As you can see here, it's actually every microsecond. And the value types and the value, and you have the day, if it's a Monday, if it's a Tuesday, if it's late at night, if it's early in the morning. And then it's also important for you to describe the data, to look at it, to check if there are any null values, to check if there are any duplicated values, to check the shape. I'm sorry, my laptop has a bit of, the laptop power is a bit low, so I wasn't able to run all of this beforehand, but you can definitely clone this and run it in your device after I've made it public. When you check the shape, it has so many values, and then something that's very important is that you need to convert it to datetime. When you convert your column that has the dates to datetime, it makes it much easier to work with. And then I renamed the value types because at first they weren't as they were. As I said, I transformed it beforehand. And then I also created, I plotted them on the map so that I see how distributed these sensors are. And then I replaced because at first the locations were they were encoded, as you can see with these numbers, and I replaced them. And I also added a day and time column because I thought that it would be interesting to see the variations per time, like how does the data look in the morning versus in the evening? How does it look on Saturdays versus Mondays? Yes, and then I did a bit of locking the data over here so that I can downscale it. This data set had very, very billions of values. So I wanted to downscale it so that I'm able to train the model. So this is some of the feature engineering things that I was telling you about. I added an AQI bucket. So this bucket is just to classify. It will look at the value, and then it will tell you this value 42 Friday morning, it was unhealthy for sensitive group. But this one on a Friday morning, it was good. This one on a Tuesday night, it was moderate. I did that so that it's easier for us to understand where these values lie. Instead of just telling you 95, 29, 11, you wouldn't really understand what it is. So here now I moved into filtering the data further so that I can now do the modeling. So what I did, I picked the top location, which is rerouter, and then I dropped all those other columns because I just want to do the modeling. And then you lock the first 5,000 values. And then always remember, because when you lock, you're creating a new data frame. So remember to do the formatting that I showed you earlier about changing it to datetime. Otherwise, you wouldn't be able to you wouldn't be able to plot it and also manipulate it, and also to set it as an index and to set the frequency. And you also check for stationarity, which I told you checks whether your data is good enough to be modeled. And then, of course, you split into the testing data and into the training data. I used the 0.3, which is very common. So the test size was 30%. The training size was 70%. And then you define your time series generator. This is from a package from TensorFlow from Keras. And then you're also supposed to define your input and the features. So these features, one means that we're only looking at one thing, which is the which is a value that we're going to predict. And the input is how many values that we want to how many values you want to use in the training data set at first. So use the first 1,000 values and then use the next 1,000 values and the next 1,000 values. Then there you're also supposed to define the batch size and yeah. Afterwards, you go to create the model. It's a sequential model, LSTM, added 50 units. You have the ReLU activation. It's very important to use some of these parameters because because they improve the accuracy of the model, such as the learning rate, the dropout, the activation, and dense layers. These are hyperparameters that you keep on playing with to see which one will give you the best machine learning model. And then here we just looked at a summary. So we're seeing that we have 10,808 trainable parameters. For purposes of this presentation, I ran it using very, very few epochs. Normally, something that you'd use a little bit more epochs because the more it trains, most of the time, the more the accuracy improves. And there's a special function that you can use called a callback, where you can do something called early stopping, where it analyzes these losses that you're seeing at the end here. So when the model notices that, okay, the loss isn't really increasing or decreasing at this point, we can stop the running, and then this is the best model that you can generate. After that, you plot your loss. You plot it to see how it's functioning. Normally, they usually run down like that, but it's a smoother curve. But as I said, for purposes of this presentation, I did not use the best parameters because of the laptop power and and so on and so forth. So afterwards, you want to predict because you've already modeled. So here we're looking at, as I mentioned earlier, you take like the first 1,000, you predict, the next 1,000, you predict. So you want to now predict them in batches. So that's what you want to do here. You want to create the batches and then you call the first, this 0 is supposed to call the first item in that array, and then it'll give you the prediction. But remember, you can also remember that we transformed this data earlier using the min-max. So something that you're supposed to do, you're supposed to inverse transform, because when you do min-max, your data is between zeros and ones, and that's not accurate. So when you inverse, it's back to 79, 25, 24. So you do the inverse scaling, and then you add them on a predictions, you visualize them, your test prediction, and then you evaluate it using the mean squared error. Normally, you'd want a mean squared error that's as low as you can get, as low as possible. Then you pickle load the model. So this is something that you do when you want to save the model, and so that you can use it in a different model. So now we've predicted for rerouter, but what if you want to find out how the quality is in the central business district? So that's why we pickle it so that we can save it, and then we load it in a different place so that we can use it. Now, that's most of it about how your Jupyter notebook will look like when you are doing an air pollution, or rather an air quality model. And then when you want to now visualize it and present it to people, so this is how your code would look like. So as I mentioned earlier, I prefer using Dash. Dash is a framework that's used to, Dash is short for dashboard, and it's used for visualizing, or rather presenting your data science findings in a unique way. You're telling it as a story. People can come to your website and they can understand what's going on. So normally when we are using Dash, these are the most important packages in Dash: the DCC, which is a Dash component, the HTML. HTML is, I'm sure most of you know, it's just about how you write your markdown, how you present your wordings, and then you also have the input and the output. So the input and the output is important because it allows the user, or rather this is what defines how the user will interactively use your website. And then, of course, Dash is built on top of Plotly. Plotly is another amazing library that I like to use because they do interactive mapping and pandas. So you import your data. I should not have shown my Mapbox token, but that's something that you're supposed to load and then you define your Dash app. And then normally you just create a layout. So what I wanted this layout to look like is that the user comes to the dashboard, and then they have certain things that they can manipulate. So the first one here is a location. We're going to ask you which location do you want to, we're going to ask you to specify the location where you want to visualize the air quality. We're going to ask you also to specify the value type. Excuse me. So as you noticed in the Jupyter notebook when we were doing the exploratory data analysis, there were different types of values. There was a humidity, there was temperature, and there was a different levels of particulate matter. So say they want to look at the temperature in the central business district, and then here there is a time. Maybe you want to look at how it looks in the early mornings or in the late evenings. The day you want to see how it looks maybe on the Saturdays, on the Fridays, and you also pick a date, or rather a date range. So this would help when you're mapping. So the Dash components that I used here is a drop down and checklist. So what this says, or rather the components that you're supposed to put inside the checklist or the drop down, you have the options. The most important that need to be there is the options, the value, and the ID. So the options is the options we loop through all the locations that are in the data set. And then for the value is just basically what is inside the options. So in the options, we had Central Business District, we had Muthaiga. So in the value, it's going to be the same. It's going to be the same list, but now the value indicates now what the user is going to see. And then we have a special ID for this checklist. It's called location. And the same thing happens all the way down to the rest of the drop downs and everything. And then you define a graph because you'd want to look at, say, the time series, how the values trend over time. So those are different graphs that you can do. And then this is also something that's very important for you to know when you're doing your Dash application, the callback. So the callback is what connects the outputs and the inputs. When you have multiple inputs, like in this case, you would put them in a list. And then your output would be the map. So for example, in this callback, you remember we did that checklist for which location do you want to see, which value type, which things do you want to see. So this is what is being input over here, the ID, and then the value, this value that we indicated over here, for example. So you link that output and that input, and then you define a function that's going to draw up the map. And inside the function, you put in different, sorry, this one isn't that correct. Inside here, you put now this chosen location, it matches up to this first input, which is the location. And this chosen value type, it matches up to this value type. So those are the parameters that it would use, the location, the specific location, and the specific value type. And then you can also draw up now your scatter map box. And then this is a sample code of how it would look like, and then you return the map box. And something that's important for you to do is to create a new data frame when you're defining these functions for graphing, so that it doesn't keep on, so it creates a copy of your actual data frame, so it doesn't keep on going back to the actual data frame. So after you're done with everything, you're supposed to call the application and it will now set up and run. So something that I have not experimented with before, but I was told about right before the beginning of this presentation, is about Heroku. So Heroku is something that can help you, or rather it's a platform that helps you deploy your Dash application. And I think it's something that we should all look into. So that is the end of my presentation. I'm going to stop sharing and I am open to any questions now.
For your presentation, I have to say that it's very inspiring to see students using all the AI technologies for projects for social good. Now we have a couple of questions for you. So the first one, is that traditional, a lot of data tracking systems on weather, air pollution and quality is not updated in real time. So you use data from the open source on Africa. How is this data updated?
Sorry, how is this data?
How often is data from open sensors Africa updated?
It's actually updated in real time, which is a very, very interesting thing, but I was not able to incorporate that into this project, but it's something that I'm looking forward to doing.
Yes, it's very great. So the next one, you are an environmental engineer. So how essential is technology analysis supporting climate change?
How is? Sorry?
How essential is technology analysis to support climate change?
How is the sensors technology supporting climate change?
Yeah.
Oh, yes. For example, in this project, you're using sensors to detect the air pollution. And air pollution is directly linked to climate change because it's what's directly causing it. So that's one of the ways that you can use sensors in order to fight in order to fight climate change. There are also other different ways you can look into, aside from air pollution, you can also look into how it's affecting the water, the soils, and other aspects of our lives.
Awesome. I think I have a couple questions. First of all, I just think it's amazing that the data set updates in real time. And I know one thing that you said in your talk was like that you were super excited to explore that in the future. So I'm super interested to hear what are like your next projects that you're looking forward to using this data or other data on.
My next project, I'm actually looking to continue building onto this project because I feel like it has so much that I can do than this. I'm still a beginner in data science. I'm looking to using more Microsoft platforms, like seeing how I can link it with Azure, seeing how I can build it into something that can now be deployed in the industry and not just on a dashboard.
I think that is so relatable. Even I remember one thing you said in your talk was how the like processing on your computer like might not be as fast as something in the cloud. And that was something that we had a speaker earlier say that like right now, like the processing you can do on your own computer, like using the cloud, suddenly you have all of this access to computing power, which I want you to come back at next year's Global AI Student Conference and do a talk on that because that would be absolutely amazing. I think maybe my final question for you, because we have a little more time, is what are you like, even what was your favorite things that you learned so far in your research and in like the data science space?
Oh, wow, there's so much. When visualizing this data, I didn't actually realize how dirty the air is. I did not realize that. And I think it's something, that's why I want to continue building it to deploy it into the industry so that people can be more aware that the air that we're breathing in is really, really not good. And, you know, it results in a lot of respiratory issues. The other thing that was very interesting for me to learn about was working on a time series model. There's a lot experimented with a lot of models such as ARIMA, the Facebook Prophet, also scikit-learn based scikit-learn-based ones like random forest and SVM, but learning how to create this neural network was a big challenge to me, and it was something that I really enjoyed.
I think that is super awesome. And I think actually we have time for one more question. And let's see, do I remember this final question I was going to ask you? I had it and then it escaped me. Let's see, it'll come back. No, I think actually, no, the thing that I think is super cool about your data and the research you've done is it's both impactful at like a small scale with like direct things that people can do with it, but also on the big scale with hopefully causing like massive social change. So what are like the impacts that you foresee that this research and your project having on like your community and the world?
Yeah, well, for one, of course, it'll create awareness on the current state of air quality in Nairobi. And this can put pressure on the government to change our policies and to change our laws and to do more. If it's planting more trees, if it's looking into more climate change technologies that can mitigate this, that's something that I'd really want to push for.
I think that is super excited, and I'm also super excited
Yeah.
for you to continue doing that research. So
Thank
you so
you.
much.
Thank you so much.
And thank you so much for coming on the conference today. I'll now pass it back to Fatini to introduce our next speaker.
We are back at the Global AI Student Conference for our next session, Introduction to Name Entity Recognition Using Azure Language Services. Let's meet our next speaker, Konstantinos Kyriakos Sitistas, a Microsoft Learn Student Ambassador from Greece. Hi, Konstantinos.
Hello. Can you hear me first of all?
Yes.
Super. So, hi, Fotini and Loxley. Hi, everyone. I'm really glad to be with you today here.
We're very excited to have you with us today. So you may share your screen and we can get started.
Okay, super. Just give me a moment to share my screen.
We can see your screen.
Perfect. So, hi, everyone. My name is Konstantinos Sitistas, and I'm a beta Microsoft Learn Student Ambassador. Today, I'm going to present you some introductory concepts around the area of named entity recognition and in general about natural language processing. And I will show you how to build your own model using Azure language. Okay, so just a few words about myself. It won't take that much time. I'm in the final year of my studies in the Electrical and Computer Engineering department of the University of Patras in Greece. I'm a student ambassador, Microsoft Learn student ambassador for almost 2 years, and I'm currently working on my thesis, which is related to natural language processing, which is one of the most exciting topics that I have got involved these years. Currently, I'm also working as a software engineer at an IoT-related company here in Patras. I suppose that most of you have heard some way about NLP, but for those of you that are unfamiliar, we could say that natural language processing is a branch of computer science that is about giving computers the ability to understand written text, but also spoken text and spoken words like us humans. Today we're going to focus on written text, but similar techniques can be applied to speech as well. In this slide, you can take a look at the most common tasks of natural language processing, which are text and speech processing, morphological analysis, syntactic analysis, semantics, and synthesis. So the named entity recognition that we're going to focus on today is part of the semantics. And I hope that you will like it. The session is pretty much introductory, so you will not need the prior knowledge to go on. Before we move on, we need to define what an entity is. So, an entity is a span of text that indicates a certain type of information. The text span can consist of one or more words, so it's not limited to a single word, as you can see in this slide. It could be 2, 3, or 4 or many words. And these entities represent the information that the user wants to extract from the text. So what are we doing? Developers tag entities within their data before they pass it to the model for training. For example, they can use entities such as date, or start date, or birthplace, or first name, or it could be an organization. So, what does name entity recognition? So, NER allows us to extract the categories of information using artificial intelligence models. So for this task, we can either use a pre-trained model with an organization or someone else has trained, or you can build your own model to meet your project needs. So with custom named entity recognition, you can build custom machine learning models to perform the data extraction. I also need to mention that it applies to unstructured text, so you don't need to worry about the exact format of the text that you want to use for your projects. And in this image, you can see the steps that are usually involved during a project lifecycle. First of all, we need to select our data and define our schema, which means to identify what entities we want to extract data from. Do we want names? Do we want cities? Do we want prices? It would be whatever. After that, we need to label the data. And we need to be very careful at this part, because if we don't pay attention and we insert incorrect labels or just mess up with the labels, this is going to affect the performance of our model. So mistakes in labeling can lead to a subpar model that is not going to cover our needs, let's say, and probably we will need to improve it later. So after we finish labeling, it's time to train our model, view the performance, and if needed, if the performance is not, let's say, satisfactory for us, we can improve it and go back to labeling again or add more data. After we achieve a satisfactory result for our case, we can deploy the model and use it in our scenarios. So, what about the accuracy of these models? Because someone may think, okay, how can I trust a model like that? I need to tell you that in recent years, the newest models achieve almost near human performance, sometimes even better than human performance. And to calculate the score of the model, we're usually using the F1 score, which is a metric that combines the precision and the accuracy of the AI models. So let's talk about the accuracy requirements. Of course, according to the application, these requirements are varying. These are not fixed. One example that I found in my research was the guidelines from the Canadian NER evaluation guidelines, which are for closed captioning, which indicate that a satisfactory score for NER model for closed captioning is at least 98% accurate for English and at least 85% accurate for French. You understand that there is a difference in these numbers because, of course, in English there is so much more data than in French language. But in general, named entity recognition is like supported for a lot of languages, and it's still under, let's say, development. However, as I've already said a lot of times, with great power comes great responsibility. And we need to take into consideration that we should avoid, let's say, using named entity recognition for decisions that might have serious implications. For instance, we should avoid scenarios where a health diagnosis is based on extracting information from an individual's medical form, or charging someone's bank account because we extracted some values from a text. Okay, so we should also avoid creating entities that extract unnecessary or sensitive information. So, for example, if we have a scenario that we need to extract the country and the city of a user, we should select only this data and not the entire address of that person. And of course, we should also follow the other general responsible guidelines for AI, such as inclusiveness, transparency, and human accountability. Okay, so time for action. Now it's time to create your own model, and I will show you how to do that easily. For that part, we're going to use the Azure Cognitive Service for Language. So custom named entity recognition is part of these services. And of course, there are a bunch of other services such as language detection, sentiment analysis, text classification, and a lot more that you could try to get started with this amazing piece of technology. So let's use language service to create our model. First of all, we need to have an Azure subscription. You can get one for free. And if we go to the Azure portal, we can go to Cognitive Services to create a new resource. We go to Language Service, create one. Okay, so that part we need to select custom text classification and custom name entity recognition. And we create our resource. We select our subscription, a resource group, or we can create a new one. I can select my region, which is close to me, and I choose a name. For example, it could be intro to NER, I don't know, something like that. Okay, there are two options here, free and standard. You can also choose free. I select a storage account, an existing or a new one, and we create the resource. Okay, so the validation has passed. It's time to create a resource. And okay, because we need to save some time here, I have already done this before, so I will not wait to for the resource to be created. What we need to do at this part is to go to the storage account that was created or that we selected before with our when we created our resource. Go to containers and we create a new container. I have already created one. I go here, and at this part, we need to upload our data. So we need to upload TXT files and JSON files, and what we need to do with this. So the TXT files, as I'm going to show you, are just plain text files. For example, these are sample loan agreement texts that you can also view on the GitHub page of Microsoft. So this dataset is online and you can use it to test your model. You can go here, you can upload, let's say, a number of files, and the JSON file contains some, let's say, information about the entities, because these are, let's say, already done to create our model, and we don't need to deal with this. So, okay, the deployment was succeeded, and it's time to move on to Language Studio. You need to go to language.cognitive.azure.com, and from here you can create a new project or select your last project, let's say. You can create a new project from here and you select, for example, custom named entity recognition, or you go to the extract information tab and you select custom named entity recognition. So Let's go and create a new one. Create a new project. We select the storage account, a resource that we created earlier. Click on next. We type a name, and we select the language, the primary language of our text. You can also select this checkbox if you want to include documents that are in many languages that are not in English, for example, and you can also add a description. You choose next. Okay, you choose the container that you also created before, and because in this scenario the documents are already labeled, and we have a JSON file to let's say describe these entities. We just choose this file and we hit next, and then we create a project. So I have already created a project to show you the result of this. So, okay, you can see that we have a number of text files here. We could go, for example, and check these. So, this one is date, this is the name of the borrower, the address of the borrower, etc., etc. So this data is already prepared to train our model. Let's train our model now. We go to training jobs, start the training job. We train a new model. Let's say we could call model intro to AR. And it can also automatically split the testing from the training data to use, let's say, a large percentage to create a model, and a smaller data set to test and perform changes to improve the model. So we hit train, and okay, this is going to take some time, so I'm just going to show you the result. I will go to my already created project, and we can see the performance of the model. So as you can see, the F1 score is about 95%, which is pretty good because we just added, let's say, 16 documents, as you can see that, 16 training documents, which is not a lot of data, and we used just 4 documents to test our model. So as you can see, this was just plain text, and we have a very high score for our model. So here you can also use a confusion matrix to improve your model and see where are errors and where are matches. And yes, here you can see the results which failed. For example, here the label text was of, and it was predicted as borrower address, so this was a mistake. But in general, we can test it with other, let's say, loan agreement text, and it will be the probability of being correct is really, really high. Okay, so this is it. You can also use your own text to test your model and see if it can adjust to your needs, or if you don't, if you cannot do so, you will need to go back and train your model and add more files, improve your labels, and repeat the same step. So you can search for the resources to learn more. There is a learning path on Microsoft Learn about natural language processing in general, and about today's exercise, you can go to Microsoft Learn documentation and study more about the custom name entity recognition. And yeah, feel free to do your research and play with it. It's really, really fun. Now it's time to discover it yourself. So if you want to follow me for more and see me in future natural language processing workshops, feel free to follow me. So that's it.
Hi, thank you for your presentation. And now we have a couple of questions to ask you because we have like 10 minutes left for your session. So our first question is, can you explain more about the types of the entities?
So when we're talking about already trained models that you haven't prepared yourself, not custom NER, just plain NER, there are some, let's say, ready groups of entities. It could be date, it could be first name, last name, address. It's like filling a form. You can see the most usual information that you want to get from a text document. Of course, in custom name entity recognition, you can add your own. It could be whatever. I recently read an article, paper, I'm sorry, about custom named entity recognition in cybersecurity. So this could apply to a very, very large part of our, let's say, um, jobs that we want to extract information. And it is pretty efficient.
So thank you. In this presentation, you use the Coscum Name Entity Recognition service. Have you ever used some of the other services of the Language Studio?
Yes, I have used the. Okay, of course, I used the named entity recognition first, which was for mine. It was pretty satisfying. There are also like uh, conversational models, and you can also build your own AI bot or do whatever you want with these services. So it's not limited to just plain text. You can combine it with other Azure services or external services, or use an SDK um, to combine it with your own application. So it's not limited to that um, user interface that I showed you. So yeah, you have so many capabilities with it.
And our next question is that in your demo you use a dataset with TXT files.
Exactly.
What if my data is in a PDF format? Can I still use this service, or I have to use the custom name entity recognition service along with other Azure services?
Um, I think that in order to extract information from PDF files, you need to combine it with other services, but I need to search for it. I'm not entirely sure. But of course, you have um, the option to do so. It is not something like say that you don't have the ability to do.
Yes, thank you. And so one last thing is that we saw the card with the evaluation results of your custom models that you built. This result is same like in other services that we find the Language Studio and the Azure Custom Vision service. Can we take like more evaluation results about our model, or we should use only the evaluation results that are presented in this site? Can we generate our own metrics?
Yes, I think that you have the ability to generate your own metrics. Of course, this is something simple because if you want to get started, you don't want a bunch of numbers to show up in percentages that may confuse you. Um, but these are in general really accepted metrics. The F1 metrics is widely used because it is used in a lot of artificial intelligence applications. Also, I have used it before in custom vision, as you said before. So it's like a generic metric that all, let's say, researchers and the students will can use to test their model and improve their data sets and models.
Fabulous. I think I have a couple other questions. And like with your experience with natural language processing, what has been like the favorite things that you've learned with the technology or your favorite projects you've done?
That's a pretty tough question. I enjoyed a lot uh, custom NER because I think this is my favorite, to be honest, because it's something that can save you so much time. For example, there are many jobs that you need to go to manually seek through a bunch of documents, for example, 100 of documents, and this will take so many hours to do for one person. At the same time, you can just train your model in 10 or 15 minutes or 30 minutes, it doesn't matter, and use it to save time and do something more productive in your working time. So I think this is pretty amazing.
That's awesome. And even I know one more question is for our students listening in on the chat today, what would you recommend as being like a very first project or learning module to learn more about natural language processing?
Um, yeah, I also showed it in my presentation. It was if you go back, you can see that it's a learning path from Microsoft Learn that you can read, and also you can use resources to get your hands dirty. It's about basic knowledge on natural language processing, how you can extract information, as we said, how you can use translate service to translate some text or detect a language or build a conversational model using Azure language. So I think that the Microsoft Learn path is like the best resource to start with.
Awesome. Well, thank you so much, Konstantinos, for coming on today to give your presentation and also to answer all of our questions.
Thank you as well. It was a pleasure for me. And yeah, I hope that this will continue in the next years because the organization is amazing.
Oh, thank you so much.
Thank you.
And we hope to see you back at another Global AI Student Conference to talk about all of the work that you will continue to do in the field.
Okay, thank you. Bye bye.
Yeah,
Bye.
thank you. I think we're almost ready to dive into our next presentation about the hybrid model approach for real-time acoustic anomaly detection using time series, but we have a little bit of time before then to talk about our two promotions we're doing during the Global AI Student Conference. The first is our Cloud Skills Challenge. So you can participate in our Cloud Skills Challenge by going to the link aka.ms/learn-challenge, and you can join a leaderboard where students from all over the world are participating, and you can complete some modules that are specifically handpicked to learn more about AI. And our second thing is you can earn your very own learning badger at aka.ms/GAI-badger. And this looks just a super cute little tool. I have a couple AI ambassador badges myself, and over 13,000 of these badges have been given out globally across the world. So a super fun way to show that you're learning these AI skills. And I think we'll go to a quick break before starting our next presentation. Welcome back to the Global AI Student Conference, and we're here almost ready to welcome our next speaker, Sahan Disanyaka, which I completely mispronounced that name, but they are a Gold Microsoft Learn Student Ambassador who will present to us about a hybrid model approach for real-time acoustic anomaly detection using time series. Sahan, hello.
Hello, hope I'm well audible.
Thank you. And how are you doing today?
Yeah, I'm feeling awesome, and I heard Feral session went on Global Student Summit 2022, so it's feel awesome.
Awesome. Well, we're super looking forward to your talk. So feel free to start sharing your screen and take it away.
Yeah, thanks so much. Okay, let me share my screen. Hope my screen is visible to you.
Yes, we can see your screen.
Okay. So, hi guys, good morning, good afternoon, good evening to everyone from wherever you are joining to Global AI Student Conference. Hope you all are enjoying Global AI Student Conference so far. So the talk I'm going to deliver today is hybrid model approach for real-time acoustic anomaly detection for machine condition monitoring. First, I must extend my regards to my supervisor, Dr. Manjushri Vikramasinghe, and also my co-supervisor, Mr. Pasinu Marasinghe, on this occasion. So this is a research project which currently moving ahead, and also currently I am working on it. And I hope it will be very interesting for you for listening this research project. And I hope many of you have many suggestions. I would like to take this as in our Q&A session. So talking about myself, I'm Sahan Disanaika. I'm a Goals Microsoft Learn Student Ambassador and also final year computer science undergraduate at University of Colombo School of Computing. And also I'm a GSOCA in 2021 at Scholar organization. So let's first analyze what is the outline for today. So first, we will discover the background and the challenge of real-time acoustic anomaly detection, and then the methodology and datasets and the baseline, then accordingly feature extraction and modeling, and then finally, let's look at a small demo. So it is crucial to discover the background behind the research to build a foundational understanding about the research problem. So let me ask you a quick question and blow your mind a bit. A machine, and can a machine hear if a machine is broken? So, okay, so think, can a person, an expert technician, hear a machine is broken? So the answer for the second question is obviously yes. An expert car technician, a motor technician can identify an anomalous behavior of a machine. So what about the first example? Can a machine hear a machine is broken? So this is the question that we have. The best example I can give you is during my first year, 3 years back, me and my fellow colleagues went on a trip to Kandy, one of the main cities in Sri Lanka, by train during our vacation. So we started off in Colombo railway station. So half of a journey, an old man, later we got to know he's a usual passenger in the train, near us, told that the train is not going to make it for Kandy because the engine sound is not good for him. So we didn't took that much serious, but however, the train has to stop before reaching to Kandy due to a engine breakdown, and we had to wait around 2 to 3 hours until a new engine replaced with the current engine. So as a computer science student, I got a question. What we can't replace this human expertise for identifying anomalies with trained model with the help of machine learning? and learning and identifying anomalies as early as possible to avoid such difficulties. Maybe it's a very small problem at the early stage of the analysis, but at the end, it has become more complex problem to solve. So that becomes the motivation to my study. So if we are to build such computerized method to detect anomalies, we need to map the real world human behavior into a machine learning. That is how science evolved, by taking human behaviors into consideration. So I have uh, discovered three major considerations. First, the human. In our example, the old man had previous experience on anomaly situation, but if we are to perceive that uh, if you have to perceive that the machine learning model has to have good knowledge, and we need a sophisticated data set with us. And second, he is well trained to identify anomalies. For that, the above mentioned model, we need to train it properly with using machine learning and deep learning models to detect anomalies. And last, human has correctly predicted the anomaly behavior. It's not a false positive. So it has a high accuracy and give remedies early. So our model, to be accurate, it needs higher accuracy and also be proactive measuring anomalies. So the challenge here is how to deliver a proactive model for detecting acoustic anomalies at real time. So this problem, the real-time acoustic anomaly detection, can be considered as a special case of anomaly detection, since we are using acoustic data for analysis purpose and also detecting at real time. This problem comes under the time series domain, since we analyze acoustic data. So how it becomes acoustic data into time series data? So the formal definition for time series data is any observation that has recorded measurements in the orderly fashion and correlated in time dimension creates a time series. So that definition well agrees with the acoustic data, since it made out with the variations of amplitude and frequency properties with the time. So the above figure show a clear picture how time series and acoustic data are related with each other. And when it comes to anomaly detection, it can be defined as a process of identifying data points which are deviates from its dataset's normal behavior. So as an example, the current economic situation around the globe is an anomaly with respect to the normal behavior and the past economic behaviors of the world economy. So the anomaly in different sources has mentioned as in different names as outliers, as novelty points, but it all carries the same semantics. But if we dive deep in and also concerning about anomaly data, there are several types, but there are on it's fair to say there are three major types, namely the point anomaly. It refers when a single observation deviates from the other observation. A good example is a sudden gunshot in a quiet environment is an example for point anomaly. And then secondly, collective anomaly, a sudden few gunshots in a quiet environment is a collective anomaly. And thirdly, the contextual anomaly. Consider the gunshot happened at Ukraine may not be an anomaly, since in a situation like those people heard gunshots infrequently, but a different country like Sri Lanka, maybe in your country, the gunshots may be an anomaly. So is anomaly detection that much hard activity? So sadly, yes. So owing to the facts of the of I have mentioned in this slide. So you may have argued with me, we can do a simple binary classification problem for anomaly detection if we have label data for normal behaviors and also for anomaly behaviors. Yes, obviously yes, but the thing is the normal behavior is evolved with time. So in many fields, including machine condition monitoring, the normal behavior has evolved with time. The one good example is the COVID virus. In 2020, it has only one variant, but gradually it has improved its behaviors and it creates more and more variants. So that's how it changes its normal behavior. And also the problem of domain generalization. Consider an example if we have a machine built in USA and we are deploying that same machine in Sri Lanka or India or China or Australia. So it has different environmental conditions. So if we have to build a domain generalizable property included model, it has to address those different domain generalization properties for different environmental conditions. And lastly, the unknownness of anomalies. Until anomalies happen, we don't know if it is an anomaly or not. So these are the most complex things, and also we can name it as challenges in anomaly detection. So with the improvement of the computing power and the big data, it made possible to do anomaly detection at real time. Under real-time detection, it has many advantages, namely, it helps identifying issues and take actions immediately. Information is up to date and can be used immediately. But in our case, it's not strictly real-time, but it has taken a few time to do the data processing part. But again, it's really useful to have information is up to date, and delay in data processing is minimal compared to offline training. So the best example is the radar map. Hope you all know about radar. So it's a really good example for real-time detection. And when we carry the detection at real time, technically it has some differences compared to the typical acoustic anomaly detection in offline training in acoustic data. So the major four differences we can do when we are building a high-level architecture for real-time acoustic anomaly detection task, I have discovered four major differences between offline trained model and the real-time acoustic anomaly detection. So the thing is, at offline mode, so we don't need additional configuration for noise cancellation and explicitly defined dataset for both training and the inference task. And also the build model at the training phase are we straightforwardly used for the inference task. And also we predict normal and anomaly behaviors at offline mode. But at real time, the difference is we need a raw audio form and raw audio source for the inference purposes. And also we need additional configuration for noise cancellation, and it needs a pre-trained model. And obviously, yes, we predict anomaly behaviors at the real time. So if we map those differences into an architectural perspective, so this is how it looks like. So in offline based model, we have explicit training data set, and we train it offline mode, and we doing inference at the offline mode. But at the real time, we have a raw audio form, and we do necessary configuration for noise cancellation, and we did offline. We have a pre-trained model, and we do the real-time inference task. So this area is highly commercial valuation, has a high commercial valuation and many useful applications, namely machine condition monitoring in industrial application, intrusion detection systems, surveillance systems and network application, military application, in deployed military vehicles, medical applications, detecting bird noises, music instrument failure detections are many, and there are many examples I can give you for this real-time acoustic anomaly detection. So in here, we are only focusing on machine condition monitoring. Let's talk it as MCM. So we only consider in this domain. So moving ahead about the literature perspective of our research project. So and the area of the acoustic anomaly detection is still underrepresented, and not many research plays due to the fact that lack of publicly available datasets. That is the main reason. But it is an active research area for several years from 2014 to 2022. And you can find around 50 research papers by now under these keywords in open access archives for the same name called real-time acoustic anomaly detection. So the contribution from our study, we hope it may be vital for the whole research community. And since we are much interested in the model approach, let's dive into it. So mentioning about the related models, there are mainly four model categories. The first time is traditional machine learning models. The classical machine learning models are the earliest. in the model classes. The early studies employs support data machines, Gaussian mixer models, hidden Markov chain models. But nowadays, those classical models are used as a candidate models for building the hybrid models. And the most widely used model category is autoencoder based model for acoustic anomaly detection. Those also there are established many variants on the autoencoder models like dense autoencoders, variation autoencoders, denoising autoencoders. Might you can come up with your own architecture for autoencoders. There are a lot more. So and also the other two categories are the CNN-based models and the row-based signal models. Talking about the row signal-based models, since these are the models recently came up with the wavenets and hierarchical temporal-based models, usually using for time series classification and generation parts. So talking uh, about the models, you may have observed that I frequently use the hybrid models. So what's the reason behind that claim? So there are two main evidences I can give you. What's the reason behind the recent surge of hybrid models in research domain? The first one is the forecasting competition, time series forecasting competition results and time series challenges and recent publications. So the major finding is the M4 competition results. The Macridas et al. Is one of the uh, main researcher in time series forecasting mentioned that the hybrid models are the next breakthrough in time series forecasting, and also it same applies for the time series anomaly detection as well. And the second example is the decade challenge results, which is predominantly focused on time series anomaly detection for acoustic data, and hybrid model performed by proposed by Siamese Corporation won the decade 20 challenge, which ended recently. So talking about the learning techniques, uh, the supervised model is one of the earliest learning techniques. It needs pre-labeled normal and abnormal data, but later researchers have moved for unsupervised learning and self-supervised learning, and recently for future learning. But the most researchers have still at the unsupervised learning, at the self-supervised learning. The self-supervised learning is some variant of unsupervised learning. It needs some sort of training data and also unlabeled data. And talking about the available data sets, for our research at the earlier stage, we could find a few publicly available data sets. The most popular one is MIMI data sets, MIMI, and there are a few variants of it. And also you can find less popular data sets like DMT, ISA electrical engine data sets. So those are the candidate data sets for our project, but we chosen that MIMI data sets for our research activities. And let's dive into the methodology. So how we are build our real-time acoustic anomaly detection system. So we propose our own pipeline to exhibit the main component for building a real-time acoustic anomaly detection system. It has 4 components. So let's analyze each phase one by one. As you may have observed, the earlier architectural diagram I have presented to differentiate the real-time acoustic anomaly detection and the offline acoustic anomaly detection. So it same applies for here as well. So in the offline training model, the main purpose is to train a pre-trained model, to take a pre-trained model. And at the real-time inference phase, we observe the streaming data from the raw audio waveform. And from the pre-trained model characteristics, we are predicting that the incoming data, how much anomalize for the incoming anomalies data. So if we dive into one step deeper, the low-level acoustic features, how the low-level acoustic features convert into analyzing anomalies given by this diagram. So if I elaborated more, the raw audio waveform converted into a spectrogram at the feature extraction phase, and our model approach, hybrid model to be exact, So analyzes and extracted features, and then our anomaly score model analyzes and assign an anomaly score based on the deviation of its from its normal behavior. For now, we have incorporated two candidate models for our baseline model task. First, a dense autoencoder and a mobile VNet model, CNN model. And then we created a simple hybrid model for combining those two architectures in such a way for building a convolutional autoencoder. So for the data integration, for the offline offline training purposes, we incorporated Mimi and MimiDev datasets since it has advanced labeling and it has additional configurations for present for domain shifted conditions, and it's really help for us to address the main problems in anomaly detection. And also for the raw audio signal source at the real-time inference phase, we integrate additional noise cancellation and pre-processing mechanism, including with the denoising layer. And to talk about more about MIMI datasets, it's abbreviated for malfunction in industrial machine investigation and inspection. It made available by Hitachi Limited under Creative Commons license, and there are 4 machine parts, namely valve, pump, fan, and rail slide, and it has around 1000 normal instances for each machine type, around 150 instances for each abnormal instances, and it downsampled for 16 kilohertz. These are additional configurations for about datasets. And let's jump up to the feature extraction phase. So feature extraction, as you know, it's a process of highlighting the most discriminating and the most impactful features of the acoustic signal. And then we use windowing technique to remove the spectral leakage, to analyze the series with more ease and divide it to small segments. It's really easy to partition into small number of segments and processing it. So this is the most popular widely used windowing equation for to take the number of segments in a acoustic signal. So same step size and the window length use of both offline and real-time real-time audio inference. So windowing results a feature map, as you can see here. So the audio features, we converted it into a time domain from the frequency domain. Since it move into a frequency domain, it enables to capture more wide range of features. So it can be enabled to taking by the MEL spectrogram by defining a hop length and a frame size, as you can see in those two diagrams. So these are some of the results we have taken from the feature extraction phase. The most effective method is the log-MEL spectrogram, as we have analyzed in our experimental phases. So if I elaborate more, the spectrogram obtained from the Fourier transformation is a 2D representation, and we feed those spectrogram sequences into the model as feature vectors. And then as the most important phase of our pipeline is the modeling and the training part. So we incorporated 3 major model classes to form the hybrid models. By now, we only incorporated autoencoders and CNN architectures, but later phases we are hoping to integrate GAN models with LSTM models. So the hybrid architecture attempts to improve the model's performance by aggregating its model capabilities, we are forming a novel architecture. So having a special concentration on the reconstruction-based model. So it is kind of a separate model class of the whole acoustic anomaly detection model classes. So the namely autoencoders, which are very useful for detecting point anomalies and collective anomalies. So, and also the CN architectures are very effective for analyzing the collective anomalies, but less effective on detecting the contextual anomalies. But so our initial hypothesis was by incorporating and building a hybrid architecture will address more proactive model, will result a proactive model to detecting both 3 anomaly types, namely point, collective, and contextual. And since the feature extraction generate the set of spectrogram, so the modeling phase are detecting and training the learning the spectral features detected at the feature extraction phase. So this is the network structure of the baseline AE model. So as you can see in the right hand side, this is a Keras implementation of our dense autoencoder model. So there are 4 layers for encoder and decoder, and then we come up with Lockmel energy of 128 bins, and we incorporated batch normalization with a relay activation date. And this is the network layer diagram for our dense autoencoder architecture. As I said, there are 4 layers for encoder and also for the decoder, and it has late 8 neural network for the latent space. So these are some of the experimental results we have obtained for the training loss for both for main 4 machine types, namely fan, slider, pump, and the slave slider. So the hybrid model approach, which we have implemented by integrating the CNN architecture and the auto encoder model. So this is the spectral features and the network architecture are pretty much similar compared to autoencoder, dense autoencoder, and also you can see the Keras implementation of the convolutional autoencoder based model we have implemented. But as a quick note, this is some kind of an improved version of the Ribeiro et al. 2020 proposed model, but the very less models have been implemented for real-time acoustic anomaly detection, not for offline training purposes. So this is the network layout for the convolution autoencoder architecture. As you can see, it has a shape of a convolutional neural network with a latent space of the autoencoder. The results we have obtained from the convolutional autoencoder are pretty much same as the autoencoder, but it has very improved results. And talking about the last phase of our pipeline, which is the anomaly score calculation, it is where it analyzes how much the obtained signal is deviated from its normal behavior.
You're doing great, but you've only got like 2 minutes left.
Okay, thank you. So the total reconstruction error given by the summation of mean distance for all sequences. And this is the most widely used evaluation matrices we have already integrated for RUC and also the partial AUC as our evaluation matrices. And this is the most important part where we are integrating the anomaly score calculation, where we calculating the error between the reconstruction based signal and the normal behavior of the signal. So based on that, we are taking an anomaly score, and based on that threshold we are defining by the Jordan index, which is denoted by J, we are indicating that the anomaly score, whether the signal is anomaly or a normal signal. And at last, since I have a limited time up left, so it is the results I have taken for the dense autoencoder and for the hybrid models. As you can see, it has more improved behavior with respect to the dense autoencoder. And as you can see, it has more the dense autoencoder is pretty much good for analyzing anomalies, but not for the detecting the normal behaviors. As you can see, recall is at 1.0 and precision is at 50%. But in our hybrid model approach, it has 72% of precision and 83% of recall. So technology and software is pretty much a Python-based implementation. And let's dive into a quick demonstration. Let me wait to open my code faces. And yes, this is my React frontend application, which have deliberately to implement the auto to analyze the real-time acoustics. So this is somewhat a proof of concept model. So currently it has predicting that a model is under the 36 model, but later we'll see in quite a while the anomaly score will change gradually. Now it's 18.81, and it will see, since it takes some time to do the pre-processing task for the detection of the anomaly score. So that's all I have to present you today. Hope you all enjoy my presentation. So thank you very much. Thank you, Global AI Student Conference, the whole organizing team for giving me this valuable opportunity, the wonderful opportunity to present about my research project. Thank you.
Yeah, thank you.
So, welcome back to the Global AI Student Conference. We are ready for our next presentation about training a simple model using Azure Machine Learning Studio. Let's welcome Pansal Alemsi. Sorry for pronouncing wrongly your name.
Pascal, are you there? We think you're muted right now, Pascal. Some temporary technical difficulties, but that is perfectly fine. Oh, Pascal's here now. Oh, that's fantastic. It's so nice to see you, Pascal. Welcome to the Global AI Student Conference.
Hi, so we cannot hear you. Can you hear us?
We'll do a quick pause here as we get Pascal connected. So once again, if you just joined the stream or if you've been here a while, we have a cloud skills challenge going right now with the Global AI Student Conference. You can learn more at the link below. It is aka.ms/learn-challenge. Also, in addition to the cloud skills challenge, you can have your very own opportunity to earn your own learning badger at aka.ms/gai-badger. And this is a super cute badger that you can have, and you can join a community of where over 13,000 of these badgers have been released. You can even collect different types. I personally have an AI ambassador badger, so there's tons you can earn. It's a lot of fun. And we'll see if Pascal, can you hear us, Pascal? Give us one moment for technical difficulties and we'll be back in just a second.
My take on life is that life is definitely there for the taking. What you put in is what you'll get out. Two things important to me in life are family and music. They both play a huge part in my life. Technology allows me to be my own one-man band. I try to be as independent as I can, and the way that I do that mostly is with low-tech, which is a white cane, and high-tech, which is a phone.
Seeing AI.
Seeing AI is one of the biggest deals in technology, I think, at the moment for visually impaired users. It's an app that you can read almost anything, anywhere with it.
Kilburn High Road. Fashion. Workspace. Mayonnaise.
It has a multitude of functions, and they all work together to produce something that you can use whenever you need it. It might even be considered to be a Swiss Army knife of apps. Of all the parts of Seeing AI, I really do think short text is the biggest of the game changers.
Northwest 6.
Because I've never seen anything like that in any other app before. And I like being in the back of cabs or in buses and pointing it out the window and seeing what I pass on the way to places.
Mobile phone NC 4000 services.
One of the greatest things about short text for me is that if there's no one else in the house, I can sort the post into who's who.
Mrs. K. Louis. Mrs. Kirsten Louis.
So I don't open my wife's post and she doesn't get cross with me. Package.
Yo, well, Andre.
My man Alex.
Good.
One fella.
Blessed.
£20.
That's really cool.
Currency is a very useful channel because sometimes it's very difficult to know what notes actually are. So with currency, I can detect that straight away.
£5.
Job done. 2025. Well done.
Scene preview.
Scene is actually really cool. It's quite descriptive, really.
Processing. A store filled with lots of different types of fruit.
I think that's pretty amazing.
Twitterific.
In my view, one of the best parts of Seeing AI is the ability to read pictures from social media. Because so many times someone will send me a picture of something that I cannot understand. So I will share that picture to Seeing AI.
Scene. Probably a group of people sitting on a bench in a park.
And then I'll get a description of what it is.
Person. 8-year-old boy with black hair looking happy, 7-year-old girl with brown hair looking disgusted.
And it's changed how I can view social media. It feels like I can participate.
Like, reply.
Far more than I could before.
Thank you for sharing. Handwriting preview.
With Handwriting Channel, I was actually able to read a card from a family member last year. That's the first time I'd actually been able to do that without help.
Dear Dad.
That was
Alice
very
worked.
good.
We can tell if Jake's been writing well if the handwriting tab can recognize it. That's good proof, really.
We love you, Daddy. XXXXXX.
We've got lots of X's.
Yeah.
The effect of having Seeing AI to hand all the time is like having somebody who can see in your pocket.
34-year-old man with a beard wearing a hat looking happy.
Why not?
There is so much more that I can do now that I couldn't before. You've grown up.
I used to be nice.
I think Seeing AI really is a huge technological step down the road, and I hope that we can continue down a road like this for many years to come.
Awesome. Welcome back to the Global AI Student Conference. I'm Loxley Kolakowski.
And I'm Fornisa Vidu.
And before we get started with our next talk, we want to talk about our Cloud Skills Challenge at aka.ms/learn-challenge. You can participate in our challenge to learn all about Microsoft AI through completing Microsoft Learn modules. You can also earn your very own learning badger from aka.ms/GAI-badger. And this is just a super fun way to get your very own NFT in a wallet. And there's tons of badges you can collect, so it is very fun. And now we're just about ready to get started with our next panel from Developer Days. I am super excited to hear from a lot of experts in the AI field.
Hey everyone, and welcome again at the Global AI Developers Days. You are now watching the kickoff event that is all about the possibilities of AI. In the past 2 hours, we have seen the inspiring keynotes delivered by our panelists. Now, this is your chance to ask our amazing panelists the questions you've always wanted to get answered. Now, to do this, if you have a question, use the chat on your platform of choice, and our moderators will pick them up. Well, moderators, that's Shoka and me. So let's welcome our panelists and get to know them a bit better. So we'll start with Eric Boyd. We have 2 Erics on the call, but we'll start with Eric Boyd. So Eric, thanks again for your insights that you gave during your keynote about AI innovations at Microsoft. As I said before, I was really impressed how Microsoft really tries to democratize AI and all the work that your team is putting into that. Now, since the first Global AI Bootcamp in 2018, you have been part of all the events throughout the years. So I hope for many people you are a familiar face, but for the people joining and being part of the community for the first time, could you quickly introduce yourself again for the ones who are just joining this call?
Happy to. Yeah, I love the community and happy to be a part of it. So I'm Eric Boyd. I lead the AI platform team at Microsoft with fabulous tools like Azure Machine Learning and our suite of cognitive services.
Yeah, thank you very much. Just a random question to make people get to know you a little bit better. What was the first computer you touched?
First computer, my dad had the original IBM PC, but I didn't get to use that one too much. So my first computer really was the TRS-80, the Tandy color computer.
Okay, cool.
Nice. Our next panelist is Ekaterina Marinova. Welcome, Ekaterina. Thank you so much for your useful talk about all the skills you need when you are working in the field of AI. I really learned a lot, and I also noticed that I have lots of skills that I need to add as well. I want to ask you a short question to get to know you a bit better as well. What was the first AI project that you have been involved in?
So thank you very much, and thank you for having me in these great panels, these great discussions. My first project, so I was working in Microsoft back then, and my first project, and I got it afterwards, everybody was chasing me for that, was actually working on a chatbot, which I considered like a very, very deep AI project. Back then, this was like the first thing that I was working on, but it was a chatbot solution that further developed within the organization and within machine learning within the organization, and working with the employees and the organization back then, the company.
Nice, great project to work on, and also a background at Microsoft. Wow.
I started my career there. Yes.
Yeah. Okay.
Amazing place.
Great.
All right, and then we go to Francesca. I really liked in your talk how you brought all the items together and the machine learning operations and all the tasks that needs to be done. And you also show that ML Ops is not just a tool; it's also a way of thinking how you start your projects. Also, a quick question to you: what's the first software that you touched?
So first of all, thank you so much for inviting me today. So the first software I touched was MATLAB, which was a software that as a scientist we were using at university to run a few data analyses. And that was the first software that I used. And I have to say was the first software that gave me the possibility also to start working with data and start building those preliminary machine learning models.
Yeah, interesting.
Yeah. And our last panelist, Eric Pounds. Welcome to the panel. Eric, you work at NVIDIA, and we heard some great insights from your colleague Manu Veer about the essential things you need to know as a developer in this new age of AI. Welcome to the show. And we have a question.
Thank you for having me.
Yes, great that you are here. And of course, we have a question for you as well.
Sure.
To know you a bit better. What was the first game you played?
Wow, a lot of things can be qualified as games, but I guess I can remember my first electronic game. It was a miniaturized arcade version of Q*bert. I guess I got it sometime in the early 80s. I'd sit on the floor and play it for long periods of time. And actually, that reminds me, I need to go to my parents' house and find that game. I need to save it.
Okay, great. I don't know that game.
Me neither.
No.
No, the Erics are laughing with us now.
So if you found it, please share something with us about it.
We'll do.
Yeah.
There's those specific streaming platforms where people are gaming on. Maybe you can start your own streaming channel. Okay, so we're here not to discuss these kinds of things, of course. We're here to talk about the future of AI. Well, there's no doubt that AI is getting more and more embedded in our daily lives, and we see it everywhere around us. Now, in solutions that help us do our work better, faster, and even more accurate, but also solutions where we put decisions about our lives in the hands of AI systems. I'm super excited to hear from you all what you think about the future impact on AI and the society. But before we dive into the future, maybe you'll need to have a good understanding of the state of AI right now. So maybe Francesca, I can start with you. Can you tell us the current state of AI, what is possible and what is not possible?
Excellent question. So I do think that the current state of AI is, first of all, very interesting from a professional point of view, in the sense that there are many different professions that have been created around this field. So when I started many years ago as a data scientist at Microsoft, I have to say that my profession was considered a little bit new. A lot of people didn't really understand at that time what I was doing. And then the more I have been working in this industry, the more I noticed that there are so many additional professionals that are working also with me. Like I work with now data scientists, machine learning engineers, data engineers, MLOps developers, also product managers that are the ones that develop the tools that are then used by all these professionals. So what I think that is currently possible with AI is the fact that we have this exposure of AI to many different people around the world. So you don't really need to be a data scientist, or you don't really need to have a PhD to work in machine learning and in AI to build those solutions that then are going to have an impact to other people. And so there is all that theme about democratizing AI and also the creation of machine learning solutions and AI application, which is great. During my talk, I also presented a few open source tools that have been like super well integrated also on the cloud. I myself and my teams, we work a lot with Azure Machine Learning, and some of those tools that I presented are PyTorch, TensorFlow, Ray, if you are in the reinforcement learning field. And so all of these is great. Like, I think that we all are in a moment of history where we know that that there is so much potential
in AI, and a lot of big tech companies are working to creating those tools that are opening up the potential of AI to many different people, which is great. On the other side, what you also asked me, part of your question was like, what is not possible with AI? Well, there are a lot, of course, of risk with these potentials, because of course, when you start opening those tools, those open source frameworks, those AI application APIs that a lot of people can leverage in order to build those solutions, means that, of course, there are many different individuals that can start building their own application. There are many different data that can be used, and that, of course, create a risk also from an ethical point of view. So I do think that there are some tools that needs to be implemented as part of the current situation. I personally use a lot of also Python packages that can help with that, such as InterpretML. We have Fair AI, which are like great tools also to assess the level of fairness of your AI applications. However, there is still a lot that needs to be done everywhere in the industry in terms of privacy, data governance, and more of these things. So that is, in my opinion, an aspect of AI that we need to keep investing on.
Right. If you look at it, what is possible now, we see that more and more people who do not have AI skills can start building their own tools. But of course, they need to be careful what exactly they're building. And therefore, of course, we have the specific frameworks that are there that can help them to grow into building something responsible, for example. Now, if you would be allowed to pick one project that you say, like, this is really the best AI project that is being built at this moment, what project would come in mind?
Well, a project that I have been probably working a lot with a few students at university, actually. So it's a project that I have been working on actually during my weekends. It's about image recognition for drug discovery. And I don't want to mention the project as like the only example of the best AI project I have been working on, but I want more to talk about the field. I do think that right now AI and machine learning application have been used a lot in the field of drug discovery. And I'm based in Boston. So in Boston, we do have a lot of biotech companies and also pharmaceutical companies, and also a lot of startup researchers and students that are working in this field. So I'm not going to name one specific applications or one specific project, but I do believe that that is also a huge field for AIs to contribute to. And we saw, of course, some of the results also recently after the global pandemic that we all had to face, and some of the discoveries that help us also to overcome that very challenging moment, that pandemic. They had been actually discovered by some researchers in the Boston area using machine learning AI on, of course, drug discovery use cases. So I do think that it's probably one of the most inspiring cases where I see that AI is really helping our society to overcome a very challenging period of history.
I can imagine, especially in drug research, that a lot can be done and fast forwarded, and research that before took a lot of more time. Eric Boyd, do you have anything to add on to what Francesca already said? Oh, we cannot hear you.
Maybe
Just
you're
give
on
us a
mute.
second.
Yeah, sorry, my fault. So I think, there's so many different and exciting fields that are moving so quickly that to say, like, what is the state of the art, like, and so Francesca talking about sort of vision and drug discovery and all of those. I think there are a lot of interesting applications there. The place I'm most excited these days is in the large language models. We've just seen, they've just exploded over the last 3 to 5 years, and they continue to get more and more powerful. And the types of things that you can do, I think, are really going to be, pretty amazing. And you combine sort of those language models now with sort of generative vision models and some of these diffusion models and things like DALL-E. And so now you've got tools where someone who's not particularly creative, who's not particularly talented artistically, or, maybe is struggling to sort of come up with something to write, now has these tools that can really unlock a lot of potential for them. And so I think a lot of that's really pretty exciting.
Yeah, those are very pretty exciting. I've seen some examples of DALL-E, and that's a really promising model. Yeah, totally agree with that. I'm very impressed what AI can all do and how fast things have evolved in the last 10 years. Now let's move 10 years into the future. Eric Boyd, what do you think about the future of AI? Is it going to change the world as we know it in 10 years?
I think someone once said that we overestimate how far things will go in 1 year and underestimate how far they will go in 10 years. And I think that's probably the case. The types of things that we're seeing that AI is capable of doing can completely change the way that we interact with computers, what we expect for them to do. The kinds of things that we've been sort of dreaming of, I'll just talk to my computer and it'll just have this assistant, the Star Trek, assistant. Those things are all going to become real. And so it's a matter of when exactly, but the potential for it is really sort of seems like it's coming quite quickly. And so I think it's going to really force us to rethink the interaction patterns that we have. How do we, the machine human interface right now is mostly typing. It has switched to swiping on phones. I think a lot of it, more of it's going to be vocal, and it's just going to be much more ambient. We'll see a lot of it more around us, because we'll have the power of computing, plus we'll have the power of the AI technology to really enable those types of things. So I think it's going to be pretty profound. And I really feel like, we keep seeing sort of the knee in the exponential curve. The AI power in some of these models is really just starting to race up that knee. And so I think we're going to be pretty amazed at the types of things we're able to do in the next 10 years.
Yeah.
Oh, I think exactly, Eric, as you said, we have the DALL-E and the GPT models and so on. They're really going to change the way we are looking at certain things, or having specific business processes that might be automated in ways that we've never thought about. But that, of course, brings us to other items. It's all of those items need serious compute capabilities. And then, Eric Pounds, I start looking at you also. Where do you think all that, will we get there? We have very powerful GPUs now. Are we still in a growing curve, exponential, or how are you looking at that for the next coming years? Will we be able to get enough compute power?
Yeah, Eric Boyd, you mentioned LLMs, large language models. I think first off, what's available today is extremely exciting. Like in large language models, for example, a year ago, in some of the folks on our team working with the Microsoft team, we trained a 530 billion parameter model, the Megatron Turing NLG model. And we, at NVIDIA, we recently demonstrated our AI framework for large language models, NeMo Megatron, on Microsoft Azure, powered by NVIDIA A100 Tensor Core GPUs and InfiniBand networking to tie all that together. And that framework is today designed for billions and trillion parameter models. So it's possible today. I'd say the future capabilities available to us are very promising and exciting. I think one thing everyone needs to think about, and Manavir touched on this in his session, is one, it's a full stack challenge. So as the hardware capabilities evolve, they can only reach their full potential with the software evolving in lockstep. So for example, at the hardware layer, there's a lot of things that can be done, but we need to think much bigger than just the instance, the system, or the cluster. We need to think data center scale, cloud scale. These models are very, very large, and they need to span many, many, many instances and nodes, and they need to all work together. But within the system, there are advances coming. Like in NVIDIA, we just recently announced and launched our H100 Tensor Core GPU, which will deliver significant faster processing on these larger models as a new transformer engine built into it. And we also take these and then assemble all these capabilities into superpod-like architectures to find optimal ways to scale. So there's promising things, moving forward. But training, customizing, and leveraging these large models wouldn't be possible without these software innovations. These frameworks to substantially reduce the time and cost to fine-tune these models for specific tasks. And also then throughout the life of these hardware generations, the software will keep evolving to make these systems even more capable. Like, I mentioned how, what we were able to do on the A100 GPU and a large cluster of those just last year, that may not have been possible when we announced and launched the A100 initially. A lot of the software evolved to take advantage of a lot of these capabilities. So anyway, a good way to be thinking about the future of computing and how it can be leveraged.
It really goes hand in hand, software and hardware, and then
yeah, exactly.
Eric Boyd, do you have anything to add to this?
I mean, I think I agree with a lot with what Eric Pound said. There has been just phenomenal hardware, performance improvements, and we certainly are looking forward to doing a lot more with the H100 series of chips, and very excited about the potential that'll come. So I think we do see that the hardware is growing. Moore's law is definitely suffering, but we're still seeing tremendous power growth, and so I think that's something that we can continue to look forward to.
Endless possibilities. Yeah,
Exactly.
and don't think we have to wait 10 years for that. No. Okay, next question is for Ekaterina. You have seen many projects over the past years, and also from different perspectives, from different companies, technical angles, and business overviews. Can you share your thought on how the future of AI will look in 2032?
Yes, thank you very much for this question. I agree with a lot of what the others have already said. My perspective, also based on my experience, is that in the beginning we were talking about research. Then we started talking about products, right? We were focusing on the technology, we were focusing on the products. Then we switched to solutions. So we started incorporating these products into different solutions and started moving towards selling and positioning those solutions. Now we are moving to redesigning industries. Now we're moving to redesigning industries through those solutions, through those technologies. And I'm absolutely sure that all of these will keep evolving, and we'll be talking about amazing technologies. We'll be talking about holistic solutions and full redesign of the industry, like a new approach to the industry. And for sure, this will happen in the following years. I cannot say exactly how many years. Because even before we were predicting that AI will be there sooner or data science will be big in certain time, and everything happens with this technology growth, with this, like, companies are adapting, technology is moving forward. But then on the other side, we have people, we have academia, we have the community, we have the recipients of this technology, the recipients of these solutions, and the way they accept it, the way they think about it, the way they think about this technology advancement, about this industry redesign, about these solutions. And I believe that the true growth of AI will come when it's incorporated in education, when it's incorporated in the communities, when we're talking about AI open data, when we're talking about this data philanthropy that I was talking previously, about AI being shared across organizations, across academia, across all those hackathons that have been organized. So talking about another approach, talking about another way of thinking of AI, not as something new, but something that's there, something that will be there, and something that will keep evolving.
Yeah, totally true. It's the people in the end that need to that are going to use it, and they need to adapt it before it can fully evolve. Yeah, thank you so much.
Well, I think without a doubt, AI is going to have a big impact on the future. But we also know, as Uncle Ben of Spider-Man says, with great power comes great responsibility. How do we keep our future selves safe from AI, making mistakes and doing the opposite of what we intend to do? Francesca, as a data scientist, this is kind of also in your hands. What are your thoughts of how do you make sure your models are fair and transparent?
That is an excellent question, and I try to cover part of the answer to this very important question also in my keynote today. Generally speaking, I try as a data scientist, and together also with my organization of data scientists, we try, of course, to follow some principles that Microsoft created. However, I do not think that these are Microsoft principles. I do think that those should be industry principles. And of course, if I can mention them, there are accountability, inclusiveness, reliability, safety, fairness, transparency, privacy, and security. So those are somehow the principles that as a data scientist, as a machine learning scientist, data engineers, of course, you always have to look at them and try to cover each of them, but most importantly, there should be like tools that allows you and your team to include them as a part of your data science machine learning lifecycle. I also think that it's important to make sure that there are open source tools available to cover some of these principles, if not all of these principles. So just to give you some more like applicable example for explainability, some of the open source tools that I use all the time are like for example, the open source framework called InterpretML. So it stands for Interpretable Machine Learning. That is this open source toolkit that helps to achieve a model explainability. And what is very nice is that it produces for you in your notebook, or also if you're using another tool, like for example, in my case, I'm using Azure Machine Learning all the time. It allows you to look at those visualizations that really gives you a very nice overview of why your model is producing specific results. We call it at the global level and at the local level, meaning that you can get this overview, a very clear understanding of why your model is producing specific results, both at the model level, meaning at the different features and variables level, but also at the specific data point level, which is extremely important, especially when you are looking at the impact of your model to a specific, for example, user ID or to a specific customer ID. So the individual level, it's or local level, it's very important. So this is just one example. Another open source toolkit that I have been using very often is FairLearn. It's integrated in Azure Machine Learning and is another Python-based open source tool that allows you to assess the fairness or the fairness level of your machine learning model. And that it's great, especially when you are using a specific data set that you think is representative enough of the population that you are targeting with your AI solution. So these are just a couple of examples, but what I'm trying to say here is that always try to integrate those tools and those open source toolkits in your solutions, and really they need to be part of your development cycle when you are building as a data scientist machine learning solutions and AI applications.
Okay, thank you very much. I think especially the frameworks that you mentioned already, they're very useful. Now, Eric Boyd, you are responsible for the AI department within all of Microsoft. How do you make sure that everything that is released is also responsible?
Yeah, I mean, we follow the, Francesca's touched on it, right? The AI principles, responsible AI principles. They're super important to us. And so we think a lot about how to develop models responsibly, so much so that we've also released the Responsible AI Standard, which is a set of practices that we follow. When developing a new model, we do impact assessment. So let's think through all the different ways that this model might impact people, and particularly the ways that we, might not think of, up front. And then we come up with what are the set of mitigations that we can come up to minimize those. And so really make sure that we're thinking through them responsible. What are the sets of tests we need to run? What are the tools that we need? How do we use tools like, FairLearn, error analysis, and all these tools to help us understand, what's happening with the models? And so, having these practices and then really disseminating them throughout the organization is absolutely key to make sure that we're doing this in the right way. And, sometimes it leads to us making choices about we'll gate or restrict certain products. If you want to use custom neural voice, you have to have sign off from the voice actors. And so there are a number of things that we want to do along the way to really make sure that the products that we have are being used in the way that they're intended. really we just feel a deep responsibility as creators of this technology. We have to make sure that the benefits of it really accrue to everyone and not just to specific groups. And so keeping focused on that and thinking through the ways that we can do that better, that's the thing that really drives us.
Yeah, thanks very much. I would like to ask the question also to you, Eric Pound, because as hardware manufacturing, you guys also make a lot of frameworks available for the public. How do you handle that within how it's used, the services?
Well, I'll echo what Eric Boyd said as well. Also, I think so definitely the way that you not just the way that you develop your software, but the way that you test your software, really understanding your audience. A lot of these audiences are global, so keeping that in mind as you're testing and tuning these softwares and these models. I think the only other thing I'll add is just also deciding the domains that you decide to invest in. Right? There's a lot of solutions for AI, and what you choose to invest in, what you choose not to invest in. I think is another big part of this decision process.
Okay, Ekaterina, anything to add up on everything that has been said already?
Well, everything that's being said is I totally agree with. I'll go back to a point that I've mentioned. For me, when we're talking about responsible AI, when we're talking about ethics, when we're talking about thinking while creating this, thinking while we're working in this area, we should be talking about a holistic process. So having this in mind from the beginning until the end.
Wow, thank you.
Welcome back to the Global AI Student Conference. Our next session is about responsible AI. Our speaker, Luis Beltran, a Microsoft MVP, developer technology and AI, and a PhD student in engineering informatics. Hi, Luis.
Hello, good evening, good morning, good afternoon, wherever you are joining. It's a pleasure to be here.
Thank you for being here. So you may share your screen and start your presentation.
Yes, of course. So, okay, I'm sharing. Let me know if you can see it.
Yes, we can see it.
Excellent. So, welcome to today's presentation in the Global AI Student Conference about Towards Responsible AI. My name is Luis Beltran. I am a Microsoft MVP in Artificial Intelligence, Azure, and Developer Technologies. I am a Mexican, but currently I am living in Czech Republic because I'm pursuing my PhD at Thomas Vata University in Engineering Informatics. My research topic is actually computer vision, emotion detection, and face recognition. So let's get started with this interesting topic. Actually, last presentation shared several thoughts, and it was really interesting. So it's a good introduction about this topic. So when we talk about AI, we usually refer to a machine learning model that is used within a system to automate something. For example, you might think of a self-driving car that takes images from sensors or using sensors. Then there is a machine learning model that uses these images to make predictions. For example, if an object is detected in the picture, is it a tree? Is it a person? Is it just the road? Then with these predictions, the car makes decisions. For example, follow the path, turn left to avoid the tree or the person, and so. And the whole system is AI. However, when we develop AI, there might be risks. And maybe what we are developing is unfair or simply seen as a black box that makes decisions for humans, like magic. So we need to know, or we need to think that AI brings unprecedented opportunities to businesses, organizations, but there is a lot of responsibility because it directly impacts people's lives, and it can raise some questions around AI ethics, data governance, trust, and legality. You might see on the screen some research, some numbers about if people trust in AI. Well, consumers only 35% trust on what organizations offer regarding AI. On the other hand, around 77% of people believe that organizations should be held accountable if they misuse AI. So, well, as you can see, it is quite important to consider some regulation, maybe some steps that organizations should take in order to comply with maybe some rules or just use AI in fair and square way. And that's where responsible AI comes into play. And it involves several actors, data scientists, machine learning engineers, and also, of course, consumers. So what is responsible AI? Maybe we can have a specific definition. So responsible AI is the practice of designing, developing, and deploying AI with good intent in order to empower people, employees, businesses, organizations, and impact customers and society fairly, safely, and ethically in order to build trustness in AI and also scale it more securely. Responsible AI is the product of many decisions made by people who develop and implement machine learning models. From the purpose of the system to the way that people interact with these systems. So the idea is to proactively guide decisions towards more beneficial and equitable outcomes. So people and their goals are the center, the core of the system design. And well, it also promotes some values like fairness, reliability, and transparency. Actually, several companies have developed or believe in some principles of responsible AI. Microsoft is one of them, and they have developed a responsible AI standard, which is a framework for building AI systems according to 6 key principles: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. In this case, Microsoft considers these principles as the foundations of a responsible and trustworthy approach to AI, especially nowadays as intelligent technology is more prevalent and we can see it everywhere in different products. Well, during this World Day, you have seen different applications of AI, interesting discussions, and actually I'm looking forward to one of the upcoming sessions about stable diffusion, so where you can generate interesting images, but well, there are also some ethics behind. So well, let's talk a bit about some of the principles and maybe see some examples. Okay, so first of all, we have privacy, and yeah, this is one of the interesting topics because, well, I work a lot with computer vision and I use a lot of face data sets. So AI systems like this voice tagging or facial recognition can be used to breach individuals' privacy and threaten security. For example, an individual's online footprint can be used to track, to deduce, or influence someone's preferences or perspectives. And nowadays, it is a serious concern that needs to be addressed. You can see that we might have these deep fakes, which are nice. Let's say that you can swap your face with someone from maybe some famous actor, like there is a movie, there is some video. You can think of your favorite actor, and then you swap your face, and it's as if you were acting on that movie. So this is some, let's say, nice, fun use of AI. However, there is also the fake news. Someone can swap your voice or your, let's say, your face and create a fake video where you talk about someone, where you, let's say, behave bad or just to affect your reputation. Unfortunately, we live in a world where viral videos can be viral, let's say, very quickly, and even though they are fake, the harm is done. So, how to protect our identity? How to verify that whatever is posted on social networks, if it is talking or if it is referring about someone, it is who claims to be, for sure. So that's the privacy thing. Privacy is any data that can identify an individual and maybe even their location, activities, and interests. And this is important, especially here in Europe, because of the GDPR and other laws. So you can think of some example. Maybe we have some couple of reports. Imagine that there is some case and we analyze some data and there are some reports, there are some aggregations. And let's say that we know or we present that in our study, 10 participants shared data about location, about salary. The aggregated salary report tells us that the average income of a person from Seattle is some amount, let's say $96,000 US. Then we know from another report that 10% of workers are from Seattle. So we can quickly figure out the specific average salary of the single person from Seattle. So we have, let's say, affected the privacy of this person. So what can we do to protect, let's say, that kind of data? So one solution is differential privacy, which is a technique that, of course, seeks to protect individual data by adding a statistical noise to the analysis process. So basically, this noise ensures that data aggregations stay statistically consistent with the actual data values. But there is some random variation, which makes it impossible to easily figure out the individual values from the aggregated data. So you can observe that now we know that 9.6% of people are from Seattle, so maybe it is not easy to figure out how many people, like numbers, a specific number. And also the average salary, there is some noise, or there is some difference. Now it is not the precise amount that we presented in the previous report, but something that doesn't affect other calculations, that it stays in some range, let's say. And how we can actually implement it in our machine learning models? Well, there are several projects. In this case, there is a Smart Noise, which is an open source project co-developed by Microsoft, which contains some components for building differentially private systems that are global. So the idea is that we add this package, this library, to our analysis, and then the aggregated data contains this noise. We can actually control the level of variation, the noise level, by some parameter known as epsilon. And well, if we increase, let's say, the epsilon value, let's say the noise is less, so there is a reduced privacy. However, the accuracy of the model, machine learning model, is high. On the other hand, if we have low epsilon value, we will get the most privacy at expense of very, let's say, a reduction of accuracy. So it's, of course, some balance between the privacy and also try not to affect at all the accuracy of our models. So we can demonstrate this. Okay, so here I can present, I have Azure Machine Learning Studio, and I will increase this a bit. Okay, so in this case, maybe we have some diabetes data set. And okay, so we install our smart noise package. Then we load the data. As you can observe, we have this data set. So there is, let's say, some information about patients, like number of pregnancies, plasma glucose level, body mass index, and all these features in the end determine if some person is or not diabetic. Then maybe we want to protect some specific feature like age, right? So we can observe at the beginning that the average age, this is the average age, is around 30.134. So that's the average age of all patients. And then if we, let's say, include our smart noise library, we can affect, here you can observe we perform some analysis, statistical noise analysis, and we use differential private mean function, right? And we pass our age column, right? We use epsilon value 0.1, low value, and we can compare that the differential private age, mean age, is 30.048, while the actual data is what I said earlier, 30.13. So we see that the value is quite similar, not exactly the same one. So there is the noise. And well, we can also use it for data distribution in histograms. So maybe you cannot see it at all, but there is a minor difference between frequency in different range of, let's say, age. We can also calculate let's say, the covariance. That is the relationship between variables. So the actual covariance, for example, between age and diastolic blood pressure is 8.72, which means that if one value increases, the other one is also affected in the same way. So there is also increase, or they both decrease in the same rate or relationship. And by applying differential privacy, in this case, we apply again DP covariance, the differential private covariance method, we also obtain positive value. So yes, there is still noise involved, but we don't affect our main outcome, which is to find the relationship between these two variables. And well, we can also at the end compare what happens if we use low value and high value of epsilon. In the end, we can add noise, but also affect the accuracy well. So it's about finding some balance. Okay. So well, I presented this already, so you can, if you want, I can share later this notebook. It's fine. You can just send me an email. I will share my contact details at the end. So what's next? Then we have another, or we can talk about another, let's say, principle, in this case, fairness. So the idea is to build models that don't affect negatively people according to some features like gender, age, ethnicity. We don't have to discriminate. So let's say that we are building a model that accepts or rejects, let's say some that people can get money, let's say some loan for something. So the model needs to consider the different variables like age, like income, of course, the amount of loan, but and there will be some decision. It can be positive or it can be negative. But the model must not discriminate, and just because this person belongs to some ethnical group, it will automatically be discarded. So yeah, we should avoid those cases. And well, I can of course we can see it on action. So let me show second example, which is about fairness. So in this case, again, we have the diabetes data set, and we want to find, of course, in a model, maybe we want to predict or inform a person if they will develop diabetes or not, according to some characteristics, as we said earlier, like diastolic blood pressure, plasma glucose level, and so. So let's say, right, that okay, after running some analysis, we find out that people which are younger than 50 years old, they are not selected to develop diabetes. They are selected just around 30% of let's say with success. So, but on the other hand, we have another group, people over 50 years old. They unfortunately develop diabetes over 70%, let's say. So in this case, even though we said, well, this is normal as people grow older, they might develop diabetes. However, there are other features to consider. There are other characteristics. And this model is unfair because maybe some person who is, I don't know, athletic or very healthy, however, they are I don't know, 60 years old, and the model will most probably will tell them that they are that they will develop diabetes because age maybe is a feature more relevant, let's say, for this model. Well, we need to find out some balance to reduce the gap, reduce this huge difference between groups. Okay, so in this case, age is the characteristic, and this is what we can find by using some, let's say, open source packages. In this case, we are using Fairlane, which was mentioned in the previous presentation, right? And well, this package also by using Azure Machine Learning, we have a dashboard, fairness dashboard, which can get us, let's say, the same information with this dashboard. So I will just go through. I select the characteristic. I select what how we measure the performance. So let's say we are considering the recall, and we select some, let's say, error rate, a demographic parity difference. So we can observe that we get these two groups, 50 or younger, they are selected 30% of the time, over 50, around 60 or 70% of the time. So we have detected fairness and how we can mitigate it. Okay, so we can mitigate it by applying some algorithms and also some constraints or restrictions. So we have algorithms like exponential gradient or grid search or even threshold optimizer, the idea is to minimize the difference between groups. And the constraint is what we want to, let's say, what is what we want to measure, what we want to reduce. In this case, it can be the false positive rate parity or true positive rate parity, and so. So, well, we again apply FairLearn. We generate actually different models, and at the end we will produce, or we will find out, well, according to your constraint, according to some specific algorithm, these are the models. And the best, let's say, models will be found here, where the metric is the highest, let's say closer to 1, and the difference between the groups is small. So, well, we don't have in this quadrant, let's say that, but it's up to us. Okay, what we want to use, either groups with the best recall, so maybe we can select one group from here, or groups with reduced difference among groups, among the characteristics. So, for example, here, let's say we selected one of these models, right, from the low part, and you can see that the difference between 50 or younger people and over 50 is now just 5-6%. So the model is more fair than it was before. Of course, maybe the recall is reduced, but again, it's about finding some balance. So, well, we can, I know that we are short of time, so the idea is to consider the other principles. Transparency refers to the fact that, okay, the machine learning model should not be seen as just magic. We need to explain why some decision was made, what characteristics were considered as most important, like, okay, if you are requesting some loan, okay, the decision, okay, it was accepted because of your income or because of your age, or on the other hand, it was rejected because you were asking for too much. Okay, so yes, it's about finding that, and there are open source packages to explain that. Okay, there is not so much time, so I can share this presentation also later, so you can find why some decisions were made. There is also reliability.
Hey, Luis, just so you know,
yes.
You can keep going. Our next speaker isn't here, so if you have more to dive into, we are absolutely here to listen to it.
Okay, thank you very much. Thank you very much. And feel free to interrupt me or let me know when I should stop. So, okay, I'm glad. So let's see this example about transparency. So, okay, I'm right. Yeah, it's here. Okay, yes. So we have, again, transparency. The idea is that we want to explain our machine learning models, why some decision was made. And well, we are using now Azure ML Explain model, this package. We can use it in our workspace. So the idea is, okay, we create or produce some model. Again, we are using a diabetes data set. Then, why some person was let's say, detected that they will develop diabetes because of some feature or some data. There are two ways to explain decisions. One is global level and also particular level. So the global level, of course, is about the model. In general, the decisions or these characteristics are more relevant. They are more important for, let's say, the results. So there is explain global method, right, that we can use in our training data. So it will find patterns, it will determine which characteristics, for example, in this case, it associates that pregnancies, the number of pregnancies is the most relevant feature for this model. So this one tells or explains why the person develops diabetes. In second level is age, then body mass index, and so. And we can also see, let's say, more or less the contribution in the final result. And we can also, of course, present it with some nice chart. However, then what if we want to know for a specific individual why the decision was made? Because maybe it doesn't agree at all with the global feature, with the global explanation. Then in this case, we have methods explain local, which of course takes a single element, single value, and we can observe, okay, for this individual, for this observation, this person was detected as non-diabetic. Why? Because of the serum insulin level, because of age in second part, and also some other characteristics. So yes, this was the prediction, non-diabetic, and with this, let's say, value 0.33, because in this case, the values are between 0 and 1. 0, non-diabetic, 1, diabetic, so the result was 0.33, which is close, of course, to the class non-diabetic. So yeah, that was, let's say, the final result, and also the corresponding prediction level. Then we might have the same example, but what happens with the other class? Well, support for diabetic, then we see pregnancies, plasma glucose, but the result is the 0.33, but negative. So of course means that this is non-diabetic. So yeah, we can explain or we can justify why the model made some decision. And of course, it's not only about accepting what the AI says, but also considering, or okay, does it make sense? Or actually, our model needs to be fine-tuned or improved, or we need to train it more, maybe, right? So yeah, that's the idea about explaining, and it's not just a black box. Then, well, yeah, for demos, this is all. Then the rest is just talking a bit about reliability. So the idea is that the models are not, let's say, stable. They should be dynamic. They should consider new data. I remember that, well, you might find some famous data sets, like the Boston one, which is about house living. However, that data, I think, is around is from the 70s or 80s, and somehow it was also detected that the data had some bias across some social levels. So, well, the idea is that we need to use new data, even when the model is in production. The new data, the predictions can be part of new training to improve the level. But we can also ask some questions, right, about the data set. Is the training data considering different groups, and more on that on the next part? Do we need to modify the data to avoid or mitigate bias? Then, did we select just one algorithm, or did we test several of them? Shall we include some constraints, some different arguments, parameters? We can use AutoML. I remember there was a really nice presentation. Hello, yes?
We appreciate you going for so long, and we wish we had time to ask you questions, but could you wrap up in about 2 minutes?
Yes, of course. Okay, so we also have inclusiveness and also accountability. Accountability is related with what we had earlier. Like, okay, there is the automatic car that make decisions. If there is an accident, who is held responsible for these decisions? And also inclusiveness is a bit related with the previous one. So the model should consider, for example, if we are talking about face recognition, they should consider different groups, and in order to avoid some problems, or that some person is not recognized at all. So, well, There are some recommendations which are in according to what we presented. So we need to display contextual information. We need to explain about our models, reduce the bias, explain why the system made some decision correct. The model is not always fine. We need to, of course, improve it, and also encourage feedback. And of course, this will give a lot of benefits. So, well, that's all from me. Thank you very much. If you have any questions, I will do my best to try to answer them.
Awesome. Thank you so much, Luis. We had an absolute blast listening to your presentation. Unfortunately, we don't have time for questions, but hang around in the chat. Maybe we'll have a couple in the audience ask questions. Thank you.
Definitely. So it was a pleasure. Enjoy the rest of the event. Thank you.
Yes, thank you.
Thank you.
Hello and welcome back to the Global AI Student Conference, and we're ready to welcome our next speaker, who'll be doing a talk on data science and AI in Africa, the impact of communities. And with that, let's welcome Frank Felix to the stage. Hello, Frank. How's it going? I think you're on mute right now. We can't hear you. We're not getting a buzzing sound. Oh, it's gone. It's back.
Again.
I think the buzzing is still going, yes.
Can you hear me?
Yes, we can hear you.
Thank you very much.
Awesome. Well, we're super glad to have you on the Global AI Student Conference, and feel free to just kick it right off with your talk.
Thank you so much. Let me see if I can share my slides.
We can't see your screen yet on our end. While we're waiting quickly for to be able to share a screen, we've got our Cloud Skills Challenge. If you want to join a challenge, learn more about AI on Microsoft Learn, you can join the link at aka.ms/learn-challenge. And in addition to our Cloud Skills Challenge, you can also earn your very own learning badger at aka.ms/gai-badger. And the learning badger is the cutest thing in the world because you get your very own NFT of a learning badger, and you can collect a whole wealth of NFTs. I personally have an AI ambassador badger, which is super cute, and so does my colleague Futina. She has an AI ambassador, as well as many other as well. That will check back in with Frank Felix. How's it going on your end with being able to share your screen?
Thank you very much. Can you see my screen?
Yes, we can see your screen.
So I'll start right off with the presentation. So I'll be talking about data science and artificial intelligence in Africa and the impact of communities. So a little bit about me before I start the presentation. I'm Frank Felix, a data scientist and machine learning engineer who is interested in the growth of artificial intelligence in Nigeria and Africa at large. I'm very interested in the growth of communities and how communities can impact Africa. I'm currently in my penultimate year studying computer science at the University of Benin in Nigeria, and I serve as deputy team lead for DSN AI Plus Uniben, which is a data science and artificial intelligence community in the University of Benin here in Nigeria. I'm also active with different tech communities, including the Data Community Africa, the Google Developers Club, and the Nigerian Computer Society. as well as the Microsoft Learn student community. And you can connect with me on Twitter as Frank Felix AI and LinkedIn as Frank Felix Felix. So let's dive right into the session. So why is this topic very important? So in this session, I will be using it to explore the state of data science and artificial intelligence in Africa and see how different communities are affected this growth. We'll also talk about how data science has impacted Africa. I'll use the opportunity to reach out to different Africans in the data science ecosystem, hence creating more awareness for the niche amongst communities. I'll also use this opportunity to reach out to the rest of the world and raise awareness for the potential of Africa and the importance of its inclusion in research and in representation. So let's get started. So in recent times, data science and artificial intelligence is growing drastically within the African communities. And this is an effect of the continuous impact of different communities within Africa. So in this session, we'll explore how the study of data science, machine learning, and artificial intelligence has grown over the years, and how different communities has made efforts to improve the state of data science and artificial intelligence. So majorly in this session, I'll be talking about 5 major communities that has helped to push the data science and artificial intelligence narrative in Africa. So I'll be making reference to the Data Scientist Network, the Data Community Africa, the Microsoft Learn Student Ambassadorship Community, Deep Learning in Daba, and Zindi Africa. So let's talk about Data Scientist Network. So Data Scientist Network, formerly known as Data Science Nigeria, is Sub-Saharan African leading artificial intelligence technology, committed to building artificial intelligence talents across the African ecosystem, and is committed to building solutions for governance, education, health, retail, and finance. So what are the goals of Data Scientist Network? So Data Scientist Network is committed to building and raising 1 million artificial intelligence talents in Africa. Data Scientist Network is committed to preparing Africa for the future of work while developing cutting-edge products in the emerging market. So as we proceed, as the world goes, tech is changing every day, and Data Science Network is committed to helping data scientists across Africa prepare for the future of work. So Data Scientist Network is also committed in building and activating digital transformation for organizations in Africa, and also committed to accelerate intelligence startups in Africa. So these are one of the wonderful things DSN, or Data Scientist Network, has planned to do in Africa. And these are some of the ways that they're trying to make impact. So let's talk about how Data Scientist Network plans to make some of this impact. So Data Scientist Network has gone ahead to set up different communities across Africa with campus communities. So one of those communities that Data Scientist Network has set up at campus communities. The African demography is majorly dominated by students, and campus communities are very, very important to ensure that the growth of data science and artificial intelligence in Africa is great. So Data Scientist Network has also set up communities in the cities to ensure that data scientists in different municipalities in Africa also grow. So we know that in data science or the tech space is majorly dominated by men, and different efforts are made by different communities to close the gap. So this is what the Data Scientist Network is doing with the community Ladies in AI. So the Data Scientist Network is trying to close that gap and ensure that data scientists who are in the ecosystem, female data scientists in the data ecosystem, get help growing in the space. So Data Scientist Network is not only committed to building students or experts. Data Scientist Network is also committed to building children and getting them excited about data science and artificial intelligence. So Data Scientist Network has communities for children and teenagers to get them excited. That's African children and African teenagers to get them excited about the opportunities in data science and artificial intelligence. Also, Data Scientist Network has gone ahead to set up communities in schools, also communities for AI professionals, communities for AI executives, and one of the important ones is the community for AI researchers. So research is a very important part of data science, and Data Scientist Network has gone ahead to set up communities to foster the growth of research in Africa and also for startups. So one of the things that Data Scientist Network is committed to doing is to improve learning within the data science ecosystem in Africa. So here are some statistics of how data science has impacted learning in Africa in 2022. So with Data Scientist Network, over 78 communities across Africa are able to get over 3 million artificial intelligence starter ebooks to help data scientists in Africa scale, with over 6 hours of face-to-face free classes for data science and machine learning across Africa, and having about 708,000 YouTube views for learning content put on YouTube. With all of this, data scientists are able to help data scientists, African data scientists, scale up and learn data science better. So another of the communities of Community Africa, Data Community Africa are the host of Data Fest Africa, and they held their first major event in October 2022. So Data Fest Africa was organized by the Data Community Africa and is an annual gathering of data professionals ranging from data analysts, data scientists, data engineers, AI specialists, and ML engineers from different sub-niches in the data ecosystem. So Data Fest Africa 2022, like I said, was hosted by the Data Community Africa. And the community all started from social media. So it was just a community of people interested in data science and artificial intelligence and data analytics, and decided to come together to form a community and held an event in October 2022. And this is the attendance report. You can see from this that a lot of the participants in the Data Fest Africa 2022 were actually from Data Scientist Network, which shows that these communities are working together hand in hand to push the narrative of data science in Africa. We can see here that there's a lot of the gap between their male counterparts and the female counterpart in data ecosystem isn't as large, because this is the Data Community Africa made efforts to make sure that a lot of female are included in their plans to make impacts for data scientists in Africa. So we had a total of 1,772 participants, and we had about 51 speakers who came to speak. That's experts who came to speak to the participants at Data Fest Africa. So these are some of the things that the Data Community Africa is doing to impact learning in Africa. So what are the things that the Data Community Africa is doing to help data scientists in Africa grow? So the community is creating an ecosystem to help data scientists to learn and to share ideas. Data Community Africa is also connecting industry experts to mentees for accelerated development. Data Community Africa also helps with collaboration from different organizations like Propel to help participants in the data ecosystem land jobs. And the Data Community Africa is also committed to helping data scientists in Africa grow with learning. So they collaborate with different learning platforms like DataCamp for accelerated learning. So right there, let's look at another community that is helping data scientists in Africa grow. That's the Microsoft Learn Students Ambassadorship Community. So Microsoft Learn Student Ambassadorship Community is a community for students who want to use tech to solve real-world problems, like-minded peers, and establish themselves as mentors and leaders in their community to amplify their impact. So this community is majorly for students who are looking forward to use technology to solve problems and build impact. So the bedrock of the Microsoft Learn Student Ambassadorship Community is Microsoft Learn, and this is one of those one of the learning platforms you can use to learn data science and artificial intelligence in Africa. The Microsoft Learn Student Ambassadorship Community has a great community in Africa, has a lot of ambassadors from Africa. Let's look at the statistics here. This is taken from the Cargo survey data, and when I did an analysis, I noticed that about 65% of data scientists in Africa are students, which means that a lot of data scientists in Africa are students, and it's important that efforts are made by these different communities to help students to scale and improve the state of data science and artificial intelligence in Africa. So this is what the Microsoft Learn Student Ambassadorship Community stands for. Also, from the cargo survey data, we noticed that online courses have played a big role in helping data scientists start off in data science. This is because as a beginner starting out in data science, structured learning platforms such as Microsoft Learn tend to help beginners learn data science better because they are more structured and they are self-paced, which is very comfortable for beginners in data space. Like I said, one of the examples of those online courses that you can use to learn data science in Africa is the Microsoft Learn. So let's talk about Microsoft Learn. Microsoft Learn is a platform that provides resources and learning paths and modules to learn different tech skills in the ecosystem. Microsoft provided different resources such as learning paths and modules to help you scale as a student, as a professional in the ecosystem. And Microsoft Learn provides a structure for you to learn data science with over 264 modules and learning paths while exploring Microsoft technologies. Use of Learn is very easy. When you get to if you follow this link, you get to see where you can learn skills with data science and artificial intelligence. And there are few for you to pick out courses, started as beginners or intermediates or experts in the ecosystem. So go ahead to explore a lot of all these resources put together for you by Microsoft. So another community that we want to talk about here is the Zindi community. Zindi holds the largest community of data scientists working to solve real-world present challenges using machine learning and artificial intelligence. So Zindi connects data scientists with organizations and provide a place to learn, to own your skill, to find a job. And Zindi also wants to transform the African continent and showcase African data science talents to the world. So Zindi is a data science community majorly for Africans, but different other data scientists from the world also can use Zindi, but Zindi was designed to solve problems for Africans and the African ecosystem. So there are three major ways you can scale and grow with Zindi. So with Zindi, you can study, join discussions, and participate in hackathons to help you scale in the data ecosystem in Africa. So with that feature, you can start your journey to master skills with real-world problems and get various study resources to help you scale. You can also practice, earn money, and build your reputation with Zindi. So with Zindi, you can join competitions and earn money, and at the same time build your knowledge base. So the higher you go with your ranking and how well you do with this competition and hackathons is how well your reputation will grow as a data scientist. So all of this is put out, and people can see how good you are with your data science skills. So with Zindi also, you can find a job and you can grow your professional network. So there are a lot of data scientists. There are over 40,000 data scientists on Zindi, and you can partner with them. You can find other data scientists, and you can learn, grow, and build network with Zindi, and hopefully transform the state of data science and artificial intelligence in Africa. So competitive data science is one of the best ways you can grow your skills in data science. Competitive data science is one of the best features you have on Zindi. So on Zindi, you can see a lot of competitions and hackathons you can participate in. Competitive data science gives you ways you can gain experience working with data and also benefit as well at the same time. So with Zindi, you can gain experience with real life data and see how some of the skills you have learned with data science can impact the world. So competitive data science is also a great way for Africans to accelerate their learning and at the same time gain experience. Another great feature you have for Zindi is the Zindi ambassadorship and professionals. So a Zindi ambassador plays a critical role in creating awareness and social involvement at grassroots levels for Zindi. So being ambassador is a volunteering position. And here are some of the things that Zindia ambassadors do to impact Africa and the growth of data science in Africa. So Zindia ambassadors promote speaking and engagement. Also, data scientists on Zindi help to encourage other data scientists to join Zindi and help the state of data science in Africa and grow the community in Africa. The ambassadors on Zindi also help to run hackathons, meetups, and events, training events that support the data science community in city and countries in Africa. Also, Zindi ambassadors helps to connect Zindi with potential partners, data sets, and commission hosts in their country and in their city. Also, Zindi ambassadors help to provide feedback and support to ensure Zindi continues to improve and better serve data scientists in Africa. So the Zindi ambassadorship program is open to students and professionals in the African ecosystem. So one of the communities that we're going to talk about too is deep learning in Daba. Deep learning in Daba is an annual meetup for African machine learning. The annual meetup for African machine learning communities with a mission to strengthen Africa's machine learning. So in 2018, deep learning in Daba introduced in Daba X. So in Daba X was introduced as a way to experiment with the ways in which we can strengthen our machine learning community and to allow more people to contribute to the conversation. As in Daba X, it's locally organized in different locations across Africa, and it helps to develop knowledge and capacity in machine learning and artificial intelligence of individuals in countries across Africa. So one of the ways in which the Indaba, deep learning Indaba impacts Africa is with the Indaba mentorship program. So there are a lot of benefits that comes with the Indaba mentorship program. And the mentorship programs help students and connect experts to mentees and help them grow. So some of the mentorship sessions include helping students translate research ideas into experiments. The Indaba mentorship program helps students write research papers, also helps them to improve their skills in writing research proposals. It helps them to improve their skill in preparing a CV, helps them improve their skills in preparing a presentation or a poster, also helps them in applying for, learning how to apply for undergraduate and postgraduate studies, helps them apply for academic or industrial job interviews, which are very important for data. Also help them prepare for academic interviews and industry interviews. Also very important, the
Hey there, Frank.
Indaba mentorship program helps
Hey there, Frank. You've
helps
got
them build.
only a couple minutes left on your presentation, just so you know.
No problem. So the Indaba mentorship program also helps them plan a career in data science. So it's probably the most important part of this portion. So in the session, you will notice that a lot of these communities are working hand in hand to ensure that the narrative of data science and artificial intelligence in Africa is pushed. So you can see how these different communities work together. Like for data scientist network, work together with the Data Committee Africa to ensure that all of these students get learning resources. The data scientist network also work with other data science communities to ensure that these participants and members in these communities get access to mentors, get access to internships, and all of those. So if you notice, a lot of these communities, or one thing that connects all of these communities together, is that they create special packages for students and to help students grow. So which means that they have students in mind, and the future of AI adoption in Africa lies in the hands of students. So what can you do as students to ensure that you scale and grow in data science. So one of the ways is to leverage communities for growth. So all of these communities that we have mentioned, data scientist network, the data community Africa, the Indaba community, the Zindi community, and likes of those. So leverage them for your growth. Also, you leverage social media for your growth. Put yourself out there. Let the world see what you are doing with all of these communities as you engage and can scale up from there. Also, you have to leverage free learning resources to scale up in the data ecosystem. And one of the resources that you can leverage is a Microsoft Learn platform. So with Microsoft Learn, you can learn a lot of skills in data science, artificial intelligence, and machine learning. Also, you should leverage competitive data science because competitive data science is one of the ways that you can show your skills and gain experience with data science apart from getting job roles. Thank you very much. My name is Felix from Felix, and welcome to a solution-driven Africa with artificial intelligence. Thank you so much.
And thank you so much for joining us today. So we don't have any time for questions, so we're going to our next session in a few minutes. Hello all and welcome back to the Global AI Student Conference. Our next session is about machine learning at Green Tech by Nicolas Chavez, a Microsoft Learn student ambassador.
Hi, can you hear me? Yeah.
Hi,
Yes.
we can hear
Okay.
you.
First of all, thank you for the invitation to be here. I'm really excited, and let's try to learn more about the importance of AI in the greening tech topic. So thank you. So I'm gonna share my screen. Can you see it?
Yes, we can.
Okay, so thank you so much for this opportunity. My name is Nicolas Chavez. I'm from Mexico, specifically for Mexico City. Today we are going to talk about the predict solar energy usage with a machine learning designer with Azure, obviously. This was an amazing project we made in the student ambassador program. And my team was called EcoWatch, big one with sustainability, and was an amazing project. We only had 3 months to develop it, and of course share with all the community. And at the end of that 3 months, we won the best workshop development project. So was an amazing experience, and that was the reason we had decided to share it with all the community, right? So for this agenda, we are talking about the project details, the GitHub repo, because it's important to us to share all the progress we did it. And of course, if you have feedback or maybe you want to collaborate, it's open it to do it. And of course, we are going to do a quick review about the project, right? So this is our team. Andrew Chan, he is from Hong Kong. Jigaksa Gupta, she is from India. I'm Nicolas Chavez, obviously me. I'm from Mexico, right? So first of all, I really like to introduce the topic green tech. And of course, for this topic, it's important to establish some points, like maybe we live in a fastest world. We need to deploy and most of the time consume all the technology, and maybe it's fast more than our capability to do it. So most of the time we have maybe we have this situation, right? You have one new cell phone for this year, but maybe the next year you you are going to change your phone, and that causes that we have a lot of waste, or maybe trash, technology trash, and that impact in the carbon footprint that we have in all the world. So it's important to have a good practices in the way that we develop the projects or software in general. We need to try to cover all the technology that we all already exist, and try to not be that try to not be part of the problem. Like maybe your software just works in the latest cell phone, right? No, maybe the best way to have a good impact in the world could be maybe you can support your software for older devices, right? So yeah, first we are going to talk about the project details. Our purpose is when we developed this project was encourage people to use renewable energy in their homes, because this is an most common problem. You know what is a solar panel, and maybe it's important to you. Maybe you can find the way that you can put some panels in your home or your neighborhood, and with that you can save money and of course be friendly with the world, right? So this is a typical and common problem here in Latin America, because we have a lot of space, and most of the time in our countries we have the sun. So maybe it could be a good way to improve or consume, and of course be friendly with the world. So how? Through Azure Machine Learning Designer, we decided to implement a predict model that allows users to visualize the production of solar energy in their area, and thus show the benefits of installing solar panels in their home. And with this, we can have a positive impact, right? So how does it look? So first of all, when you are working with machine learning, you need to have a data set. You need to prepare that information. So first of all, the thing we did was search or looking for some data set with variables like solar energy production, maybe the wind, temperature, latitude, altitude, and with that information, we have an data set with clean information, and of course, that information could be used with a trained model, right? And for what kind of model we can use it, uh, we part of these variables that we know. So it's important to, with these variables, try to answer a question, right? So linear regression model, it's the best way to do it with this kind of information. So so for the data preparation, we use the how can I Jupyter notebooks and with pandas. So for that, we have the spreadsheet data, and we decided to use it with pandas. And with this, you can charge the weather data with wind spent, radiation, temperature, and other measurements to have an best prediction. All right. So it's important, if you have information, it's very important to have a bunch of information. So for the data preparation, the first step is importing the data. And with that, we can see this important graphic that, for example, for the solar generation in Germany, that's the data set we can found it and try it to use or try it. Yeah. So as you can see in the maybe in the summer season in Germany, they have a lot of solar energy generation. But in the other way, the wind generation is very low in the summer season. So with that, we can think, or maybe in the summer season, it's important to have a solar panels, and maybe for the wind season or winter season, sorry, we can just be focused in that um, energy generation with wind. So with this information, the second step is merge the data frames, all the data frames that we can be able to do it. And with this, you can see we match maybe the date with the wind generation and the solar generation, and we have a better data set of information. So with all of these steps, the next step is to introduce it in Azure Machine Learning Designer. We decided to use Azure Machine Learning Designer because it's an option without code and it's very visual for us, because I am a chemical engineering, so I don't have the background, or maybe not the best background to use maybe AI solutions or AI implementations. So for us, it's very important to do it very friendly, and maybe the people can use it and of course collaborate it with us. So for all of this, we have the GitHub repo. It's a workshop, as you can see. So we have all the information that we try to bring it to you, and what is our goal with this workshop, right? So you can consult it in this link, or if you search in GitHub, Nico McAfee user, it's my username, and you can see the workshop development project Green Tech repo. So this is an invitation to all the people to join hands with sustainability and deploy solutions with AI and machine learning to be more friendly with the world, and try to try to be a better person with your footprint, and be conscious about it. So as you can see, it's important to have the Azure Machine Learning Designer, because that allows us to implement a solution without complex code, and the linear regression, because it's user satisfaction from the data. So we are going to check it now. I'm gonna put this. This is the GitHub repo. As you can see, this is the project goal, the pre-learning path. It's important to know a little bit about AI with Azure Machine Learning Designer. You have all the links here to be part of this project. What is our goals for this workshop? The pre-learning part, it's important for us to, you really need to know about pandas for data science, introduction for Python, and an Azure account. And with every milestone, we have a specific goals. First of all, it's important to know about the Azure Machine Learning and the regression models. We have all the information here. And the second milestone, we have a briefly introduction to sustainability with machine learning. This is an amazing graphic that was designed by an Microsoft employee, as far as I remember. And we can check all the information here. And because as you can see, the JAMA explained the sustainability, and it was so fun. So the milestone 3, it's about getting the data set. As I mentioned it before, we search the best data set for this purpose, and we found it in German, the government energy sustainable data sets. And we just we just merge the information and create this project, right? So this is the data processing with the pandas, and of course the milestone 5 create this model. So at the end of the day, you can have your own model in your account, Azure account, and you can test it with your information of your house. And with this, you can see if your house is able to use solar energy or wind energy. So yeah, this is the way that we can collaborate with you and try to invite you to use it, the renewable energy in your home, right? So for the quick review of the project, first of all, you need to have an Azure account, like me, and of course you need to create a resource. The machine learning. Let me check. And in the marketplace, you just search Azure machine learning. You put in the create and resource group. You create a new one, like a test AI, no, something like that. Oh, sorry. Test AI. The workspace name, wherever you want. In the region, it's important that you put all the regions around all the projects in the same, like this. Maybe all our projects we're going to be in East USA, and that's because this is the nearest region to me. So review and create. Yeah, create. And with this, as you can see, the portal notifies you that the deployment is in progress, and maybe this could take a little minutes, a little time. So we don't have a problem because we are wizards, and this is the television, so we have the magic of the television, right? So for this part, you need to go to the machine learning portal. So this is important in your browser. You can type ML Azure and click on it, Microsoft Azure Machine Learning Studio. And now you have access to the Azure Machine Learning Studio, right? So once you have signed it, this is the page you are going to see. It's important in the right part up. It's important to check if you are in the correct directory, the correct subscription, and of course the correct workspace, right? So for this occasion, I had one prepared before the Global AI Conference workspace, so it's here. And now, you know, it's this interface. It's very friendly with with all of us, and especially with the people that we don't have maybe a data science background, right? So for the next step, it's important to identify this left part, you know, the bar settings or something like that, and click on the compute. and create a new one, a compute instance, and you can put all the name that you want. Maybe AI test. You put it in CPU, standard ES11, create, and maybe this can take maybe a few minutes. So for this part, it's okay. And now a computer cluster, you know, in the same region, location, in the same region, ES, US, in my case, dedicated CPU, standard, and computer name, computer cluster, right? Cluster test. A minimum of number of nodes, 0, number maximum, 1, and create. Okay. But this can take a little time. So for that reason, I have one created before. So yeah, as you can see, this is the same properties, so that doesn't change. And now with all these steps, the next step is going to the designer. This part with no code and maybe better use with just the design. And now you are going to create a new one and a new designer. So for that, it's important to upload the dataset, right? So before in the repo, you can check the information. You can check the dataset before and after the merge. So you can download it from here and upload it to your to your project. So for this part, maybe dataset, machine learning, energy. What kind of information? Tabular. From local files. Next. Azure Blob Storage, that's okay. Upload file. I uploaded the file. Remember, this file is in the repo, so don't worry about it. This is a data preview with all the columns. Yeah, we can check it, the dataset if you want it. If you want, just give me a second. That's okay. So this is the columns, the structure of the dataset. You know, the time, the date, the wind generation, the solar energy generation, latitude, velocity of the wind, temperature, pressure, all these variables that are going to be important for our project or a prediction model, sorry. So yeah, next, all the columns are included. Yeah. The quick review and create. Yeah, so it's here, the dataset ML energy. And now it's important to, in this part, you need to, or you have the opportunity to just select all the steps, and it's explained it in the repo. And you know, this is very visual. You just need to connect like Legos or something like that. It's very friendly, right? Yeah, but you know, I don't have the time to do it here. That's what is the reason I just designed it before. And here is the result. You know, the data set, the select columns in the data set. This is the parameters, which columns are important to select it. You know, all the information are in the repo. you need to normalize the data with transformation method min-max, true, the same columns that you selected before, split the data with 0.7 in this part, include the linear regression model, and of course connected with the train model, with the data set, and with this you just need to select which information are important to you in this moment. In this case, it's solar generation. It's this model. Connect and scholar model. It's important. You can find all of these blocks of steps, these components in here. You just need to type it, score model, and here is the score model, right? And you just put it on the platform, and you just connect it, and that's all. Evaluate the model, and that's all. And after you did you connected this, you need to submit it, create a new experiment, and click on a name. In this case, I'm gonna put just numbers. Display name, renewable energy. Oh, well, we are going to put it the same, renewable energy, 55, submit it. These are going to take a long time because it for this lab or this designer, it's important to test all the steps. So if they found a problem, it's important to notice and of course stop all the pipeline, and you need to review it. But in this case, this works well. Okay, trust me, I know what I'm doing. So once you have submitted this part, and of course, let's check the status for the jobs. So after you submit it, you are going to visit. You are going to do this, right? First, find the assets part, the jobs part, and as you can see, we have a renewable energy 555, and at this moment are completed. But after you have that part, let me check if we can visit it. Yeah, it's completed. And now we need to create a real inference pipeline. And once you have created, you are going to have a result similar like this. You need to connect on the service input and with the dataset, with the renewable energy, the score model, the service web service output, the evaluate model, and now you just need to submit it and create an after you have submitted. This is the final part. You just need to click on deploy, and now you are going to have a real-time endpoint. And with this, you can connect it with API or maybe with another service, web service, and you can you just need to send the information, right? The test information, maybe your own data from your home with the solar energy or wind energy generated. So this is the final part, and this is how does it looks, the test. And in this part, you just need to change it with your variables, with your data, as I said it before. And yeah, that's all. All these steps, I'm sorry for the time, but you can check it on the repo. That is the reason I just did a quick review. So yeah, that's all for my part today.
much, Nicholas, for an amazing talk. I think like 2 points is, first of all, I think it is extremely cool that as a chemical engineer, you're able to use Microsoft Azure to implement these low code solutions. I think like making it like technology like accessible to everyone is just super awesome, and you're doing great work with it as well.
Yeah, it and Microsoft Student Ambassador Program was an amazing opportunity to me to improve myself and, of course, collaborate with students around the world. Most of the time, I just study chemical, but maybe an AI could be another way to improve my skills.
You definitely should. This sounds like an amazing intersection of skills. And even like another point from your talk is it was super cool to see Nitya Narasimhan's green tech visual as well. Like I remember when she made that a couple years ago. So seeing it still being super impactful for the green tech community is also very awesome.
Thank you so much for the opportunity. And I'm gonna be very excited for the next year, maybe, and with another project.
That would be amazing. But before that, we absolutely want you back next year. But we have 2 questions for you. The first is, how did you first learn about Microsoft Azure Machine Learning Studio?
I am a very curious person. So one day I just visit the the Microsoft Learning platform, and I found that it was possible to use machine learning without this background of the data science. And for me was, okay, I'm gonna try it. And yeah, that was my way to discover that.
I think that curiosity is super awesome. And then we have one final question for you. And what do you think are other applications outside of solar panels you would like to test with?
As I told you, maybe the wind generation, maybe with water. This it could be another opportunity. Maybe with potatoes sounds an crazy way to do energy, and maybe could be possible. Or with oil, maybe some combustible or gas. Yeah, with oil, vegetable oil.
I think all of those applications are amazing, and I'm personally hoping that you bring one of those as your talk for our next year's Global AI Student Conference. So thank you so much for joining us, Nicholas, and I think we're ready to pivot to our next speaker. So welcome back to the Global AI Student Conference, and we have our next speaker is Matt Elland, who is an instructor at Tech Elevator. They will be giving a talk on automating my dog with Azure Cognitive Services. And it'll be a video that I'll play in just a moment.
Hello, Global AI Student Conference. I am Matt Eland, or at IntegerMan on Twitter, and this is Automating My Dog with Azure Cognitive Services. So in order to speak here, you have to either be a student or a teacher, and it turns out I'm actually both. I teach software engineering professionally at Tech Elevator, and I'm also a Master's in Science and Data Analytics student at Franklin University. In addition to these things, I speak frequently in my communities and tend to talk a lot about Azure Machine Learning, Azure Cognitive Services, artificial intelligence, data science, and ordinary .NET development. So these are kind of my topics of interest. So Azure Cognitive Services is really interesting to me because it's kind of this intersection of my two worlds. So it's software engineering with C# and .NET, and it's also data science and artificial intelligence, and being able to use all of these pre-built APIs that Microsoft has given us to do all these data science tasks without having to train a machine learning model, get deep into data science and things like that. So Azure Cognitive Services is really this sort of a suite of AI as a service offerings where you can say like, hey, I really need something to process images and classify images and detect objects in this, or I really need something to generate speech from text, or understand the sentiment of text. and you pay basically by the usage of how many API calls you make without having to get a master's degree in data science. So very, very fancy stuff. I like it a lot. And so I decided to talk about it in my community. And whenever I'm giving a talk, I like to have kind of a fun spin to things. So I thought, what's the strangest way I could give a talk that would still be informational? And I came up with, well, thinking about my dog. So this is Jester the Cairn Terrier, and he is a wonderful dog. He's a very good boy. He's also a very loud boy. Okay, so he he does a lot of things out there in the world. And I said, it'd be nice if I could relieve him of some of his responsibilities. If I could find a system that could go out there and look for animals for him out the window and bark at those animals if it sees them, and listening to commands and recognizing words and identifying the spoken commands. And I thought about it and I thought, well, wait a minute, Azure Cognitive Services can actually do all of these things. So wouldn't it be fun to give a talk about how I could make my dog's life easier by automating some of his more mundane tasks, such as looking out the window and barking at rabbits? And yes, this is absolutely ridiculous talk, but that's kind of the point. We want to use some humor and whimsy to talk about some really interesting things. So I'm going to demo to you a solution that involves Azure Cognitive Services. And we're going to talk about entity recognition, sentiment analysis, language understanding, computer vision, text-to-speech, speech-to-text, and other considerations, right? So we're going to tie all of this together with .NET code written in C#, and we're going to see how this can tell kind of a coherent story and build an application that's, A, ridiculous, but B, could legitimately be used to automate my dog's core tasks, if only he would listen. So let's take a look at the application, and I'll come back and kind of walk you through its code.
Hello there.
All right, so here we are in the app, and the first thing you'll notice is it talked to me using text-to-speech. So let's have it look at some pictures. So first, I will show it a picture of me back when I was a developer. And it finds a bunch of things in that picture. And if I have Jester take a look at that picture, the results of that.
Nothing to bark at, but here's some things I saw. A man sitting at a desk with a computer and a chair, monitor, person, indoor, clothing.
And it actually tells us a lot about that image. Now, if I show him another picture, such as a squirrel sitting on a peg, I get a different set, and it finds a bunch of different things, and Jester has a different opinion because it saw an animal.
I saw a squirrel eating a nut. Bark, bark, bark.
So that is essentially the image recognition capabilities. So let's take a look at the listening to commands. Do you want to go on a walk? And it was able to determine that I said, do you want to go on a walk? And it analyzed the sentiment and key phrases, and it mapped it to an intent, we'll talk about later. And it says,
why, yes, Jester does want to go on a walk.
Now, I could also say something different, such as, are you a good boy? And it interpreted it differently.
Jester is a good doggo.
So that's the app. It works pretty well. Let's talk about how it works.
Goodbye, friend.
All right, let's talk a little bit about how this works. So in order to make any of this possible, you need an Azure Cognitive Services instance on your Azure account. Okay? So if you don't have an Azure account, you can always go out and create a free one, which is free for a year or so. You get a number of free credits for the first month, and then some persistently free things for the next 12 months, and then persistent free things after that. But in order to do anything with Azure Cognitive Services, you need to go in and search for a Cognitive Services instance and go ahead and create that. Now, you'll need to tell it a resource group that it belongs to. You also need to tell it what region it needs to be in. Okay, this is usually going to be something close to you and your users. Finally, you give it a name and you choose a pricing tier. You tell it to create, and it goes ahead and creates it. So once you have that, you now can go in and find the endpoints and keys for this. So these are secure keys that you can use to access your Azure Cognitive Services instance from your .NET code. So keep these things secure. I would recommend not checking these things into source control, but rather putting them into your application configuration files, storing them in Key Vault, something like that. And just not having them inside a Git or whatever you're using for source control. But you can grab the key out of this using the keys and endpoints pane in the Azure Azure, and you can also grab the endpoint as well. Now, once you do that, now we can start to get into the code and how this works. So the application I created was in .NET. So inside of Visual Studio, I went in and I added references to all the various services I was going to use inside of Azure Cognitive Services. There's no one library that you're going to use to add a NuGet package for. Instead, it's very piecemeal. You're going to say, oh, I need speech, I need language, I need computer vision, I need all these things. And so you're going to kind of only include what you need. Right? So you go to NuGet Package Manager, you go in there and you just select the things that you want, and it installs them for you, and you're great. Okay. Now, next thing we do, let's talk about how the various features work, starting with text-to-speech, because really it's the simplest. With text-to-speech, you are creating a speech config object. So the speech config object, it has your Azure Cognitive Services key, and it also has the region name for that's the region that you deploy your Cognitive Services instance to. Next, you tell it what voice to use. I chose Guy Neural. This is a neural voice, which is a little bit more believable and realistic than a non-neural voice. And Microsoft is creating more and more neural voices all the time for various locales throughout the world. So check the full list of those out. They're pretty awesome. And then the next thing I do is I'm creating a speech synthesizer and I'm awaiting its speak text async. And this is actually going to go out there and it's going to find my default speakers and it's going to pipe the output of that through my speakers. So this is actually all the code I need to make my application speak to the user. Now, if you don't want to be doing this all the time, you could actually go out there, call this method, and save the result to a WAV file, and then you can go in and you can play it later on in your application. So you might be paying only once to generate that file. But if you need to say something dynamic, that's not as much of an option. But if it's always the same thing every time, you can just save it to a file and you'll be fine. Okay, so that's speech synthesis or text to speech. Now, speech to text is fairly similar, but a little bit more code. So with speech recognition or speech to text, we create a speech recognizer. We give it the same speech config, but we don't necessarily need to specify the voice this time around. But we are telling it the key in the Azure region. And then we're calling recognizer recognize once async. There's also ways of recognizing things in a stream and the like, but those get a lot more complex. So recognize once async is very smart. It listens on your default microphone and it waits for you to stop talking. Now, if your microphone's not on or you're muted or whatever it might be, it's just going to give you back a, hey, I didn't recognize anything, a no match result. But normally you're going to get a recognized speech and you'll be able to get access to the result.txt. So this works remarkably well, at least in quiet environments. I've not tested this thoroughly in active environments like cafes and the like. I've not had a lot of different people test it with their voices, but I assume, I'm actually very confident that Microsoft has as well. So speech recognition, there's a little bit to it, but there's not much to it. It's really fairly simple and it works pretty well. Now, computer vision is a lot more complex because there's a lot of aspects to computer vision. It depends on what you care about. Now, first thing you might want to do is you need to do is you need to actually go out there and you need to basically load your image. So in this code here, I am loading the image from a file. I'm loading it into an image stream, and then I'm calling a computer vision client analyze image in stream async. And I'm telling it what features I care about. This is the tasks I want it to conduct. So the image analysis in Azure Cognitive Services, it's really one endpoint that you call to do a whole lot of different analysis results. Now, each one of those things you're paying for. So if you really only need, let's say, the description of your image, just tell it that's all I care about. But you can use the same endpoint to get all sorts of different pieces of information about your image if your application needs them. So in this case, I'm asking for the categories, the description, the image type, the tags, and any objects inside the image. Now, once I've done that, I have this image analysis result, and I can look at the results of that. So here, I can take a look at the captions that are present on this image. And so it's going to give me basically an auto-generated caption as to what is in my image, which is pretty neat. I'm also able to take a look at the tags and categories present in an image. Right? So I can loop over all the tags and the categories applied to the image, and I can display the confidence level that Azure had that each one was present. And that will tell you a lot about what's in the image. In particular, the tags API is really, really helpful for that. The categories are more broad, like nature and things like that, but the tags can say, I think this is an eastern tree squirrel with a 86% probability. It's pretty interesting. Object detection. Object detection is a big one. So with object detection, you're actually getting not just what's in my image, but where it is. It gives you a rectangle for the things it was able to notice. And so you can look at these rectangles by getting at the object rectangle. It gives you this bounding rect, and you can look at the x and y and the width and height, and you can kind of get a sense for where in your image something is. Right? So that's really, really handy if you want to understand, what is actually in your image and where is it in your image. So not just what's in my image, but where is it in my image. Okay? So all of this, it winds up with this output that we saw earlier in the demo. But there's a lot we can do with image analysis, and it all really flows through that one endpoint. So it's super convenient. I really love it. Text analysis is a little bit different. So it has multiple endpoints. So the very first one you might want to do would be language detection. This says, hey, what language is the text in? Is it in English? Is it in something else? And in order to do this, you need to create a text analytics client. It's like, hey, here's my cognitive services key. Here's the endpoint I want you to call out to. Remember, get your key and your endpoint from the keys and endpoints blade in the Azure portal. And these are secure things, particularly your Azure Cognitive Services key. So if somebody else has that, they can use it to make calls and have you pay for it. So you don't want to share that or check it into source control, especially if you're just doing open source development. Okay, so the next thing you're doing is you're going out and you're saying like, hey, I want to detect the language. I can even give it a hint as to what country I'm in if I want to, if I think most of my users are going to be in the same country. And then it's going to loop over all the languages it detects. So pretty cool. Key phrase detection is basically kind of a summarization sort of API. So you can loop over that. You can say, hey, I want to get my key phrases asynchronously. Here's the language that I believe this is in. Here's the text. And it goes out and it gives you all the key phrases it finds. So very good for reducing large periods of text to just key bullet points. Entity recognition lets you find named people, places, events, things like that in periods of text. So you can take a look at this and it can scan and highlight the key players in a passage of text. So really good for automated analysis of documents and things like that. Sentiment analysis, you'll see this applied a lot to social media. If you want to find out if the sentiment or someone's happy, sad, angry, whatever it might be, it will give you a value ranging from 1 to -1, with 1 meaning I'm super happy and -1 meaning I'm pretty mad right now, and 0 meaning about neutral sentiment. Okay? So you can use this to determine like how do people feel about your products and brands and things like that if you wanted to. So very common case for text analysis. So again, we see values outputting like this. It says, hey, I found English in this. The key phrases were cognitive services. I found these entities and that kind of thing. So very cool. Now, this last one, the last thing that powered this application is something called language understanding, or Lewis or Luis. I hear different pronunciations for that. Before we get into this, I do want to say that this is more of a deprecated aspect of Azure. The sequel to this is conversational language understanding, or CLUE, which I will be writing about actually later on this week. So take a look at that on accessibleai.dev if you want to see the differences between CLUE and Lewis, but they're very, very similar. It's just CLUE is the newer way of doing this, but they both work exactly the same, just different areas of Azure. So both work off of something called an intent. An intent is basically a command your application supports. My application supports responding to the phrase good boy and responding to the phrase walk. Right? It understands those things. It also has handling for the none intent. So you said something I don't recognize, I don't understand. So these are kind of the 3 things that the application can respond to: good boy, walk, and none. Now, the user is not saying those things. The user is saying something else. The thing that the user says is called an utterance. So we map each individual utterance to a specific intent. So I might have multiple utterances that go to the same intent. For example, do you want to go on a walk? And hey, what do you think about a walk right now? Or you want to go on a stroll? Those all map to the walk intent, right? So we can put in user utterances to train our application inside of Lewis or Clue, and it's going to say, oh, okay, I understand that this utterance goes to that intent. You're telling it what it does, and then you train it to recognize that. And when the user types in something new or says something new that your application has never seen before, it says, how similar is it to this other thing over here? I think it's pretty similar to some of the utterances for this walk intent, or I'm going to map it to that one. And over time, you find yourself adding more utterances to Lewis or Clue to help, it respond to the things that users are saying to your application or the different grammar they're using, things like that. Okay. So the code for this, for Lewis, is pretty simple. For Clue, last time I checked, it's not, which is why that's a separate article. But Lewis, you are actually creating a new Azure API key service client credentials like we had before, giving it your Azure Cognitive Services key. And then you're creating a runtime client, Lewis runtime client. You're telling it what endpoint to use, and then you are giving it the GUID of your Lewis applications. It's something you find in the Lewis portal, right? And you're telling it whether to use the staging or portal environment, or sorry, staging or production environment. Now, once you have that down, you are going to then go in and try to map the user's utterance to an intent. So now we're actually going out, we're calling out to Lewis, we're saying like, hey, here's my message, I want to get a response. So we said, here's my request, give me my prediction asynchronously. And we get back our prediction response. Now, looking at that, we can actually go in and see, oh, okay, well, here is the result of that. Here's my most likely prediction, and here's all the other intents that it tried to map to and the confidence of each one. So this is going to tell you not only the top intent, but it's also going to tell you the other ones it considered and how likely they were. So you can take this result and you can say like, hey, the top intent was walk, but I also matched onto these other things with a certain degree of confidence. So this lets you really build a chatbot or a conversational AI solution without having to do a whole lot of data science. I just recently wrote an article on ML.net and how that was actually pretty complex to map utterances to intents manually. So Azure Cognitive Services gives us a nice and friendly way without having to do a whole lot of data science under the hood. So in conclusion, we did a lot of things. We were able to automate a lot of capabilities. We were able to detect objects of interest with computer vision and identify whether or not they had things worth barking at. We were able to respond to certain occurrences using text-to-speech that made Jester bark, or the equivalent of barking in this example. And we were also able to understand human speech and sentiment using the speech-to-text and text analysis and Lewis or Clue APIs. So all told, Azure Cognitive Services let us build an application without having to do a whole lot of complex code. So it lets you take a new application or build an existing application and build them up and add on new capabilities to respond to users in more intelligent ways. You can think about this application, all the other things I might add to it, such as translation, speaker recognition, facial API, so Jester could recognize me. There's a lot of things we could do with this. I could train a custom vision model to identify individual toys that Jester has, for example. This stuff's really cool. It's really a lot of fun to work with. I encourage you to play around with it. If you'd like to take a look at my code, you can go out to mattelan.dev/doggo, and that'll give you a bunch of resources related to this talk, as well as a link to my GitHub, which is also pictured here if you want to go out and take a look at that repository. Now, one note, this application won't work out of the box because I don't have my Azure Cognitive Services keys and other things checked in for reasons I've been referencing during this talk. If you'd like to learn more about this application or other things we can do with cognitive services, data science in general, check out a few of my resources such as accessibleai.dev or my YouTube channel. I'd be happy to tell you more on Twitter, LinkedIn as well if you wanted to reach out to me. Microsoft also has some really fantastic stuff on Microsoft Learn. They got a lot of learning paths. There's also the AI 900 Azure AI Fundamentals certification, which is a great one to study for. It takes about a week to study for and pass, and it never expires. And if you're a little bit more serious about it, you might go into the Azure AI Engineer certification, which focuses heavily on Azure Cognitive Services. So thank you for listening. Thank you for the Global AI Student Conference for having me, and I hope you enjoyed this and learned something new.
So we are back at the Global AI Student Conference. Unfortunately, Matt cannot join us online, so we cannot ask him some questions. But after watching his season, I have to admit that I just want to go home and see how to use Azure Cognitive Services to automate my cat. Now, before introducing our next speaker, I want to remind you that we have a Cloud Seed challenge about Azure AI. You can go to the challenge and complete all the learn modules and see how can you compete to your friends and people from around the world using our leaderboard. You can also claim a unique learner badge that is provided to you. You can go to the website, scan the QR code, and claim your unique NFT in your wallet. So we will be back in a few minutes with our next speaker. Hi again, and welcome back to the Global AI Student Conference. In our next season, we'll talk about the 4 types of machine learning. And let's welcome Frank Lavin, a data and AI architect at Microsoft, and MSDNS columnist, a blogger, and a podcaster. Hi, Frank.
You might be on mute right now, Frank, but we love your background. It's super cool.
Oh, thank you. Thank you very much. I may have a problem collecting monitors.
No, that's a good problem to have.
Indeed it is. Indeed it is. So I just want to update I didn't update the bio. I actually now work at Red Hat. So that's why I had little fedora back there. And, and I'm excited to talk about the 4 types of machine learning and some of the innovations that have been happening in this space.
Yeah, thank you. So before going to your presentation, would you like to tell us about your podcasts and your blog?
Yeah, sure. So my podcast is called Data Driven, and we've been online now about 6-7 years, and we have about 315 episodes. I co-host it with my good friend Andy Leonard, and he's the data engineer, I'm the data scientist, so we kind of cover the whole spectrum of what the data world consists of.
I absolutely love that. I feel like now I'm super interested in that podcast. And also, I just love your background again with the Red Hat specifically.
Well,
and then
thank you.
Now, so when I get home, I'll definitely be listening to the Data Driven podcast. Would you like to tell us a little bit about your blog as well?
Sure. So I run a blog called franksworld.com. And fun fact, I started Frank's World in 1995, and it's been online in one form or the other since then. So my oldest child is going to be 13 this week. It's kind of, I think of Frank's World as kind of my first child.
That's absolutely amazing. I mean, what an accomplishment to have, especially for our students listening into the audience at the very beginning of their careers. Like, if they want to be you in a couple decades, they want to start writing their blogs posts now. So I think that is super impressive. With that, we'll let you kick off with your presentation.
Awesome. Thank you very much. All right. So hopefully, I guess I have to share my screen.
Yes.
All right. I will share my screen. So many monitors, it's always hard to know which screen to share. All right, so hopefully you can see my screen, and my name is Frank Lavinia, and we're going to talk about the 4 types of machine learning. And as I mentioned before, you can catch me, I am now at Red Hat, so there's a little fedora, but you can check me out at Frank Digs Data on social media. I'm there on Twitter and Instagram, datadriven.tv and franksworld.com. We did mention the Data Science Podcast, and I forgot to mention that we're just above 250,000 downloads. All right, so I'm going to talk now about the 4 types of machine learning, right? There's supervised, unsupervised, reinforcement, and transfer learning. But of course, this is a field that waits for no one. There's more. And this is a fast-moving field, and if you're a student in this field, this is both an exciting and an intimidating time to be in this industry, because you could be up to date on all the latest innovations, and then 20 minutes later, not so much. So it definitely helps to have an innate sense of curiosity. But what's really cool about this is kind of what's changing in this category. But for the most part, I like to think of this as solution categories, right? What are you really what's the problem you're trying to solve? And honestly, in my career, the technology is cool, but ultimately what makes the what pays the bills, as it were, or what keeps me going is the problems I solve for customers, right? I like to solve problems. That's kind of that innate engineer in me. And it's one of those things. Now, you'll notice on none of those slides, I mentioned neural networks. And neural networks are a fascinating kind of look at the innovation that has happened in this space. When I first started in this, there were really only one, maybe two different types of neural networks. You just kind of put everything into various layers, and there were different types of layers. But now there's all sorts of neural network architectures. And let me turn it over to my virtual co-host here to speak really to the fast-moving nature of this field. So surely by now you've heard of ChatGPT. OpenAI is backed in large part by Microsoft and other industry leaders. But what's fascinating about this is how good this is. How many types of machine learning are there? So what's interesting is, and I have a screenshot capture just in case this goes wrong, but basically, well, this is funny. This is a completely different answer than before, which is very fascinating to kind of play around with this tool. Ultimately, it told me that there were 4 different types of machine learning, but it didn't quite match up with my list, which goes to show you kind of just how silly this industry could be sometimes, because they'll want to categorize things, right? That's kind of a human nature. And there's a lot of buzzwords in this field, right? Business analyst, data analyst, problem, solution, organization, right? But you know what? It's late in the day, at least where I am. Let's talk cake, because everybody likes cake. All right, so let's explore this analogy, because there's really kind of a way of looking at this field. Now, these are the 4 categories I've come up with, but for the most part, let's think about it in terms of cake, right? So the cake itself is unsupervised learning. In order to get anything to work, you need large amounts of data, right? Just massive amount of quantity of data, right? Not necessarily quality in that sense, right? So you'll have to, basically what you do is you just get enough data, and eventually you start clustering it, graphing it, and clusters will start to form, and then you'll get an idea of how these things get categorized. Secondly, and this is the one that most people really start with, is this supervised learning. And that's really the icing on the cake, so to speak. And that's really was the idea that you have data, but you also have it labeled. So in other words, you know that if given a particular record, you know that this person survived the Titanic, right? Or this person did not, right? That's labeled data. So you know what the ground truth is. So that way you can go through and the algorithm can sort through it and find the patterns in the data that you can't see quite so easily. All right. Reinforcement learning requires even less samples, in some cases even no samples at all. And this is the idea, and we'll talk more about this later. That's kind of the cherry on top. Now, finally, the candle is transfer learning, which basically you start with a pre-trained model and then you add another layer on top to kind of explain what it is. A great example of this is the Azure Custom Vision Service, which I believe my previous presenter had referenced. And it is a pre-trained computer vision model that you just add an extra layer, right? So an example of, this is a cat, this is a dog, and you don't have to explain all of the fundamentals of computer vision or train it from the get-go. Now, this is actually becoming more and more increasingly important. A lot of these language models require a lot of GPU and CPU effort to go, GPT-3 being one of them. But what you do is you could basically start from that pre-trained model and then work from there. So you can really kind of build on an existing foundation. Now, let's talk about that, right? So given a picture set of cats and dogs, what does this look like, right? Well, supervised learning is, you tell the computer which photos contain a cat and which ones contain a dog, right? And then given enough samples, it will it will be able to kind of reverse engineer the differences between cats and dogs. Unsupervised learning is you just give it pictures of cats and dogs, and you find some kind of property or multiple properties, and eventually the patterns will start emerging and they'll start clustering around that. Reinforcement learning is the idea that you show it a picture of a dog, and it will take a guess, is it a dog or a cat, and then you give it a point. You reward the computer for right answers or punish it for wrong answers. Basically, you give it a point. Congratulations, 10 points. You got you picked the dog. Minus 10 if you chose a cat when it was actually a picture of a dog, vice versa. And transfer learning. Let's hold that thought for transfer learning. Now, which one of these is the hunted and which one of these is the hunter? Well, chances are, if you're just starting your career, you're younger than I am, and I'm not even old enough to have ever seen dinosaurs in person. But however, we know through movies like Jurassic Park and whatnot, but we also know, even if we hadn't seen those movies, that the animal with the big sharp teeth is probably the predator, right, or the hunter. And the hunted is the light, small thing that is running as fast as it can, right? That's an example of transfer learning that has been arguably built into our, fused into our DNA since time immemorial, right? So the idea that you can kind of start with an existing model that you have and then work off of that. And that is essentially transfer learning. Now, transfer learning, like I said, leverages these pre-trained models. The pros are minimal training. Cons are you still need a base model to start from, and but ultimately that's it in a nutshell. So one of the things that you'll find that's going to be very useful in your career is the ability to summarize things in an elevator pitch, because you never know who you're going to be stuck with for a finite period of time. So it's always good to get used to the idea of relaying complex topics in a very short kind of way, right? Supervised learning, you know the answers already, the rules are inferred. Unsupervised, well, you don't know the answers, but eventually a pattern emerges. Reinforcement learning is you figure out the answer through trial and error, right? It's very similar to how animals learn. Transfer learning, you rely on previous knowledge and previous answers. And basically, models trained on one task are repurposed to a second related task. Now, at one point, you're probably wondering, like, hey, why would you do anything if you already knew the answers, right? Now, if you're a software engineer, chances are you're not a career software engineer like I used to be. But ultimately, here's the paradigm shift that's going to be very crucial and a different way of thinking that comes with artificial intelligence and machine learning. Now, in traditional development, what happens is you get the data, and then you program in the rules, and then answers are then computed. What machine learning does is kind of invert this a little bit, because you give it the answers and you give it the data, and then the rules are inferred, right? The computer will go through using a series of algorithms to go through and interpret what the rules are of any of your of what you're trying to figure out. So for instance, when I did work at Microsoft, I had one of my customers was they made candy, right? They made licorice, right? And there was this huge stack of notebook rules that the food scientists had crafted over decades, right? Basically, how to mix the chocolate in. I mean, how to mix the chocolate in, how to mix the flavoring, the sugar, all that sort of thing. And they would be able to optimize the output of the candy, and they wanted to basically have the maximum output of candy for minimum input of ingredients. Now I've already mentioned cake. I mentioned candy. Could it be that I'm hungry? Who knows? But that's not the point. The point is that what they were able to do, a team of consultants was able to go and reverse engineer the rules by monitoring the data of what went into the machine and what came out of the machine. And they were able to, within, I would say, probably a matter of weeks, be able to reverse engineer all the information that took decades for this company to kind of collate and put on paper. So that just shows you the power of this and what this can do. Now, supervised learning, can really be it's not really about the tools that you use to solve it. It's really that you have the answers ahead of time. That's really what it's about. The pros are it's very specific. The cons is that this could be very labor intensive, and labeling data turns out to be, well, quite the booming industry in terms of what you'll have is getting the quality of data out there. So while the data engineering or data scientists get the headlines, it's the data engineers are really the unsung heroes of this field, right? So you'll hear a news story saying, hey, XYZ3 model came out and it was trained on 15 billion parameters or this much data. Now think about the amount of labor that had to go into label that data, organize that data, sort that data so you can get it processed through and create a model out of. So that's really kind of the cons of it, because not all data is going to come naturally labeled. Now let's talk about decision boundaries. So what you're seeing here is just a graph, and it represents two classes of things, right? The circles and the triangles, right? And this is a linear classification is what we're doing here. It's a linear or binary classification. Linear because we just draw a straight line defining what is this and versus what is that. Binary because, well, there's really only two classifications. And with that, let's do an experiment with a neural network that I am certain everyone here within the sound of my voice has, and that's your brain, right? So let's do an experiment now. Because this is remote, I can't do this like I normally do in person, but ultimately I'm going to show you pictures of dogs, pictures of cats, and you're going to tell me which is which, right? Should be easy enough. All right. So what's this? All right. There's really no interactive feature here, but if you said dog, congratulations, you are correct. All right. Next picture. What is this? All right. It's a cat. Yes. All right. So now you're 2 for 2. What could be behind slide number 3? What is this?
Oh no. I'm gonna go for cat.
All right, we have 1 vote for cat. Now, this is an interesting use case. So most of the time, people will say dog. I happen to know the ground truth because it's labeled data. And the only people that have ever gotten it right was, one, I spoke at my son's school, and one of the students in the class, her mom was a veterinarian, right? So that child guessed correctly that it was a cat, like you did. And another person that I spoke at a user group here in the DC area had formerly been a veterinary technician. So I find that interesting that they were able to tell, and apparently the tell, as it were, are in the eyes. So that gets you kind of this idea of what the decision boundary is, because ultimately what you're doing is you're mapping qualities. You're doing this in your head. You don't realize it. Like, that's just how good nature is gotten at this. And the distance from the decision boundary matters. So what that is really a fancy way of saying is something you probably learned in middle school, right? Is this linear regression, right? That y equals mx plus p. This is not rocket science per se. But this is a way to kind of see how this goes. Now, I want to show you another real-world example of how a decision boundary, and local, at least to me. So using 2 American football teams, this has been a crazy year for me. I changed jobs. I sold my old house. I bought a new house. So I'm actually much closer to Baltimore now than I used to be. So basically, there's 2 major American football teams in this area. And one of the things I noticed when we were house hunting was that there's kind of this idea when we were house hunting like 15 years ago. I noticed that different stores, different gas stations, supermarkets, you name it, would have different material based on where we were looking for homes. And there's basically Baltimore has the Ravens, the Washington's team is now called the Commanders or Commandos. And basically, can we kind of see what our decision boundary looks in real life? So when we are house hunting, I noticed a distinct pattern here. And this pattern has actually shifted over the years as the Baltimore team has done way better than the Washington team. but there still is a clear line here. So I've actually noticed that the decision boundary, again, this is a linear classification problem. It's a little more nuanced than that in the real world, but come on, for a demo, for a simple example, this is it. So ultimately, you'll see that a couple of things here. You'll notice that, hey, Frank, you drew a line, but the line kind of leaves this point out and this point out as well. Yes, that's right, because you're never going to get, anytime you have a model, there's going to be some level of what's called true, false positives or false negatives, right? So in this case, this would be considered a false, if I were given a lat long coordinates, if it was north and west of that line, I would assume that it would be Baltimore. If it's south of that line, I would assume it would be DC. Obviously, this would be a false negative or false positive based on that. So ultimately, what you're going to find is that there's always this line, and this is really more art than science, of how good is your model, and can you model overfit? And if I were to draw this line in such a way that I could bend this around, then that would really be an overfitted model, because the short of it is to say that predicting the future is hard, right? And for fun fact, that this would be not, instead of a mathematical distribution, this would be the line if you are north and east of Route 32, State Route in Maryland, or if you're north of Interstate 70, that's basically the borderline. Although I have noticed that as the season goes on and things go better for Baltimore than Washington, that line has creeped south a bit. But again, why so Euclidean, right? It turns out that when we're dealing with these mathematical models, we're not really dealing with reality, right? So in that example, I'm dealing with a map, so there is some kind of correlation between reality. But one of the true powers of data science and advanced analytics is you can compare things in more than one dimension. In fact, in some cases, some problems I've been on is that we were comparing different aspects of, classification A or B across hundreds of dimensions. Now, that's something that really melts your brain. But if you think about this, is that if you can imagine what's the shortest path between 2 points, well, it's a straight line. Well, if you view the world in kind of 2 dimensions, in that case, the middle diagram here would be the straight line. However, as you add more dimensions, that short line can get shorter. And ultimately, to paraphrase a line from The Matrix, which I guess to students of today, this is an old movie. It's not so. If the quote in this goes, the child actor here says it way more eloquently than I can, but ultimately, it's not so much that the spoon bends, but your mind bends. So let's revisit this concept in terms of a binary linear classifier. Can you draw a straight line through this? So before I said you're never going to overfit a model, and I'm saying like you're always going to have some kind of thing. Now I'm basically saying the opposite, right? Just as a thought experiment, could you draw a straight line to isolate the red circles from the yellow circles? And the answer is you can't, right? Now, what if indeed we were to add more dimensions to the problem? So let's try it now. Animation should kick off. Now you can draw a straight line that would cut through that very evenly. So hopefully this is your reaction. And again, another kind of movie reference, you're not thinking fourth dimensionally, from one of the Back to the Future films, is basically what you're doing is creating a hyperplane, which is the 3-dimensional cousin of a line or a straight linear classifier. And basically, by adding more dimensions, by getting more data or more facets of data, you can actually increase your accuracy. You can also introduce a lot more noise, a lot more bias, but that is a topic for another presentation. All right, so don't feel bad if you're not confused. You're not paying attention. Confusion is part of this. This is very kind of esoteric kind of things that normally we don't encounter in our day-to-day lives, but this is becoming more and more of a thing. So what I'm going to talk about now is unsupervised learning. Like, what does this look like? Well, basically, the big algorithm here is basically around clustering, right? The canonical example is iris species, where you can based on the length of the pedal to the width of the pedal, it will produce, and you'll see that you can kind of cluster. You'll notice that eventually things start to cluster around certain patterns. Now, the good thing is that there's really no labor. You just get the data. The cons are there's really no control over the data quality per se, and there's no context, right? You don't know like what you know. Like in this chart here, all you see is that, hey, there's a big green cluster here. What does that mean? There's a big red cluster here. What does that mean, right? So this is where the analysis, the human analysis part of it really matters. Now, I'm going to talk about something that I've really gotten fascinated by of late, and this is called reinforcement learning. And this is the idea that computers can learn by trial and error. Now, what you do to create this is generally a simulated environment, and that sounds really fancy, but Super Mario Brothers could be considered a simulated environment in this situation. Another aspect of this is using synthetic data or simulated data. And you're probably like, why would I want to use synthetic or simulated data? Well, it turns out in some cases, simulated or synthetic data is far superior than real data, which sounds really crazy when you think about it. But one of the things that I want to point out here is that when you're building a reinforcement learning system, careful thought has to go into what you're rewarding the agent for or the bot and what you're punishing it for, because you can really wind up with some really bizarre unintended consequences. So synthetic data is the example of how do you train a self-driving car? Well, one way would be to have all the sensors or whatnot loaded up on a machine and just let it go and see what happens, right? One of the things that's really been crucial to the development of autonomous vehicles is the idea of synthetic data, right? Plenty of game engines exist that can produce a photorealistic world in real time, and ultimately, no one gets hurt, right? So if you see videos of this, the first thing the car does is it goes forward, it hits something, right? Well, then that loses its life, it gets penalized, then eventually it learns over thousands, if not millions of iterations, how to safely drive. Now, one of the interesting use cases here is you could train across different scenarios. You can control the variables in a simulation, right? You can control the amount of weather, the amount of traffic, the road conditions. Are there potholes? Are there trees down on the road? Like, how would you handle that? So synthetic data in very real, particularly in reinforcement learning, turns out to be very good. I would also say it also works out pretty well in terms of computer vision problems, right? Because one example I'll give is to say you wanted to recognize a truck. All right. Well, what type of truck? Okay. Well, we'll narrow it down to let's say a tractor trailer, right? You can teach a computer vision model, but a computer vision model is only as good as the data that it learns on, right? Like all AI models. But what if you wanted to know, well, what about foggy at sunset, right? How would your model perform? Well, you don't really know unless you get a picture, multiple pictures of multiple angles of a semi-truck, and in that type of environment. But what you could do is you could basically use a game engine and a script to calculate tens of thousands of variations of a photo of a truck in different lighting conditions, weather conditions, you name it, damage, missing headlight, et cetera, et cetera, et cetera. Now, the advantage of that is if you write the script properly, and chances are you will, you automatically have the data labeled. Now, there's been numerous research information posted about this. I think Microsoft Research recently published that their AI, they're basically using a game engine generating faces, is just as accurate, even though it never saw a real human face until the testing phase. It was just as accurate. Now, that's good because you can really script through a variety of types of faces, so you don't have that any kind of implicit bias in it, you can automatically script that so you can run through every conceivable variation. Now, the next thing I like to point out is that incentives drive behavior. I don't know if you've ever been to Costco on a Saturday afternoon in the United States, but it looks something like this. So the fascinating thing about all of this, and I see that I'm a little short on time, so I'm going to skip ahead a couple of slides, but ultimately, this is really kind of the the aha moment I think a lot of people had about this. So AlphaGo took 3 days, and to beat the best human player. This is AlphaGo 0, so it had no human intervention in terms of the data that it was trained on. It was basically learning by example, learning by playing the game. And this is the power of reinforcement learning. This could play in 40 days millions of lifetimes worth of Go, right? So the fact that we can do this on a computer and the fact that we can do this in such a way is really a good example, I think, of really what the future looks like for this field. So again, I'm going to mention I work for Red Hat, so I want to show you, hopefully, I will show you. Give me 1 second. That is the wrong window. This is what happens when you have too many monitors. And if you have any questions, feel free to queue them up, and I'm happy to answer them. And all right. Hang on. All right, so I'm going to restart that. Hopefully the server will finally kick off. So this is Red Hat OpenShift Data Science, all the data science tools you like, but it's in a Kubernetes container, containerized, and can run on anyone's cloud, yours, Microsoft's, or anyone else's. And while I wait for that to start, I will hopefully show you this while the kernel is starting. All right, so reinforcement learning basically works like this. You have an environment, simulated or real, and you have an agent, aka your bot. And this bot will examine the state of the environment, and then it'll take an action. And then based on that action, it will update the state. The environment changes based on the action that it took. And then based on how that works, it will do a reward. So in the event that this demo does not work, I have a backup plan, and my backup plan is to show you the cached output, which is the true beauty of Jupyter Notebooks. So this is known as the multi-armed bandit problem. I recently gave this presentation at a talk in Las Vegas. And ultimately, it's about figuring out which one of these machines will pay out the most. Right? So slot machines themselves are called one-armed bandits because they take your money. Multi-armed bandit problem is basically a bank of slot machines. So what I'm going to do is, this is all in Python, so I'm going to just basically create a simulated environment. I'm going to say I create a bank of 5 slot machines, randomly pick their payout odds, and this is what the ground truth is, right? And the ground truth is that first slot machine 0, pays out at 54%, 27%, 42%, 84%, and 0.4%, which of course, these are not realistic odds. As I like to say, if you find a bank of slot machines that pays out this well, call me. But this is what the agent knows at first. It doesn't know anything about the environment. So I'm setting up the rest of the simulation of playing a machine. And I know I'm close on time, so I want to kind of go through that quickly. I'm creating this environment. I'm creating this. I'm going to run this simulation, say 10 times, and I'm going to just do a test, right? Because you can always test the environment. You want to make sure the simulation is as close to reality as possible. And you'll see that on slot machine 4 with the 84% chance of winning, I win 9 times out of 10, which is close enough to 84%. And on machine 5, where the odds are very low, I lose every time. Fun fact, I did run this 1,000 times, and the math does check out. So this is one of the algorithms inside of epsilon, inside of reinforcement learning, is the idea of epsilon greedy. And it's basically the paradox of, do you explore or do you exploit? And what this means for slot machines is, do you sit at the same machine that you know will pay out and keep playing the machine in the hopes that you have a guaranteed winner? Or do you, every once in a while, do you look around and try another machine in the hopes that it will do better, right? A lot of this is built on game theory. So what I built here was this multi-armed bandit solution, and there's this notion of epsilon 10. So epsilon 10 is the idea that I'm going to explore 10% of the times, 10% of the times I pull the lever on the slot machine. Well, wait, 10% of the time I'm going to go try a new slot machine, right? And running through this, this is the actual odds, and this is the odds that my bot has learned. That's with a 10% being curious and exploratory. Now I'm going to start with not doing this at all. And I don't know how it is in the rest of the world, but there are definitely casinos I've been to in the US and in parts of Europe where there's always somebody playing the same machine for hours at a time. And, you know, so this, by setting that value to 0, I'm simulating that, right? It's never going to try another machine. And I want to point out right here that the total reward is 4830. And the reward for being 10% curious is 7,800. Hold on to that thought. I also, because I never played anything but the first machine, there was no learning, basically. So now I'm going to go completely the opposite. I'm going to be curious. I'm never going to play the same machine twice in a row. Now, what you'll see here is that, well, I did a much better job of learning kind of the lay of the land, although it does tend to be rather pessimistic on the payout odds on the slot machine, the fifth one, number 4. But that's interesting. So basically, this got me wondering, what if I ran a hyperparameter sweep? So basically saying in 1/100th increments from 0 to 1 and kind of plot what that score would be. Because you'll see by being completely curious, I really have lost a lot of points here. And ultimately, as you see on this graph, what happens is that the more curious I get, I do see a bump up right around the 10 to 15% point. I do see a serious boost in what my returns would be. But as it gets beyond that, it's a series of diminishing returns. And ultimately, to paraphrase from the movie Wall Street from the 80s, you know, greed is good, but only 10% of the time is ultimately what it is. But this does teach a good lesson on when you're building a reinforcement learning bot, what it's being incentivized upon really matters. And I hear the sound back on. Any questions at this point?
Unfortunately, we do not have any time for questions, Frank, but we appreciate your presentation. Was so engaging. Like, I'm sure late in the evening for you, late in the evening for us, but this presentation was extremely relatable and woke me up, and I'll definitely be asking you some questions after the Global AI Student Conference.
Well, thank you very much. Look me up on LinkedIn or on any of the social medias.
Awesome. Thank you so much, Frank.
Thanks.
Welcome back to the Global AI Student Conference, and we're ready for our next 2 speakers. So our next 2 speakers are Felipe Flores and David Lazaro, and they will be doing a talk on generating out-of-the-world images with Azure and Stable Diffusion. Hello there.
Hello.
Hello, everyone. Can you hear me?
Yeah.
Yes, we can.
Awesome. How are you? Thank you so much for the opportunity of being here today.
How are you both doing?
Awesome. I'm real excited for this kind of workshop and for this kind of talk. What about you, Felipe?
I'm really nervous about this, but it's okay. I'm really excited about this.
Both of you will do absolutely amazing. We're super looking forward to your talk, and feel free to take it away.
Awesome. So do you mind, Felipe, to try to share the screen up and start with the talk?
Felipe, are you going to share the screen? Fabulous. Let us know if you're having any technical difficulties.
Do you have permissions for sharing the screen? If you don't have permissions, don't worry, I can do it. So just let me share my screen already here. So I think you can see it already, right?
Yes, we can see your screen.
Awesome, that is really cool. So welcome everyone. It is really nice to be here on the Global AI Student Conference for our first time. My name is David Lazaro and he is Felipe. So we're going to look at this awesome topic called generate out of the world images with Azure and Stable Diffusion. So this is a really cool topic for everyone. And if you have seen like all these AI generating images and all this stuff around internet, around Twitter, or everyone or everywhere you are, this is really on trend right now. So before that, Big Sad Bell, which is greetings in Mayan. First of all, let's try to introduce ourselves. So my name is David. I'm a beta Microsoft Learning Student Ambassador and a GitHub Campus expert. I don't really know what I'm doing here, but I feel that this is going to be real excited today. I'm a nerd, I'm a gym rat, I'm a machine learning cat. And fun fact, today is my birthday. So it is real nice to be here on my birthday. That cat that you see on the left of my picture is my cat. It is called Cappuccino. And the things around me are Pom Pom Purin and the dog Snoopy. They are like my spirit animals and they're literally me. So do you think you can present yourself, Felipe?
Yeah, sure. Thank you so much. My name is Felipe Flores. I'm a Go and Microsoft Learning Student Ambassador. I'm here just learning, learn exciting stuff, and I'm a gamer, a bookworm. And fun fact, I've never been in the space because just know about the name of the workshop,
Yeah. So let's try to start with this workshop. This is going to be real fun. So have you ever seen these images, like these generated images? They don't look made for a person, and actually they are not generated from a person. They're not edited on Photoshop or anything like that. These images are generated by artificial intelligence, which is really cool, and it is really interesting to know. So let's try to meet the Stable Diffusion. So first of all, what is that? What is a Stable Diffusion? So Stable Diffusion is a text-to-image latent diffusion model created by the researchers and engineers from computer vision, Stability AI, and Lion, which is a cool database. So this basically is a text-to-image latent diffusion model that takes this text and tries, or well, this prompt and tries to generate an image that can represent that text that we are giving the model as a context. So if you see, we have an elegant cat, and we have also a fisherman versus seals, which is really interesting to see. So how this works basically is that all these models are trained on by 512 by 512 images from a subset of the Lion 5B database, which is a really largest and really accessible multimodal dataset that is currently existing, is growing each day, and it is real cool to see this kind of model working right now. So we mentioned about something about diffusion models, but that sounds like really weird, don't you think? So let's try to take a little deep into this topic. So the noise and diffusion probabilistic models, also known as DPMs or diffusion models, score-based generative models, or simply autoencoders, are models or a type of machine learning algorithm that are designed to remove noise, or we basically remove noise and certainly noise from our data. So these models work by using a series of probabilistic calculations to predict the most likely underlying patterns in the data, and then we use these data or this information to clear and clarify our data. So this process helps us to improve the accuracy and reliability of our data that we are using, and thanks to that, it makes a little bit more easier for us or for the algorithm to work and learn from. So basically, in a few words, the noise and diffusion model, probabilistic models, or the DPMs, are like a filter that can help us to clean up and organize messy or noisy data, making it more useful and valuable for us or for further analysis on understanding. So as you can see here, a graphic really simple representation of this, or how it works, is the fixed Fourier diffusion process of how we are reversing all this process from dot pixels and try to bring it to something who doesn't have that kind of noises. So to be honest, this is really complex to understand. There are like thousands of papers, hundreds of papers and articles of a lot of persons working on these the noise diffusion probabilistic models. If you want to, you can take a more deep into this. I encourage you to do it. This is a really interesting topic to take care of. But yeah, you don't need to understand it for this talk. Just imagine that they are mathematical and probabilistic models that give superpowers to the AI. So knowing that, now we're going to talk about the real goat into this workshop or into this talk, which is Hugging Face. But what on the world is Hugging Face? So Hugging Face is a hub, or well, we have two parts, but what we care here on this talk is the Hugging Face hub. So Hugging Face is a platform that allows us to access and to use pre-trained language processing models for a variety of tasks such as text translation, text summarization, and sentiment analysis. So as you can see, we have here Buzz Lightyear watching open source models in Hugging Face, and he says, I could use one of those. So yeah, everyone wants a free and open source AI model, right? So these models are developed by a really huge community all around the world of researchers and developers, and can be easily integrated into applications and systems without the need of extensive programming knowledge. So don't worry about if you don't know anything about AI or how these models work. The thing is that you have access to those models. They are open source. You can try to understand them. And Hugging Face Hubs gives you a lot of tools to find the kind of model you're searching for. If you're looking for models of image classification or translation or natural language processing models for Spanish things or for English, Japanese things, everything is there. Hugging Face is like the Lord of the Rings, one hub to roll them all. And the goal of Hugging Face Hub is to make a state-of-the-art language processing technology accessible to a wider audience and facilitate the development of new innovative language-based applications. So here's a cool example of the latest hackathon on Spanish of the Hugging Face community here on the Hispanic audience here in Latin America and Spain. So here are some cool projects. Those three were the winners of the hackathon. We have gender neutralization, sex detector, and the Mexican juridic model, which is used right now on the juridic model here in Mexico, which is like a really, really cool thing, knowing that governance is using machine learning models to predict juridic models. So, okay, that is Hugging Face, but how are we going to use Stable Diffusion into our talk today or into our workshop? So we're going to use Complete Stable Diffusion model to generate awesome images. So we need to download the model from Hugging Face and do awesome things with that. So that is how Hugging Face is going to help us today. So do you think you can explain a little bit about how we're going to use Azure today, Felipe?
Yeah, but where is Azure? Azure Static Web Apps is something we have to do. Is a service that automatically builds and deploys full stack apps to Azure from a code repository. The workflow of Azure Static Web Apps is tailored to a developer's daily workflow. Apps are built and deployed based off of code change. We have up here the deployment process, and this is just one of the tons of Azure services because there is a lot.
Yeah, so how we're going to build this thing is that this application, for simplicity of the workshop, we're going to develop into an API from Google Colab, or you can, whether you're using Colab or Jupyter Notebooks or Azure Machine Learning Studio, just for the simplicity to make it a little bit quicker and try to understand it a little bit more faster. We're going to use Colab as an API using Python and Fast API. So we're going to have our static web app. He's going to pull information from the API, and the API is going to try to use a GPU, and that GPU is going to train the model. It's going to train the model, try to return us an encoded 64 base image. Right. And we're going to decode that base image into our web app. And that said, also we're using the count-based Stable Diffusion model from Hugging Face, and we're using it from our API. So what do you think if we start and try to see how this is working? So let's try to look at how is this working. So we have here our Jupyter Notebook. So the first thing that we are using today are some things like fast APR, diffusers, transformer, accelerated club code. So all this stuff, you don't need to understand it. Just try to know or try to think that we're importing some libraries that we need to accelerate the process of training this model. We're also asking for a GPU, and we are also using something like Torch or importing some methods that we're going to use. Also, we're using club code, which is a library that helps us to do this. And what I mean with this is to try to use an API right here on our collab code. And with that API, we're just going to pass or to return the encoded image to our static web app. So cool. So here what we're doing is just trying to customize our model, trying to customize everything that we're going to use into our pipeline of the Stable Diffusion pipelines. So we have our model ID, our type of revision that we're going to use, the data type that we're going to use with Torch, and our user authentication token that we extracted from Hugging Face Hub. And also before that, well, after that set, we generate that image and we try to call to that pipe here and to ask the model to generate that image and try to pass all the information that we're receiving as a prompt here. As a parameter, we pass that prompt to the model, and the model starts doing magic and all of this work. So after that, we just run our app, and we have already an URL running here. So thanks to Azure, and because Azure is also integrated with GitHub Actions, we can just deploy whenever we want our page. And right now we have our page running already. So what do you think if we try to prompt something? So I know that some of the club advocates use raccoons, right, as a mascot. So what do you think if we try to see an image of a raccoon drinking milk? So let's try to do it. Let's try to see a raccoon drinking milk. So we're going to generate that image, and if we go to our API, we're receiving that information. We received already that prompt as a raccoon. So we see here that our API is already doing that. It's doing all the process. So it is generating the image, and if everything is okay, we're going to see our raccoon drinking milk. But because this is an early version of a Stable Diffusion, some of the times it's not going to give us what we want, and it is also real difficult to the model to understand a little bit of this, because we need to give here a little bit more information, maybe in a table, or instead of drinking milk, drinking water. In a table, yeah. Water in what?
In a table, yeah.
In a table, water in a table. So let's try to do it. Let's try to give this information. And what you need to understand here is that we're just passing a prompt. That prompt is being passed to the API. So that API is going to pass it to our model, is going to pass to, so yeah. Hey, we have already,
it's really fun.
Yeah, it's really fun. Generating a image with AI is real fun, and it's really easy. You just need to deploy your web application into Azure. It's a few steps. Deploying your application takes just a little bit of seconds, like 2 seconds, and making this API is real fast too. You don't have to understand or to have all your backend already done. But like I said, this is a little bit more. This is for simplicity of the workshop, to be honest. But if you wanted to do like a really web app or something like that, you will need to orchestrate a lot of things like Kubernetes, or try to have a lot of GPUs for if you have a lot of requests for your API. well, it's going to be a lot of process that your API and your GPU that you are using is going to need to process, right? So yeah, this is just for the simplicity of the workshop. So on the real life, it is a little bit more difficult to try to host an application of this kind of way. But yeah, like we see here, we have images, we have already generated AI images. So let's try to go again into our slides. So as we see here, we have already generated our images with stable diffusion. But beyond stable diffusion, there are a lot of more things that we can use, like Dreambot. Dreambot is some of the things that can help with stable diffusion. There are a group of models that help with stable diffusion to generate more, well, to return to us more precise or with a little bit more context of our images. So it is a really cool way for you. If you want, you can search on Google or on Bing Dreambot, and the first page of Dreambot github.io is going to have all the information that you need to try to understand it a little bit more. But yeah, we encourage you to try to look at all this stuff. Also, if you like Arcane, like the new League of Legends series, you have models on Hugging Face, like Arcane Diffusion. If you like Bangkok, you have also a model of images made by Bangkok, like they were painted by Bangkok. If you like anime, you have also a model to generate images from like in an anime way. If you like 3D modeling, you also have that kind of models. Modern Disney, Spider-Verse. Well, I love Spider-Verse. I'm really hyped for the new movie. So yeah, you can generate yourself images with Spider-Verse diffusion, impact diffusion. You have a lot of models. You just have to go there, try to create yourself a Hugging Face account, and start looking at all the models that you have for work from Stable Diffusion. So yeah, that is all for this workshop. We're going to have a giveaway. We have this QR code if you want to scan it. We have a form to fulfill for you. We're going to bring to you to 2 persons of the audience 20 cool images of you. So if you are a winner, we're going to ask you like photos of your face and things like that. And we're going to generate for you 20 images of yourself in a lot of situations and with a lot of models like these ones that you've seen before. So yeah, thank you so much.
Thanks so much for your presentation and happy birthday, David.
Thank you so much.
We have time for some questions. First of all, we have so much fun with the raccoon that you show us. And we would like to know if you have tried the stable diffusion with your cat.
Yeah, I've tried already, and it is real difficult. But yeah, I'm not finished. I want to generate more images, like the Spider-Verse. I want to use different models, like the Spider-Verse model, like the Arcane model, to try to see how will Cappuccino look into that kind of art style.
That is absolutely amazing. Even like I was thinking like Cappuccino the cat. I want your cat like sipping a cappuccino. That would be the coolest picture in the world. But we have another question.
So, have you ever tried any other application for Hugging Face?
Yes, also, actually, I participated on the hackathon that I told you that was like the first hackathon from Hugging Face. It's a community for natural language processing, but that hackathon was the first natural language processing in all Latin America and Spain. So we worked on trying to generate a model that watches videos, and from those videos, well, not all videos, but specific videos, and these videos were like recipe cooking videos. So for example, if you are watching a video of how to make a sandwich, the model will extract like all the information, like all the script of the video, and try to extract all the important words that you will need to use to create that sandwich. For example, oh, okay, you want to make a sandwich, you need bread, you need tomatoes, you need lettuce, and all that stuff. So and after that, that text is going to be, well, was placed on a web page of recipes. So Hugging Face is an awesome hub. I recommend you to look at it. Like you say, it is not only used for making art or for generating images. It's also used today by the government of Mexico in the juridic model. So I encourage you to look at all the important projects that are there.
Even on the note of the juridic model, would you like to talk about that a little more for some of us who might not know a lot about it?
Yeah. So the juridic model here in Mexico is, some weeks ago, I had the opportunity to to talk with the maintainers of that repository, for that repository. And they're using that model to try to search how, for example, let's try to imagine, okay, I was on the subway and I don't know, I was assaulted. They took my phone and they took my bag, and I had important things there. So I want to make a demand, where I want to see what can I do. So I put my my example of what happened to me. Okay, they have a web page, and onto that web page you can see similar cases from yourself and how those cases were taken. So it is real cool that you can see how easy for you is to try to take care of the thing that happened to you on the subway, and how do you say it? Well, to what entities you need to go and how can you proceed with your case. So yeah, it is really interesting how the government of Mexico is using that model.
I think that is extremely interesting. And I think my follow-up question to that is, like, you've done your current work in Hugging Face, and what are both of you excited about for, like, next projects in the AI or in the Hugging space? Hugging Face space.
Do you want to talk about it, Felipe?
Yeah, sure. For example, for me, it's the first time I use this model. It's kind of interesting. I'm using right now for entertainment purposes, just to know how I look in the Disney or Arcane, for example. But later, I want to improve how I can use for models that can help people around my community. For example, there are so many problems that that can be helped with this model, and actually that's the way I'm going to. What about you, David?
Well, now that you say your community, Felipe is from a region of Mexico where it is really popular that they talk a native language called Mayan. So on Hugging Face, or on the hackathon, there were a lot of people trying to create a model for natural language processing on the Mayan language, but it is really hard work of researching a lot of things, because if you look into the internet native languages like Mayan, there's not something really formal that can help you to train your model or to try to understand how the Mayan language works and all the stuff. So I think working with native languages will be an awesome thing for me, and a really exciting and intriguing thing to look at.
That's absolutely fabulous. I'm super excited about both of your next steps on both Hugging Face and in your AI journeys. And I know we have time for like one final question. So I'd love to hear like your closing thoughts or like message to like our student audiences to maybe get them excited about the potential projects they could get involved in.
You want to go, Felipe?
Yeah, sure. First of all, we encourage all the people wants to improve their skills in the AI. It's really interesting the things you can solve. We can handle the problems with AI, and it's just an advice. Just try it. David.
We might have lost David, but that's all right. Well, first of all, finally, happy birthday, David. Thank you so much for spending your day with us. And also, Felipe, thank you so much for joining as well. And I think we're about ready to go to our final session for the Global AI Student Conference, and we'll be back in just a minute.
Hi everyone, and welcome back to the Global AI Student Conference. We have something like 40 minutes until the end of today's conference. So let's welcome our 4 panelists, Kevin, Gabriela, Noah, and Azit. Hi!
Hello everybody, hi.
Hello everybody.
Thank you for joining us. So we'd like to know you better. I'll start with Kevin, who saw you in your presentation. We have some technical difficulties, but we have to say a big thank you for the such informative presentation you gave us about how to build and deploy deep learning models. So we have some students that have just joined the live stream. So could you reintroduce yourself?
Sure. My name is Kevin McFall. I am a master instructor with NVIDIA's Deep Learning Institute. So I teach a lot of workshops all over in terms of deep learning, different technologies. Before I came to NVIDIA, I was a university professor and worked in mechatronics engineering, so did a lot of robotics, computer vision, AI, and deep learning. Interestingly enough, all of my degrees are mechanical engineering, so I sort of backed into AI, but once I found out about it, I couldn't let go. So glad to be here with you all today, and nice to share my experiences with you.
And the final question before going to our next panelist. I saw that you have an amazing international experience. How many countries have you worked, lived, or studied?
Well, I guess the short answer to that is I've lived, worked, or studied in 4 different countries. I'm originally American. A funny thing, though, I never got my first passport until I was 23. So I really didn't do much traveling until later in life. But I've been in Sweden, where I was a student as well as a faculty member. I did my PhD at Georgia Tech's campus in France, where I also taught. I did my master's thesis in Japan, and I now work in Germany with NVIDIA. So it's fun to be around the world and get different experiences.
That's amazing. So our next panelist is Gabriela. Gabriela, could you introduce yourself?
Thank you. Yes, so my name is Gabriela de Quiroz, and I'm a principal cloud advocate manager at Microsoft. So my focus is on AI, ML, and data science, and our customers are the students and educators. And I'm very excited to be here with the panel, sharing a little bit about like my knowledge and my wisdom, I would say. But I'm originally from Brazil, so you can tell it's very fun that we have people all over the globe here. I'm originally from Brazil, but based in California.
Awesome. So, and I saw that you have an inspiring community contributions all over the years. Can you share your experience from founding Our Ladies and AI Inclusive?
Yes, I love community. I love to build community, to be involved with communities. Our Ladies, let me talk about Our Ladies a little bit. So R, as some of you might know, it's a programming language that was created by statisticians and for statisticians a long time ago. But nowadays R is being used by different people, like you can say like data scientists, data analysts, journalists, biologists, like from all over the domains. And Our Ladies is our organization to bring more diversity into the AI community. So I founded Our Ladies in 2012, and it's a huge community. We are in over 60 countries, in more than 200 cities across the globe. And we have over 100,000 members, so it's huge. And AI Inclusive, it's another community which is more focused on AI, where it's language agnostic in some way, so there is no language. But the idea it's very similar when we are trying to change the landscape of AI. We are trying to bring more diversity. We are trying to empower communities to get into AI and try to make the difference in this area.
That's fabulous. And I'll just interject and say congratulations on Our Lady celebrating its 10th anniversary this year. That is such a huge accomplishment, and it's so amazing that it's impacted so many people from all around the world. And now I'll pass it back to Fortini to continue introducing our amazing panel.
So, Noah, hi and welcome to the studio. Can you tell us a bit about yourself?
Sure, yeah, happy to be here. My current role is at Duke in the data science program and also in their AI program. And a lot of what I focus on is building out curriculum for MLOps. I don't know if there's a little bit of an echo. Is that on my end?
Sounds great for us.
Oh, okay, it sounds great for you.
Yes.
Okay. But yeah, most of my work is really on operationalizing things, and that's, I think, a very interesting focus now in industry is that there is a lot of the initial work has been started with data science, and many of the things that we're doing are really like a laboratory. And just like you wouldn't go into a laboratory and, I don't know, start trying to make substances out of the laboratory to sell in a retail store. Likewise, the same problem exists in machine learning AI, where we have some rough edges, and really there's, I think probably 2023 is going to be the year where there's going to be a huge operationalization methodology, probably because of recession as well, where there's going to be a focus on really traditional software engineering approaches to machine learning. And that's really the stuff I'm focused on.
Thank you. And we saw that you have published so many technical books. We would love to hear about your experience publishing technical books.
Yeah, so in terms of technical books, I would say it's an interesting process because on one hand, it isn't necessarily like a very lucrative thing to do. So a lot of times after I write a book, I'm like, why did I do this? But I think part of it is that it's kind of a fun thing to at least write one book, and I think more books that are written, the better. And I think anybody that's in the technical field can write a book. There isn't really a unique trait involved with writing a book other than just doing it. And in some sense, it's an excuse to just work hard for a short period of time, or to learn something. A lot of times, if you're able to, write down all the different things that you're learning, that type of mentality is one of the best types of books to read, because of the fact that you're approaching the subject from a learner's mind. There's an expression called the expert blind spot, and it's really true in that the deeper the expert is, a lot of times they are missing what they're explaining to you. And it's talked about a little bit in is it Daniel Kahneman's book about thinking fast and slow, where there's type 1 and type 2 thinking. Basically once you know something, then it's automated. But if you're learning something, you have to actually really pay attention to the details. And in fact, that's actually one of the best types of authors, is someone who doesn't really understand all of the things that are going on, and they're really careful about explaining it from a beginner's mind.
So thank you. And our panelist is Adlit. Hi, Adlit.
Hello.
Could you?
Hello. Hi.
Hi. Could you also introduce yourself?
Sure, yes. So I'm based in London and Oxford. I'm a course director at the University of Oxford, and the course we teach is artificial intelligence, cloud, and edge implementations. As it says on the box, it's a full stack AI course, and we've been teaching that since about 2017. So we have a fairly good detailed experience of both the algorithmic side and also the MLOps side. So in terms of, I'm also a fellow at Oxford, so and that's on the engineering sciences side of things. So that's a little bit different. But I guess that's the best way to define what we do. And in many ways, Oxford's a very collaborative thing. So for example, we're looking at something about AI with quantum. We're looking at AI with cybersecurity. I'm involved in AI with digital twins. So it's like they kind of a branch out with different areas, and these are collaborations within other professors at Oxford. And this is our focus. That's what we do. Yeah.
And we have a final question and for you. So you do a work in a really innovative AI spaces, including digital twins, metaverse, and quantum computing. What has been your most favorite application of AI throughout your career?
Aha. Okay. Um, so I think so. You asked me the most favorite application of AI. Is this correct?
Yes.
Okay, so I think that the most favorite application of AI, which is very hard, which is what I'm trying to do, and I've been working on it for about 3 or 4 years now. And this is something which I think Noah mentioned about System 1 and System 2, Daniel Kahneman, and so on and so forth. And we are trying to use AI to detect phenomena called cognitive dissonance. So cognitive dissonance is not deception or not lying. It's when you're conflicted. So it's a very complex phenomena for AI to detect, because you have to sort of do multimodal analysis. You have to sort of do almost what Kahneman was saying, that there's a very interesting video which talks about Yoshua Benjo saying that it is not possible for AI to detect such a phenomena. And I think that that's one of the things I've been working on for the last 4 years, working on the research paper on that subject. So it's good fun. Hopefully I'll get there.
That's absolutely amazing. I really appreciate all of you introducing yourselves, as well as giving a little bit of like fun facts about who you are. And that was actually a fantastic kind of bridge into our next conversation, which is like kind of first projects in AI or advice for those learning about AI for the very first time. And our very first question is for Gabriella. What are the first projects you did at school or work in the AI artificial intelligence space?
Yeah, that's an interesting question. I think when I was in school, we didn't have AI, even like data science. I'm a statistician by training, so I don't think we exist as a title anymore. Like we all became data scientists or some kind of like AI engineer. But at work, this first AI project, I don't know if it was a project or was like I was trying to learn how the whole AI works, and I would get some pre-trained model and then use on my own and see the application. So I did a lot of like understanding so I could teach later on. So that was kind of like the project, like object detection, some kind of like object detection, but always kind of like reusing something that other people did, because it was like an easy way for me to understand how AI works without like needing a lot of like infrastructure, for example. So that's how I got. I remember pretty much the object detection was the one that I stuck with me. That I was impressed. I was like, wow, this is amazing. I had no idea that we could do things like this. And then seeing the whole applications of like different areas. So that's what I did.
That's amazing. I think even like the thing of like looking at what others have done, even like I remember going to my very first hackathons in college and seeing what like the winning teams are doing, super innovative stuff. And I was like, wait, is that something I'm capable of doing? So extremely relatable.
So how about you, Noah? What are the first projects you do in your school or the work in AI?
Yeah, so I am a strong believer in building end-to-end prototypes, and I would recommend, and I do teach this actually for the classes at Duke, is I recommend students immediately build Indian prototypes. It could be data pipelines, it could be MLOps pipelines, it could be Streamlit or Gradio applications. And one of the nice things about building an Indian application is that you care less about the technique and more about the goal at the end. And a good analogy would be if you're walking into Costco, you could put on several different roles. You could go into a Costco and you could become like a restaurant, right? You could go into Costco and buy 50-pound bags of flour and then 50-pound, bags of salt and, essentially make a restaurant that creates pizza. You also could become a vendor, right? You could actually do, catering, and you could buy a bunch of frozen pizzas, and you could actually go out the door and you could do that. You could also just be hungry and decide to, on the way out of Costco, go to the pizza place and just get a slice of pizza and eat it, right? They all are essentially the same thing, but they're just different forms of pizza. Similarly with AI or machine learning, that it really depends on what it is you're trying to do. But if you care less about what it is that the technique initially, and you build a prototype, you can get to a solution much quicker. And in some sense, I think even the shorter the time frame, the better. Where if you could build it in like a day, or you could build it in 2 days, it really can harness your ability to create a solution. So I think pre-trained models with Hugging Face and using things like GitHub code spaces to fine-tune it because they have GPU has been really an effective way for students to build compelling prototypes in the courses I teach.
And I think you also lead the multi-cloud certification program for students. Are there any certifications you recommend students consider when learning AI?
Yeah, I do recommend that. I think students should try to get at least a couple of the solutions architect certifications. So not just one cloud, like get an Azure certification, that's solutions architecture, get a AWS certification, maybe get a Google, doesn't matter, get one of those, and then also get a couple for machine learning for clouds as well. And so in terms of machine learning, I've actually worked on courses on all of the machine learning products for the major clouds. So I've built something for Azure Associate Data Scientist, which is essentially like a machine learning engineer certification. I've also built some material for Google Professional Machine Learning Certification, which I think is also pretty good, and also AWS Machine Learning Certification. I think any of those machine learning certifications are great. And so I think those are probably if I had to start, is solutions architect from any cloud, machine learning certification from any cloud. That's a great place to start.
I think that's absolutely amazing. And now our next question is for Kevin. And so you have experience and expertise in both like the professional and in the academic space. So I'd love to hear what your advice is for students who are looking to get their first experience or skills in AI.
Yeah, perhaps the best thing is in today's day and age, you have so many options open to you, and it kind of depends a little bit on the type of person you are. There's so many different trainings and certifications, like what Noah's talking about. Even NVIDIA, we offer different certifications and trainings. There's so many that you can get. I mean, you can learn everything on the internet, if you go out there and find it. And if that's sort of the way you like, if you like to be independent and you like to chase the things that you're interested in, by all means do that, because you can find the projects, you can get involved in Kaggle competitions, you can do all that. But if that's not, that takes a lot of self-motivation, and maybe you'd rather work together in a community like what Gabriella's doing, where there's people that come together and you're doing things together. And, maybe you're the type of person that needs a little accountability, be with your friends, or have a meeting every week that gets your butt in a seat that you're going to do it, And so, especially through these community actions or through your school, there's so many different classes you can take, of course, but all the student organizations. So there's so many different ways to get involved and to learn. and find which way works for you. Go that independent route if that's you, go the social way if you want to be together with people. But the information is out there, and there's so many different ways that if you're excited about it, you're sure to find some interesting way to get you those skills. So keep trying different ways and find what works best for you, and just keep trying because it's super fun.
Thank you. And so let's go next to Adlin. So, as the director of the Artificial Intelligence course at the Oxford University, what advice do you have for students that they want to get their first experience in AI?
Sure. So I think that what I see is that you should be ambitious, and what I mean by that is now I think as Gabriela said and a couple of other people said, there's so much choice, there's so many things you can do, and the point is that you don't want to do something very simple with everybody else is doing. Don't just get a sort of the Boston housing data set and try to do that. I think that it's more interesting to choose a problem which you like, to choose a complex problem, and I'm not talking technically complex, just do something which is unique, to something which you can showcase out there, and then build up on that, on that end to end, meaning that you try to say that this is how an end user would use it, not just the ML part, but put it in Flask, put it on a website. How would you serve the model, that type of thing. So this would be my advice, and I think that to a large extent, I mean, it's a great time to be learning today, because there is so many resources out there, as we've been saying as well, and also there is so much support. Again, like we've been talking about the various communities and the various forums and the various approaches. So I think that I think the world is a good place. I mean, the world is a good place if you're learning something now, and it's a supportive place. And I think you should leverage on that if you're just starting out, and you should be ambitious, is what I meant here.
I think that advice is extremely valuable, and I think is also, once again, a fantastic bridge to our next topic of conversation, which is like the skills and interests students should develop in AI. And Noah, our first question is for you. And so you teach a wide variety of classes in AI, machine learning, MLOps, AI, data science. Are there any skills or areas of AI that you think are especially important for students to learn?
Yeah, that's a great question. I think one of the most underutilized skill is DevOps. And the reason why DevOps is so important is that you can never have too much. And the more DevOps you know, the better you will be at AI, the better you'll be at data science. There's essentially no upper bound. And the reason why it's so important is it's about really two things. It's about automation, and it's also about data science. And believe it or not, DevOps is, in a sense, one of the most prolific forms of data science in the software industry, because in order to understand what's happening with the software system, you have to have monitoring and instrumentation, you have to have load testing, you have to look at your system and understand latency. This is data science. There's no other way to put it. It's a classic data science problem. And a data scientist, in a sense, can really thrive with DevOps because all of those skills you have in mathematical understanding, the foundations, plotting things, it really comes in handy for data science, which is about understanding how things work and automating things. Likewise, once you understand the entire point of DevOps is to make things automated and improve, that's also very similar to data science, in that the whole point of machine learning is you train a model to get some kind of outcome and you improve it with more data or better techniques, etc. Same with DevOps, is you more and more automate things, you get less tools, simpler workflows, faster deployments. And so it I think is one of the most under-taught aspects of software engineering. And in fact, it's very straightforward to learn DevOps. And so I would encourage people to start there. I think that's probably a good place. The other skill I would actually agree with AJ here is that I think the other thing that is missing is sometimes the passion. So if you want to stand out, you should pick a project that you're very interested in, and it should be something that's unique. Fortunately, the world is full of very complex problems that do need further insight. We have, misinformation problems. We have income inequality problems, global warming. We have, gun violence problems in the United States. We have just so many problems that would benefit from people really doing comprehensive analysis that's based on passion. And so I think if I had to pick two things, it would be that is be passionate about something, pick a real problem that helps solve the world, and then also get very, very good at automation and DevOps.
And I actually have one follow-up question for you there. And I think because DevOps and MLOps are words that we've heard throughout the day at the Global AI Student Conference. So I'd love for our beginners in the audience explaining what makes MLOps and DevOps similar and what also makes them different.
Would you like me to go, or?
I would love you to go, Noah, but if anyone else has commentary, feel free to jump in as well.
I mean, I could start with like a 30-second summary, which is that if you don't have DevOps, you don't have MLOps. I think that's the first heuristic. So if you're saying you're going to do MLOps, but you don't do DevOps, you have to start there. Once you have DevOps, then really the next part is what are the parts of data science that can use those same techniques, and that would be the model and the data. And once you have the model and the data also automated, and you have instrumentation and logging and automatic deployment, then you're essentially doing MLOps.
So can I go next as well? Yeah, sure. Yeah. So what I see it as what I in a very simplistic terms, I see it as CI plus CD plus CT. So CI is continuous integration, CD is continuous deployment, which is the traditional DevOps piece, so CI and CD. And then you have CT, which is the continuous training, because the whole point about MLOps is that you build a model and deploy it, but then it suffers from data drift or various other forms of sort of mismatch between the real world and what you build it on. And therefore the goal of the MLOps space is to create that feedback loop where you are able to trigger the retraining process. So in my mind, it is CI and CD and then CT on top. So this is how I see that.
Yeah, the other interesting thing on this is MLOps is newer, at least the term. It's newer than DevOps. So like we all heard throughout the past years about DevOps, it was like more common, especially in the industry, to have a DevOps person, someone that would be hired as a DevOps and doing the whole infrastructure for the development. And usually this person would sit within the engineering team. And as the machine learning models got more complicated, more sophisticated, and more data, we kind of like branch off DevOps to MLOps. So now we have all this branch nowadays. There are courses and classes on MLOps. And before we didn't need, because we as a data scientist, we did a lot of like offline modeling. So we would not do in real time. It was like we didn't have enough either computer power or enough even data to do something on that scale. In so big and something huge. So MLOps is like you can see more and more being introduced also as a role inside companies.
So thank you. Our next question is actually for you, Gabriela. And we saw that you have experience in both AI and open source. How do you think the skills of these fields intersect?
Oh, there is a lot of intersection. In pretty much everything that we do in AI or everything that we use in AI is based on open source projects. So I'll give you some examples. So TensorFlow, like we use TensorFlow, we use PyTorch. There are so many other open